Hey everyone, I hope you have attempted the KillerX mock test. So in this video, we will discuss all the solutions of 65 questions. And yeah, I know the test was on the difficult side because I and Himanshu sir, both of us together set the paper and we know it was on the difficult side. So don't worry if you have got low marks or if you have not got whatever you wanted to get, right? Whatever marks you wanted to get, like let's say 50 plus or 60 plus. So of course I cannot comment right now because I am just recording this before the mock test has gone live. So don't worry, we will come live at 7 p.m. today itself and discuss everything, like what shall be save marks in this particular paper, how should you prepare, like in the next 2 weeks, what should you do, all those strategy and guidance we will discuss. Roughly I can just give you an estimate. If anyone is scoring 50 plus, that is my assumption, that if anyone is scoring 50 plus in this particular paper, then he or she can assume that they are safe. Whatever they are doing it great, just continue doing it. But more information I will give you at today's life, right? Because people have not attempted. This is just my own assumption and calculation that I am doing. 50 plus is a great marks in this particular mock test. So yeah, do come on this live session. We will discuss everything, every strategy and everything. Also, like if you are lagging behind in any particular topic, right? Any particular topic. So we will also discuss that in live session as well. That you can obviously from where you can refer to those things. And let's say in our website we have few free courses that are already there. Okay, these are free, no nothing paid, right? So you can go onto these courses on our website, right, and study those particular topics in which topics which you feel you're weak on, right? Also we have uploaded revision x notes, revision x notes. So make sure you download those revision x notes. Those are also free in this free courses tab. If you go on our website, just at the last particular section, right, you will see a revision x. So you can click on that. That is basically short notes by PrepFusion. So make sure you download that. How can you use it? How can you use it? Basically you download it, right, and from that you make your own short notes. That is a reference, and from that you make your own short notes. That is a point one. Point two is we have obviously our RPYQ series as well. So make sure you are following the RPYQ series to revise. RPYQ series is nothing but the revision series of PrepFusion. On playlist itself is there. First video will tell you exactly what is the RPYQ series. That is also completely free. You can go there, right? So these are the things that I wanted to discuss. Now let's start with the first question of the examination. Consider a 5-digit number A, B, C, D, E formed using digits 1 through 5. Okay, so they are all, each digit is used exactly once. That means each digit is unique and the following conditions are given. A is less than C, B is greater than E, D is less than B and less than, okay, so these are the conditions. Then what is the value of B? So A is less than C, right? And I can see C is here. That will not help me. And A is less than E as well. So A is both less than C and E. Okay, this is one thing. B is greater than E. So B is greater than E. So B would be lying somewhere here. Okay, but B is less than C actually. B is less than C. So if B is less than C, that means C has to go here, right? So actually in this kind of questions, always try to solve with the best, like where most of the information is given. So C would lie here. Okay, because C is greater than B and D is less than B. So D can actually lie here somewhere here. Okay. So it seems like C is the highest. Okay, because I have total 5 digits. C is the highest. B is the second highest. That is for sure. B is the second highest. So B would be certainly 4. Okay. B certainly would be 4. Again, if you are confused, again you satisfy whether this particular inequality is satisfying all your conditions. So A is less than C, yes, A is less than C, true. B is greater than E, yes, B is greater than E, true. B is less than C, yes, B is less than C. B is greater than D, yes, B is greater than D. E is greater than A, yes, E is greater than A. So whenever you are confused, first form the relationship inequality and then you check the conditions where your formed inequality is actually correct. Is it satisfying all the particular conditions or not? So here 4 would be your correct answer because B is the second highest number I have 1 through 5, so 1, 2, 3, 4, 5. 5 is the highest, 4 would be the second highest. Identify the option that has the most appropriate sequence such that a coherent paragraph is formed. P. As a result, many of them were forced uh, to abandon their plans midway. This does not seem like a starting point. They believe that the journey would be simple and success. Again, no. However, the harsh terrain, again, no. When the announcement of a new trade route was made, countless merchants set out immediately in search of quick profit. So this seems like a good starting point. Okay, so I see an option B and option C, S is the starting point, right? Then I have either Q and R. So I will read Q and R. So they believe that the journey would be simple and that success was guaranteed. However, harsh terrain, lack of resources, and unpredictable weather soon proved otherwise. So you can see, like, of course, your option B is totally matching your sequence, right? You can read the last statement as well. It will totally match your sequence. So it's very simple. Option B is your correct answer for the question. Consider the relationships among A, B, C, D, E. Okay, so A is the father of B. So let me draw the tree diagram or family diagram. So A is the, let me change the color. A is the father of B. So B is here and A is here, right? And A is a boy. So I can write A as plus. So plus basically for me means boy, and minus basically means for me, minus basically means that it is a girl. So A is the father of B. I don't know what is the gender of B. C is the wife of A. So A and C are wife. So this double arrow basically means they are married with each other. D is the son of B. So D is the son of B. Okay. D is the son of B. So D certainly is a boy. E is the sister of D. So if they are sisters, then I will not do that arrow wala thing. I will just do this. So D, E is the sister of D. The following statements are made based on the relationships given above. C is the grandmother of D. C is the grandmother of D, certainly yes, because C is also mother of B as well, right? So if they are father sons, I can actually get a arrow. So if C is the mother of B and E is the daughter of B, then certainly C would be the grandmother of E. Certainly that is correct. Sorry. Oh yeah, same thing. C is grandmother of both D and E because they are both brothers and sisters. So this first statement is certainly correct. A is the grandfather of E. Again, this statement is again correct, right? Because we can see B is the father of A. Sorry, A is the father of B, and B is the I don't know what is B. Either B can be mother or father, does not matter. But ultimately, it is either father or mother, right? So A is grand father of E. That is certainly correct. B has only one child. No, B certainly has two childs, right? You can see B has a son D and B has a daughter E. So B has two childs. So statement 3 is incorrect. C has only one son. So according to the information given us, C has only one son. Okay. I will not be able to comment whether C has only one son or not, because what is the problem here? The problem is I don't know the gender of B, right? B can be the girl or daughter. Sorry, B can be the girl or a boy. So if B is either a girl or a boy, so C can have only one daughter. That is also another possibility. There are two possibilities, right? C has only one daughter or C has only one son. So there are two possibilities. So I cannot surely say that this statement is 100% true, right? There are two possibilities. So both 1 and 2 are true. Okay. So option A will be the correct answer for this question. Based on the conversation below, identify the logically correct inference. Even if I had been informed about the meeting in advance, I would not have attended it. So even if, like, Arjun had been informed regarding the meeting in advance, still Arjun would not have attended the meeting, which is the correct inference. Arjun was informed about the meeting in advance. Does not seem like it, because Arjun is saying even if I had been. So he wasn't, right? Even if he was, then he would have not joined, but it's not like he was informed, right? He's saying even if I had, right? So he was not informed. So Arjun was not informed about the meeting would be your correct answer for this question. A stationery store sells four distinct types of pen. So I have four distinct pens. So P1, P2, P3 and P4. Now a customer can buy any number of pens of each type. So basically I can buy P1 four times, right? So 4 P1 I can do, or 3 P2, 1 P1 I can do. So any number of pens, there is no limitation. And the order in which the pens are selected does not matter. Let's say first I choose 1 P1 and then I choose 1 P2, then I choose 2 P1, right? And for example, let's say first I choose 3 P1 and then I choose a P2. This order and the previous order, whatever I explained, those are the same. Order does not matter. If the customer wants to buy 3 pens, so I want to buy 3 pens, in how many different ways can the purchase be made? So basically I have 3 box to fill, right? I want to buy 3 pens. In how many different ways can I purchase? So he will say, sir, I will select 4C3, right? Because order does not matter. I will select 3 pens and that will be my answer. And you will be wrong, because this will only consider the case when I am choosing all the 3 pens to be distinct, right? This does not take into account that I can choose P1 thrice, correct? So this is the case that is certainly true. 4C3 is certainly one of the correct answers. That is, I can choose case 1 where all pens are distinct. All are distinct, right? So that means basically I will have P1 here, P2 here, P3 here, right? Or I can have P2, P3, P4, something like that. So when all 3 are distinct, so out of 4 I have to choose 3, right? It will be 4C3. That's very simple. Now things change here. As soon as I move, I change the case. What case I make? So let's take another simpler case, right? Or let's take a bit of difficult case. The case is that 2 pens will be same. Here all of them were distinct, right? 2 of them will be same. So let's say 2 of them is same, right? So basically now be very careful. Okay, be very careful. You cannot simply use this. This is used only when the number of boxes that I need to fill are equal, right? So I have to choose 3, so it will be 4C3. But here I'm just giving you a example scenario. I have chosen P1, right? So P1 will be chosen twice, and then I can choose any other pen, let's say P2. So this is also a valid way to buy the pen, right? Because I can choose a single pen any number of times. Like this, I can have P2 here twice and then I can choose P1. That is also another possibility. That is a different arrangement, correct? So how do I do this? How do I solve this? So what you do, first you select a pen. First you select a pen which will be bought twice. So let's say I have total 4 pens, right? Out of 4 pens, I select a pen which will be bought twice. Then in this particular box, right? So I hope you understood the example. So to choose a particular pen, right, out of 4 pens will be 4C1. Now, what is the option that is left in this particular box? How many ways can I fill this particular box? How many ways? It is 1C1, because I have to choose one pen and I have only one option. If I have chosen here P1, then I will choose P1 here. If I have chosen here P2, then I will choose P2 here. Like that, right? Again here, what will happen? Now, how many options are left? 3 options are left, right? 3 options are left. Out of how many I have to choose? 1. So total, what will be the answer? This will be 12. Now you might have a very good doubt. Sir, we could have done it like this, because you are saying 2 pens are same. Yes, you are correct. You are saying 2 pens are same. Then sir, what you could have done is just select 2 pens, right? Out of 5 pens, just select 2 pens. And one of the pen will be repeated, P1, P1, and the other pen will not be repeated. That's it. Just 2, because we're ultimately we're choosing 2 pens. You are correct, but this particular thing, right, and this particular thing, both are different. Both will give you different answers. Here, what I will get, it will be 5 into 4 upon 2, that is 10. Correct, 5 into 4 upon 2, that is 10. So not 5 into 4, sorry. This will be 4C2. I have 4 pens, right? Sorry. Four into 3 upon 2, that is 6. So what is different here and here? The difference is here, let's say one selection, right? P1, P1, P2, and the selection P2, P2, P1. Are these different? Yes, these are different. But in this case, you are choosing 2 pens, right? So you can either choose P1 and then P2, or you can either choose P2 and then P1. Are these same? In this particular case, when you are using this formula, I hope you have studied P and C. In this particular case, because arrangement does not matter, they are the same. They are the same, right? Because we have considered only one case for this, because they are simply swapped. So be very careful while using this PNC formula when your boxes to fill in is more, right, and like it's a bit different. So do it step by step. Do it step by step. So that's why it will be 12, not 6, because the reason being P1, P1, P2 and P2, P2, P1, these two are different arrangements. But in this case, these two are same arrangements. Got my point? Now, either two of them can be same, right? All three are distinct, and obviously the final case, the easier one, where all three are same. Correct. So when all are same, so what is 4C3 basically? 4C3 is basically nothing but 4. So when all are same, that essentially means that in all the boxes, the same pen will be there. So if I choose one pen, right, and I fill it up, so in the other one, I have only one option, 1C1, 1C1. That's it. Correct. So yeah, it's not that difficult. 4C3. I'm just thinking one thing. 4 to 4 pens, I choose 3. Arrangement does not matter. Yeah, they're all distinct, right? 4 by second arrangement. Yes. Okay. Yeah. But technically, like, you have to choose only one pen, right? And then you have to repeat it. So it will be 4 as well. So your overall answer would be what? Overall answer would be 4 plus 4 plus 12, that is equals to 20. And trust me, if you see the solution of this question, right, anywhere in the internet or something, you'll always get a formula. They will always show you a formula. They will not tell you how this was solved, right? I have told you the method how to solve. So your answer would be 20 for this question. If stone and water are coded as such, then which of the following is the most appropriate for plant? Okay, so there are 4 options that you can see. I have not copied the options. What essentially you'll do, you can see what are the common words, right? I can see that I have in this word, I have A. So A is coded to, if you see, Y. Okay, and I have also N. N is coded, so A is coded to Y. N is coded, I can see N is coded to Z. Sorry, N is coded to L, right? And your T, if you see in the second letter T, T is coded to R. Okay, so I see that the last 3 letters must be Y, L, R. Okay, last 3 letters must be Y, L, R, and that I can see only in option. Like I don't have the options here, but I have kept the option as C, where the last 3 letters are Y, L, R. So that will be your answer. But if you want to understand it more thoroughly, what you can do, you can obviously write down the numbers, write down the positions, and you can see the pattern. The pattern here is simply -2, right? So with all the letters, I'm subtracting 2 digits. So if, let's say, for the first letter it is S, right? So S, if I subtract 2, I will reach here, that is Q. So you can see the coded letter to be Q. So you can follow the same pattern for all the other letters, and you will just subtract 2 from each letters, right? So you will get your coded word. So here option C would be your correct answer for the question. In the given figure, ABCD is a square of side 3 centimeter. So ABCD is a square of side 3 centimeter. AEFG is a rectangle where E is the uh, point that lies on the side BC of the square. Side FG of the rectangle passes through the corner D of the square. The sides of the rectangle are parallel to the sides of the square. Uh, Sides of the rectangle. I think this statement should not be there. Sides of the rectangle are parallel to the sides of the square. What are they asking? They're essentially asking me what is the area of the rectangle AEFG. That is what they're asking me, right? So this is 3 centimeter. This whole thing, it is a square, right? So this is also 3 centimeter. Correct. Now, if I have, uh, let's assume these to be my theta. Correct. So this is the base, right? And what would be this side? So my tan theta, do I need tan theta? Do I really need tan theta? I'm just thinking about that. Okay. Uh, okay. This will be, so this is how, what angle? This is 90 minus theta. 90 minus theta. And this is 90, right? And so this whole this angle would be what? 180. Sorry, hold on. So yeah, what will be this small angle? This will be 180 minus this angle, right? So what is this angle? It is 180 minus theta. So this angle is also theta only. So add all these angles. Do I get 180? Yes, you get 180. If you add all the angles, you will get 180. So angle of a straight line is 180 degrees. So this will be theta. This will be again 90 minus theta, correct? This will be also 90 minus theta. Like, what do I want? I essentially want, so this particular side is how much? Let's assume that this side has a distance of x. So this will be how much? This will be 3 minus x, correct? This will be 3 minus x. Okay. I'm just trying to get any information regarding the sides. Okay. This is 90, this is 90. 90 minus theta. Now this is also 90 minus theta. This is also 90 minus theta. This will be theta. This is theta. This is 90. Right. So this will be how much? This will be again 90 minus theta. If this is 90 minus theta, this is again theta. But what will that help me achieve? If I know this theta angle, what will it help me achieve? So this is, let's say, okay, let's assume that this whole is x. Let's not assume that, and let's assume that this whole thing is y, right? So 3 cos theta would be y. Okay. Okay. So this is x, right? It is a rectangle. So here this is the hypotenuse of this particular triangle. So x into cos theta, x into cos theta would be equals to what? Would be equals to 3. What about here? So this is my hypotenuse here, right? This is my hypotenuse. So this is what? This is 3, right? So 3 into cos theta would be equals to what? Y. What do I have to find out? I have to find out the area of the rectangle, that is x into y. I have to find out x into y. So what? Okay, they are very talented. So your x is what? X is 3 upon cos theta. And what is your y? Y is your 3 upon, hold on, y is your 3 cos theta. So your areas are actually same. So x into y would be simply equals to 9. So the area of the square and the area of the rectangle are actually same. So option B would be your correct answer for the question. Two cyclists A and B start simultaneously from point O from 9 a.m. onwards. So we two cyclists A and B are starting at 9 a.m. onwards. Cyclist A travels south at a constant speed of this much. Cyclist B travels west at a constant speed of this, but halts for some time after riding for 1 hour. If both the cyclists are at same distance from point O at 10:45 am, how long did cyclist B stop? So essentially what they're telling me that both the starting point is same and they are essentially measuring the distance. So let's say if this is my north, right? So we are starting, okay, hold on. If we are starting from point O and we are moving, cyclist A is moving to north and cyclist B is moving to west, correct? And they have not mentioned anything regarding cyclist A. So assumption is cyclist A does not stop. Sorry, cyclist A is going to south, not north. So if cyclist A does not stop, how much distance has A covered? So it will be speed of A into the time, right? What is the time? Time overall is how much? So this is in hours, how many it is? So we are starting from 9 a.m., right? So it is 1 hour and 3/4. So it is simply 1.75 hours. I hope you got the point, right? How I am getting 75, that is 45 upon 60. Essentially converting this minutes to hours. That's all. So 1 hour, 1.75 hours. So this would be 20 into 1.75. So it is actually 9 upon, no, not 9, 7 upon 4. Am I correct? If I do 7 upon 4, what is that? That's 3 into 7. Yeah, 7 upon 4 is correct. So this will be equals to 5, that is 35 kilometers. So B also has to cover the same amount of distance because essentially it is just a straight line. We're measuring the distance. They're telling me that B also has covered the same distance from point O. So B also will cover the same distance, right? So for how much time B needs to travel to cover this distance, because the remaining time has been wasted in taking rest. So we can directly calculate it. So it will be SB into TB will be equal to 35. So TB would be equals to 35 upon SB. SB is given as 24. Right, that is equals to 35 upon 24. That is 1.4583. So essentially it means 1 hour and 0.4583 hours, right? So if I want to convert this into minutes, 0.4583 into minutes. So if I want to come back to convert to hour, what I did 45 by 60, right? I will do the opposite now. Essentially I will multiply this 0.45 into 60, that will convert this into hour, into minutes, sorry, into minutes, right? So I hope you know how to convert from hours, minutes and stuff. Now B travels for this much minutes, right? And they are telling me that they are at the same distance at 10:45. So how much, so what is the amount of time for which B can take rest? Because certainly in this whole duration of 1 hour, or let's compare this particular thing, right? In this whole duration B needs to travel, right? So what is the rest amount, what is the rest period? Because in 1.75 hours both of them must reach the same point. So the difference being the rest period, right, x would be equals to 1.75, right? That is at 10:45 am minus 1.45, because B travels faster, so B will reach this distance faster, but certainly B also takes a rest, right? That's the point. So B takes a rest, so the amount of rest would be total duration minus the duration of travel. So this would be 1.75 minus 1.75 minus 1.4583, this into 60, right? I will convert this into minutes. So it will be approximately 17.5 minutes. This will be your answer for the question which is present in option B. Many students will make a mistake. that they will assume this, right? They will just convert this 0.453 into 60. That is wrong, right? So yeah, don't do it. So they will assume that, okay, I have only traveled for 1 hour 27.5 minutes, and like they will make some mistake. Don't make the mistake. Actually, what is the total duration? Total duration is 1 hour 45 minutes, right? Total duration is 1 hour. Here, from here also you can do 1 hour 45 minutes. So what is the difference duration, right? That is what you have to compute. That is 17.5 minutes. This will be your answer for the question. A postgraduate applicant applies to two universities, University A and University B. Based on her profile, she estimates the probability of receiving an admission offer A to be 0.7. Okay, so probability that A event will occur, right? Receiving admission on university, like, yeah, receiving an admission in A would be 0.7, receiving an admission in B would be 0.5. Let X denote the probability that C receives admission in both universities, basically A intersection B, right? That is X. Then basically the most appropriate range of X shall be equals to what? Now I don't know anything regarding A and B. Are they independent? Are they not? Are they dependent? I don't know anything, right? So how can I compute the range? So what is PA intersection B? So we know this formula, right? PA union B is equals to PA plus PB minus PA intersection B, right? So essentially your X is equals to PA plus PB minus PA union B. Okay. Now what does A union B mean? So if this is my Venn diagram, this is my A and B, right? So I certainly know what is my PA and PB value, right? So let me put those values. PA is 0.7, PB is 0.5. So this will be 1.2 minus PA union B X. Can you tell me what is the maximum value of PA union B? So if this A union B covers the whole Venn diagram, that is 1. If you cover the whole Venn diagram, it will be 1, right? That is the maximum value of PA union B. So X would be equals to X minimum, right? Minimum value of X would be equals to 1.2 minus 1, that is 0.2. So I see the minimum range that is present only here. That is a minimum, right? Minimum, because PA union B will certainly be always less than 1, less than or equals to 1. Okay. So it will be always less than or equals to 1. So if I'm subtracting something less than or equals to 1, then this value will only increase than 0.2. So X will always be greater than 0.2, that is certain. But how do I compute the larger limit? So we got the lower limit, right? How do I compute the larger limit? So PA union B is this. Of course, PA union B, it cannot be 0. I have chosen the maximum value, that is 1. It can be somewhat less than 1 as well. Now, what is the, do you know what is the minimum value of PA union B? PA union B. The minimum value. Do you know what is the minimum value? So the minimum value would be actually equals to minimum of PA comma PB. Why so? So basically this can be a possible scenario, right? Sorry, not minimum, maximum. Where A is totally inside B. So what will be PA union B? It includes both. It includes both A and B, right? So I will have to choose the maximum of PA comma PB, right? So maximum of PA comma PB in, like, basically I'm just choosing a case where PB is highest. Okay, so basically my A is totally inside B, right? So there can be another case as well. What will be the other case? Other case would be this one, where my B would be inside A, right? This can be the case. What is the PA union B? That is PA only, right? Because B is already inside A. So PA union B would be PA, and here PA union B would be PB. So basically, essentially, I'm choosing the highest value. Highest value. So the minimum value of PA union B would be actually maximum of PA comma PB. So that's how you can conceptually understand it. So here this will be actually equals to maximum of PA comma PB, that is actually equals to 0.7. So your X max would be 1.2 minus 0.7, that is 0.5. That is the highest value that you will get. You will not get anything above it, right? So X will vary from 0.2 to 0.5. So option B is certainly correct. Okay, it will not, because you have to see that this is the minimum amount of value that you will get. Okay, why this is the minimum? I have given you the total explanation why minimum. And when you're getting this minimum value, right, so this negative is minimum, that means your X will be maximum. Okay, just the opposite, because negative sign is there. So certainly this will be 0.5. So 0.5 will be the highest value, 0.2 would be the lowest value, that is option B. The stamina level of a runner can be expressed as a function of their age. Okay, so basically I'm expressing the stamina level of a runner as their function of age, right? This function varies from person to person. The function varies from person to person. Suppose this function is identical for two sisters. Okay, the function is identical for two sisters. Okay, and it monotonically increases up to the age of 35 years and then monotonically decreases thereafter. Okay, identical, it monotonically increases. Let A1 and A2 denote their ages of the sisters on a particular day. Which of the following is correct about their ages on the day when they have the same stamina? Okay, so if they have the same stamina, right? So basically the function that they are talking about, it follows this curve. Stamina function, it essentially follows a Gaussian curve, right? So till 35 it is monotonically increasing, and after 35 it starts to decrease. This is the age and this is the stamina. They are telling me on a certain day they have uh, uh, let A1 A2 denote the ages of both the sisters on a particular day with A1 less than A2. So A1 is certainly less than A2. Which one of the following is correct if they have the same stamina level? If they have the same stamina level, right, if they have the same stamina level, that basically means that this level must be same, right? And certainly they have told me that A1 is less than A2. So it could have been that both of them are of same age and they have the same stamina level, but they have already ruled that out. A1 is less than A2. So if A1 is here, where will A2 be? They have the same stamina level, A2 will be here, right? So I can see A2 is certainly greater than 35 and A1 is certainly less than 35. So A1 would be certainly less than 35 and A2 would be certainly greater than 35. So option B would be your correct answer of this question. Let A be a non-singular matrix with real entries. Okay, so A is a non-singular matrix with real entries, and A and B are obtained by interchanging two of its rows. So B is obtained, the matrix B is obtained from A by interchanging two of its rows. Which of the following statements is slash R true? Determinant of B is equals to negative of determinant of A. Certainly this is true, right? If I interchange, so let's say if let's say this was alpha, beta, gamma and delta, this is my A. I'm just taking an example. Okay, so they are non-singular matrix. It should be properly mentioned that they are non-singular square matrix. This will be mentioned in the question. I forgot to mention it. They will be non-singular square matrices. Okay. So if I swap the rows, you certainly know that determinant of B would be simply negative of determinant of A. This is a property, right? If A is invertible, B is also invertible. Is this true? Yes, this will also be true, because technically, like, it is, they have already told me that it is a non-singular matrix, right? So basically its determinant is not equal to 0. That means A will be invertible. So if determinant of A is not 0, determinant of B also will be not 0. Why? Because we know both the determinants follow this relation. Determinant of B is equals to negative of determinant of A. So if A is non-zero, B also will be non-zero only, but it will be negative. So option B is also correct, right? Now, if A is symmetric, then B is also symmetric. Is that correct? No. So let's say here A is symmetric matrix, right? So asymmetric basically means A equals to A transpose. So if I swap these two values, it will be same. So essentially my gamma and beta are same, right? That is what symmetric means. Gamma is equals to beta. In this particular example, I'm just taking an example. Now what essentially I'm doing is I am trying to change this, right? I am swapping the rows. This will become alpha beta. And now is this symmetric? So what is B transpose? This is my B, right? What is B transpose? B transpose is gamma alpha and row will be changed to columns, right? To beta. So I said that gamma is equals to beta, right? So these two elements are same. Are these same? If they, how can they be same? They can be same only if alpha is equals to delta. Yeah, only if alpha is equal to delta, then only these two matrices will be same, right? But the condition that was set, if A is equals to A transpose, is gamma is equals to beta, right? So these two conditions are different. So certainly it will not be symmetrical. I cannot comment basically. Again, trace of A is 0, then trace of B also will be 0. Again, not correct. Here what is the trace? Alpha plus delta, that is equals to 0. Here what is the trace? Gamma plus beta. Is it equal to 0? I don't know. This condition is certainly true, but is this like, if this is true, is this true also? No, I cannot comment. So only option 1 and 2 will be correct. I will actually remove this non-singular part. Actually it should have been square matrix. Here non-singular is wrong, it should have been a square matrix. Okay, so yeah, that is the only difference that I will do. I will change the non-singular to square matrix. Okay, so option A and B will be your correct answer for this question. Consider the function as function belongs to real values only, defined by this. Which of the following statements is /r correct? F of x is continuous over the whole real domain. Is that so? Yes, it is, right? So what we are doing, so what is my e raised to power x? E raised to power x is a function like this, always increasing, right? So for negative values of x, the function will reduce. E raised to power -1, e raised to power -2, e raised to power minus infinity is 0, and e raised to power 2, e raised to power 3, it will only increase. This is my e raised to power x. What about your mod of sin x? Mod of sin x. So your mod of sin x would be this, right? So essentially it will not include any negative values of x, right? It will just make it positive. That is mod of sin x. So if I'm multiplying these two, right, what is happening? So essentially you will have to plot a what do you call it? I forgot this envelope, right? Now because your function is always positive, you don't have to draw the mirror image of the envelope, only for the positive values of the envelope. So this is the scaling factor. So essentially your function is like this. The amplitude will increase, and it will keep on increasing, right? Like this. This will be your function. Okay. So just a rough drawing, basically it will exist from minus infinity to plus infinity. Hence I can see at every point it is always continuous. There is no discontinuity. So f of x is continuous over the whole region. Option A is correct. F of x is differentiable for all real values of x. I can certainly say it is not differentiable, because you see the slope sharply change here, right? So there are sharp changes at x equals to pi, 2 pi, 3 pi, 0. So at multiples, integer multiples of pi, there are sharp changes. So f of x is not differentiable. F of x is periodic? No. This is periodic. This is not periodic. So I'm multiplying a aperiodic function with a periodic function. So certainly I will get a aperiodic function. F of x is bounded on R. This statement is again incorrect. It is not bounded, right? If you see, it is certainly not bounded, because at x equals to infinity, right, for all real values, it is also trending towards infinity. So certainly it is not bounded. So this is not bounded, right? So this is incorrect. So only option 1 will be the correct answer for this question. For the inductive circuit shown below, calculate the L equivalent between A and B in Henry. So I see that two particular coils with mutual inductance 3 Henry are in parallel, and I see, like, of course, if I am supplying here with some energy, both of them, in both the dots current is entering, and I have already derived the formula. If I have two coils in parallel, how to find out the equivalent L, right? You can, that's there in the videos, you can watch that, right? So yeah, how to watch that? So yeah, I think you can watch that. So this is certainly easy, but this one is not easy, right? This one's difficult because they are not exactly neither in directly series, neither in parallel. So this one, unfortunately, you will have to derive. We'll see. So first, let's reduce this block. So what is the L dash equivalent here? L dash. So we know two coils are in parallel, and both of them the flux is aiding each other, because in both the dots current is entering. If in both the dots current is entering, your formula would be L1 L2 minus m square divided by L1 plus L2 minus 2m. Why it will be minus 2m and why it will not be plus 2m? Because I have told you how to remember. Because intuitively you see that both of them the flux is aiding, so overall inductance will increase. So if flux is more, inductance is more, like basically your inductance formula is phi upon I, right? So if your flux is more, your inductance will be more. Then certainly if the flux is increasing here, certainly your equivalent inductance will be increasing. Because if let's say the dot was here, then this would have been plus, then your overall L equivalent would have been lower. Okay, I have told this in the full course, like not in the full course, in the video itself. So yeah, that is the L equivalent formula. Let's calculate this. So this will be equals to L1 is 6, this is L2, right? L2, L1 is 6, L2 is 6 minus m square, that is 9, upon L1 plus L2, that is 12 minus 2m, that is 6. So this will be 36 minus 9, that is 25 by 6, correct? Sorry, 36 minus 9, sorry, this is not 25, sorry, this is 27, right? Yeah, 27 divided by 6, that is 4.5. So this particular block can be converted into 4.5 Henry, with which I have 2 Henry in series. So this whole thing will be, okay, sorry, I have 6.5 Henry here, and here this is 8 Henry. Here I have a dot, and here again I have 4 Henry, and here I have a dot. You might have a doubt, sir, how are you assuming current to be entering? Because if I'm connecting a source, right, the load will always take in the current. So current will always go like this, because this is a source, this is a load. Okay, yeah. So here again I observe that the current that flows here, this current also enters, right? But again they are neither in series, neither in parallel. So for this particular scenario, we will have to derive it. So what will be your L equivalent in this case? What will be your L equivalent in this case? In this case, basically you will have to derive this equation, right? So if I let's say this current entering is I, and this voltage is simply V. So we know V will be equals to L equivalent into di by dt. So ultimately we will have to calculate di by dt upon V upon di by dt. That is what we have to calculate. So if this current is I, let's say this current is I1 and this current is I2. Okay. So what is the voltage here? What will be the voltage here? Let's say this is some V dash voltage. So V dash voltage will be 6.5 into di2 by dt, right? And what is this voltage? Now this voltage is interesting. This voltage is interesting. First of all, you see both of them current is entering. So current is entering, this voltage will be same V dash only, that is equals to L dIL by dt, that is 8 into di1 by dt, plus there will be an additional plus sign, because I see there is a mutual inductance between them. What is the value of the mutual inductance? That is 2 into the current in the other coil, that is di by dt. It will be plus because it is aiding. Okay, I hope you get the point. It is plus because it is aiding the coil, right? This particular connection is aiding the flux. So the current in the other coil, derivative into the mutual inductance between the two coils, that is 2 di by dt, that is equals to my V dash. Okay. Huh. and another equation is there, that is I is equals to I1 plus I2. So let me just try to eliminate I2, right? Let me just try to eliminate I2. So I can see that your I2 is equals to I minus I1, correct? I2 is equals to I minus I1. So in this equation, if I replace my I2, right, this will be 6.5 di by dt. All I'm doing is just eliminating my I2. So into 6.5 di2, so di1 by dt, right? Let me take another page. This will be a bit lengthy. Now here, this is my v dash, and this v dash is same as this v dash, right? This v dash is same as this v dash. So from here I get the value that your, I can equate these two, right? So 6.5, so I can copy this equation, and again I can copy this equation. These two are same, right? So from this I will get a relation between I1 and I. So this will be 4.5 di1 by dt, that will be equals to 14.5 di1 by dt. Okay, so from this I get the result that your di1 by dt is equals to 4.5 by 14.5 di by dt. That's it, right? So yeah, now if I solve it, here, if I solve it, right, uh if I write uh, a KVL in this loop, if I write a KVL in this loop, it will be minus V plus the voltage developed here. What is the voltage developed here? That is 4 plus 4 into di by dt, plus again plus, because I have mutual inductance of 2 Henry, right? Mutual inductance of 2 Henry into d, the current in the other coil, right? That is di1 dt, plus obviously this V dash voltage. Okay, plus this V dash voltage. What is the V dash voltage? V dash voltage is this. This is my V dash voltage, right? It is this. That should be equals to 0. Now here, let me solve it. So let me rearrange the terms. So V will be equals to 4 di by dt, that is 10.5 di by dt, and 10.5 di by dt minus 4.5 di1 di1 by dt, right? So I know my di1 by dt is this value, so I can replace my di1 by dt with this value, right? So this will be 10.5 di by dt minus 4.5 whole square upon 14.5 di by dt. I hope this is correct, right? This negative thing is correct. How is this negative? I'm not able to figure out. V dash value is this, right? Huh? I think both should give you the same values only. 6.5. Both should give me the same values. So this, right, is di by dt. So this, if I solve it, this will be 4.5 square divided by 14.5, and this subtracted with 10.5. That approximately comes out to be 9.1 di by dt, that is equals to my V. So basically what is your inductance? Inductance would be 9.1 Henry, right? Because V is equals to L equivalent to di by dt. So 9.1 Henry would be your correct answer. Trust me, no formula will help you here. Your basics must be very strong for solving this question. So 9.1 will be your answer for the question. A wattmeter is connected to the circuit shown in the figure, right? Wattmeter is connected to the circuit shown in the figure. The resistance of the secondary winding is 10 ohms. Okay, so resistance of the secondary winding, right, that is shown is 10 ohms, and the resistance of the wattmeter voltage coil is 1 kilo ohm. the current coil of the wattmeter is assumed to be ideal. So current coil basically has no resistance. The wattmeter indicates a power of 50 watt. Remember, the connections are not proper here. Okay, it is used to measure the coil loss, but I see if I want to measure the coil loss, I will connect the voltage coil across the primary, not across the secondary, right? So something is wrong. Assume the primary side is connected with the source. Determine the actual coil loss of the transformer if these are the voltages, right? So basically, what is the scenario? The scenario is the voltage at the secondary coil. They are telling me it is 50 volt, so it is 100 volts, right? And wattmeter is measuring 50 watts. So what you will say, because the voltage coil has 100 volts, wattmeter is measuring 50 watts. So what will wattmeter measure? Wattmeter will measure the voltage across the secondary coil into the current across the primary coil, right? Secondary winding and the primary winding, because the current coil is connected in series with the primary winding and the voltage coil is connected in parallel with the secondary winding. This is what your wattmeter will read, of course, into cos of phi. I don't care about this phi naught. Phi naught basically means the angle loss. I don't care about this for now. Okay, now what I care, because ultimately the angle between primary and the secondary volt, like angle between the current, right, of the primary and angle between the voltage of the secondary, these two angles will be same as the angle between primary winding and primary current. This will be same, because transformer does not, if you remember, transformer does not do a phase shifting in the voltage domain, so the angle will be same. Now they are asking me to compute the actual coil loss. What will be the actual coil loss? You will say, if this voltage coil was connected in the primary, then the actual coil loss would have been what? Then I would have been able to compute the actual coil loss, right? Then I would have been able to compute the actual coil loss. So this is the actual reading of the voltmeter, but the actual coil loss, right, would be, if you know the proper connections, actual coil loss would be equals to voltage coil connected in the primary into the current across the primary coil into the cos of phi naught, right? But we are doing this, and for this value we are getting a volt value of what? 50 watts. So if I take the ratio of these two, so your actual coil loss upon actual measured, that is 50 watt, will be equals to, these things will be cancelled simply. So it will be voltage of the primary winding upon voltage of the secondary winding, simply the ratio, turns ratio. So the turns ratio, if I see, it is 100 upon 50, so it is 2. So you will say your actual coil loss is actually equals to 100 watts, and you will tick mark 100 watts and you will be wrong. Why? Because this is the voltage here, right? They have already told me that there are certain resistance, right? Resistance of the potential coil and resistance of the secondary winding. So we will have to consider exactly how much voltage is this potential coil measuring, right? If I draw the equivalent circuit, so I have a 100 volt RMS across the secondary, right? And then I will have to consider the resistance of the winding. Also I will have to consider the resistance of the potential coil, and whatever is the voltage across this resistance, right, that is actually the voltage. Ideally it should be infinity. Ideally the resistance of the potential coil should be infinity. Of course it is not infinity. It is, in this case, it is 1 kilo ohm, so it is 1k. So this VPC will be the actual V of the secondary winding. Okay, this is not my VSW, this is not 100. Okay, so here I have done a bit of mistake. So what is your VPC? VPC would be equals to, you can use the simple voltage division rule, 100 into 1k, that is 10 cube upon 1010. Okay, so this would be equals to 1010, so that is 0.99 into 100. So it is almost similar, but it is actually equals to 99, almost 99 volts. Okay, 99.01 volts. So this is the actual voltage measured, right? Now what is the actual voltage in the primary side? What is the actual voltage in the primary side? The actual voltage in the primary side is what? It is equals to, if they have told me the secondary voltage is how much? 100 volts. So the primary voltage would be double of that, it will be 200 volts. So this is my V of primary winding voltage, that is 200 volts, with which I actually needed to calculate the core loss. So here what you'll do, so your actual core loss would be what? It will be this voltage ratio, right? That is equals to V primary winding, that is 200, divided by the not the secondary winding voltage, but the voltage measured by the coil, potential coil, that is 99.21, 90.01. This into obviously the previous power measured, that's how the ratio was derived, 50. Now again, this is not enough. Why this is not enough? Because again we will have to consider the losses in the winding. Don't forget there are losses in the so we consider this drop, right? So but I did not consider the loss across the potential winding, right? There is some loss here, this was not considered. What is the loss? The loss is simply, it is minus VPC whole square upon 1 kilo, right? That is simply the okay, not this, okay. So sorry, this loss, this, like I have considered the drop, the potential measured across the VPC, but I have not considered the loss across this particular resistance, this particular resistance. Do you know what is the loss? These two are in simply series, right? What is the loss here? It is simply the voltage square upon the total resistance, that is the overall loss. Because this is not my core loss, right? This is the loss that was present due to the connections of the meters. So this is not my core loss, but the wattmeter is measuring all these losses, right? Wattmeter will measure all these losses. You get the point? Because the current will be due to all these resistances, right? Ideally this should be infinity, but wattmeter still measures all these losses, because wattmeter will measure all the losses. And remember, it does not matter whether you're calculating the loss in the primary or in the secondary, losses are same. Voltage and currents are referred, losses, power is never referred. Power in the secondary, power in the primary, both are same thing, they are not different. Okay, so the loss would be 100 whole square upon the total resistance, that is 10,010 ohms. So this will be my actual core loss, because this was measured by the wattmeter extra. This is not required, right? This question is actually pretty conceptual. So this will be hold on, so 100 square, so let me write this, 200 divided by 99.01 into 50, that is 101, right? 101 minus this 100 square divided by 1010, so that is 9.9, so 9.9, hold on a second, plus 101, that is 91.1 watt. So 91.1 watt will be your answer for the question that is present in option C. So option C will be your correct answer, right? So you will certainly, so this also will not be a correct answer, because if you refer it, right, you will see that you are measuring 101 watts, but that 101 watts is also wrong, because you did not consider there are losses, there are copper losses. These are all what? These are all copper losses in the resistance, copper loss, right? And this is not considered as my core loss. Core loss is only due to the hysteresis and eddy current loss. So these are all copper losses, right? So these will not be considered. So your actual core loss will be this 91.1 watt. The transfer function of a linear time invariant system is given by this. The system is initially at rest and is subjected to a unit step input at t equals to 0. If y of t denotes the output of the system, then the value of dyt upon dt at t equals to 0 is equals to what? So y of t is the output of the system and we are providing a unit step input, right? So in Laplace domain, what is the output? Because essentially what they are asking me, the initial value of the differentiation or the derivative of the output. So I certainly know that basically what they are asking me is to calculate the initial value of the derivative of the output, that is y dash of t. In Laplace domain, it is x s into y of s. That is what the value of the derivative in Laplace domain is. So essentially, can I apply the initial value theorem here? Certainly yes. Why I can apply the initial value? Because I can certainly observe that this is a causal system. Okay, this is a causal system. That's why initial value theorem will be applicable here, because the order of the denominator is greater than the order of the numerator. Okay, certainly, like this is an LTI, and I can see that this transfer function is causal. Okay, so yeah, that's why this Laplace transform, that's why this initial value theorem will be applicable. So what will be y dash of 0 plus the value? This will be equals to basically limit as s tends to 0, s into what? This is the Laplace transform, right? I have to do s into the Laplace transform of y dash of t, that is s into y of s, that is actually s into y of s. Okay, so this will be equals to limit as s tends to 0, s square into y of s, right? That is what the value is, right? Okay, so yeah, now what is y of s? Y of s will be basically, so I know the transfer function definition, g of s would be the ratio Laplace transform of the output upon Laplace transform of the input, y of s upon x of s. Now the input is basically unit step, so your y of s would be simply equals to uh, g of s by s, right? That is basically 3s plus 2 upon s into s square minus s plus 2, correct? Now we will apply the limits now. So if I multiply s square, what will happen? One s will be cancelled, one s still will be there, right? Yes. T equal to 0, applying the input. So this will be equals to basically, if I give s equal s tending to 0, so s square into my y of s, so my y dash of 0 plus s square into y of s into 3s plus 2 upon s into s square minus s plus 2. So essentially, obviously don't forget limit as, okay, sorry, but initial value theorem is not 0, right? It is going to infinity. Sorry, just I know you guys are screaming at me, sir infinity होगा हाँ, so मेरे से भी होता है, right? Sometimes it happens. So I actually meant here infinity, right? Not 0. So how do you remember? So if I have 0 here, this will be infinity. If I have infinity here, this will be 0. That's how I remember the final value and the initial value theorem. Okay, sorry. Yeah. So 1s will be cancelled essentially, right? And of course s is tending towards infinity. If s is tending towards infinity, I will only consider the coefficients of the higher order terms in both the numerator and the denominator. I hope you know how to solve the limits. So this will be 3s, so like the coefficient of s square here is 3, and the coefficient of s square in the denominator, that is the highest coefficient, highest order coefficient, that is 1. So 3 upon 1, this will be 3. So 3 will be your answer for the question. The transfer function of a system is given as this. In the state space representation of the system, the minimum number of state variables in integers necessary is. So the minimum number of state variables, right, or the order of the system matrix will always be equals to the actual number of poles of the system. How many poles I have? 3. So once for answering this question, just be careful. One thing, simply measure the number of poles. Yeah, you're done. So number of poles here is 3. So your answer is 3. In this case, the answer is 3. But just be careful, make sure there is no pole zero cancellation. What do I mean by pole zero cancellation? Let's say if the quotient would have changed, it was s plus 1, s plus 3, and here I would have had s square minus 1 into s plus 7 into s plus 9. So your answer at first glance would be 4 for this particular transfer function. But if you factorize, right? If you break this down into factors, it will be s minus 1 into s plus 1, and that s plus 1 will be cancelled with this. So make sure whenever you're answering this, there is no pole zero cancellation. In this case, there is no pole zero cancellation. So your answer would be 3. Inside a linear dielectric medium with relative permittivity epsilon r equals to 3, the static electric field is specified in cylindrical coordinate systems. Okay, these are the cylindrical coordinate systems. We generally write rho, phi, and z. Here they have given r, so they are they have just replaced r. They have just replaced rho with r. That's all. Assuming that the above field represents a valid electrostatic field within the medium, the corresponding volume charge density is expressed in A into epsilon naught, which is in SI units, where epsilon naught is the permittivity of the free space. Then the value of A would be equals to what? So, uh, do you know what does volume charge basically means? So I know this, right? That the amount of Q enclosed would be equals to the surface integral of electric flux density. Electric flux density, that is the amount of uh, charge enclosed within a particular surface. So if I want to compute the volume, how can I compute? So what is Q enclosed? Q enclosed would be volume integration of volume charge density dV over the same volume, and this I can use the Gauss divergence theorem to change the surface integral to volume integral. That will become del dot d dV, right? So this will be my uh, divergence theorem, and from this I can equate that del dot V will be equals to rho V. So del dot D is equals to rho V. Now I have not been given the electric flux density, I have been given the electric field intensity E, right? This is called as the static electric field intensity. So we have certainly know this, that our electric flux density is epsilon into E, right? So I can replace epsilon into E here. Epsilon is just a constant, so epsilon can go here, right? So your del dot E, it is just a constant, right? Epsilon, so that can go here. That will be rho V upon epsilon. So actually you don't even need to calculate this. Actually you need to calculate rho V only, right? So you need to calculate this only. So actually technically you need to calculate this epsilon into del dot E. So we have to compute the divergence of my electric field intensity, right? This is in uh, cylindrical coordinate system. So if you have not already watched my RPO series, make sure you watch it. How to remember the formula of divergence, how to remember the formula of curl in different coordinate systems, I have explained in a very good manner. I will just use my shortcut here. Okay, so in this case, so there are three coordinates, right? Rho, let me write r, phi, and z. So what is a small differential length? I'm using my shortcut. I will not explain my shortcut here. Okay, I will not explain my shortcut. So you have to watch the RPOIQ video, AMFT and measurements. In the AMFT portion, I have explained how to use this shortcut. So it will be del r, small differential length is del r. So what will be the H1 constant here? H1 would be del r upon del r. Okay, I'm differentiating this with del r. So this will be 1. Now, what is the small differential length along the phi direction, right? So if this is phi, what is the small differential length? It is basically, if this is r, this will be r d phi. This is the small differential length along the phi direction. So in the numerator, I will have r d phi, and obviously I will differentiate with respect to this, that is d phi. So the H2 comes out to be r, right? H2 comes out to be r. And what is the small differential length along z direction? It is simply del z only, right? So del z upon del z is simply 1. Okay, so in the bottom I will have the differentials of these particular variables. In the top I will have the differential length. That's the shortcut. So these are my H values. And do you remember what was the divergence formula in terms of in different coordinate systems? It is 1 by H1, H2, H3. Certainly H1 is this, H2 is this, H3 is this, into this will be del of the first differentiation with respect to the first variable, right? That is del r into h1 into the other two coefficients of the other two variables into h2, h3, obviously into the component ar, whatever was the vector component here. If you see, ar cap vector component, that is 2r. Okay, And similarly we can extend this formula. So this is my divergence. For curl also I have explained the same. So yeah, del r, now this will be del phi, the second coordinate, second variable, into the coefficients of the other two variables, that is h1 h3 into fi plus del z into h1 h2 into az, right? Because in our case we don't have any z cap component, we have only phi cap and r cap. So yeah, let's solve this. So this will be h1 h2 h3 is 1 by r, del r, h2 h3 is r into 1, that is r, into ar. What is the ar cap component? It is 2r. So this will be 2r plus del phi into h1 into h3. So h1 is okay, h1 is 1, h3 is also 1, right? H1 is 1, h3 is also 1 into a5, right? a5. So a5 would be basically a5 would be this. This is my a5. Okay, a5 component is 3 by r. 3 by r, right? That's all. So this, right, will be equals to my divergence of electric field. So let me solve it. This is 1 by r, differentiation of 2r square with respect to r, that is 2 will come outside, this will be 4r plus, now I am differentiating this with respect to 5, that will be 0, right? Because this is a function of r, so 0. So actually it comes out to be 4, right? So your del dot E is coming out to be 4. So what is your answer? Rho v. Rho v would be epsilon into del dot E. What is epsilon? Epsilon is equals to epsilon naught into epsilon r. So epsilon naught is epsilon naught only, and epsilon r is given as 3. So this will be 3 into epsilon naught. So this would be equals to 3 into epsilon naught into 4. Right? So it is 12 epsilon naught, which is equals to a into epsilon naught. So your a will be equals to 12. This will be the answer of the question. A semicircular conducting loop of radius 1, as you can see the radius is 1, so capital R is equals to 1 meter, whose diameter is okay, this will be centered at the origin. Okay, diameter is centered at the origin, this will be centered, rotates uniformly in the xy plane about the origin with an angular speed of 10 radians per second. So its omega is 10 radian per second. As shown in the figure, a uniform magnetic field of 2 Tesla is present on the, as you can see, on the one half only on the for positive values of x, right? Only in the region x greater than 0. Now the loop has a resistance of 10 ohm. The loop has a resistance of 10 ohm and negligible inductance. Right? Determine the peak to peak value of the current induced in the loop. What is the peak to peak value of the induced current? So do you realize what is happening over here? So when my circular loop is around this region, right? So there is no flux cut. If there is no flux cut, that means there is no voltage induced. Now as soon as, let's say, my circular region reaches here, so I see half of the semicircular region is cutting the flux, right? So here the flux cut was 0, then at, let's say, theta, so this is my let's assume this is my theta, right? So the angle between this axis and this semicircular region, this angle is theta. Okay, so when my theta is 0, my flux is 0. When my theta, let's say, is pi by 2, when my theta is pi by 2, when my region is here, right, theta is pi by 2, then what is the flux? Flux would be something half. Okay, it will be half. Basically, if all of the circular region is here, flux would be the total flux, right? So I'm just telling you with intuition what is happening over here. So flux would be, let's say, phi m by 2. Again, when my theta is equals to what, pi whole 180, right? When my theta is equals to 180, then what happens, then my flux would be phi m. Again, what happens after this, again it go rotates in the anti-clockwise direction. So again, what will be the value of theta now? So the angle, right, between this point and this point is actually minus, this is negative now, okay? Or I can say, sorry, this is not negative, this is actually, what is the angle? It is actually 3 pi by 2, okay? So basically angle is this one, right? Angle between this edge of the circular region and between my negative y-axis, right? So it was, once it was here, angle was 0, then this negative edge was here, angle was 90, then this negative edge was here, angle was 180, then the negative edge will be here, angle will be 3 pi by 2, okay? So at 3 pi by 2, if I see basically this edge, right? So half of the circular region is cutting the magnetic field, that is flux is again phi m by 2, and again you at theta equals to 2 pi, flux would be again 0. So this is the scenario, okay? I'm just giving you a rough scenario what is happening. Flux is increasing, then decreasing, and we know voltage is induced when you have d phi by dt, right? The magnitude of the voltage induced is minus d phi by dt, right? That is the magnitude of the voltage induced, minus d phi by dt, correct? So how do I calculate? So what are they asking? They're asking me the peak value of the current induced in the loop. How do I compute that? Okay, so yeah, so E is equals to minus d phi by dt. So let us see what is d phi by dt. What is the change in the flux? So how do I calculate my flux as a function of time? Right, then I will be able to comment about d phi by dt. So flux as a function of time, if I see, right, so flux will depend on theta, correct? So this magnetic field is uniform, that is B. So whatever is the region here, right, that will be equal to the total flux cut. So what is the area of this region? This would be, let's say, if this angle is theta, right, if this angle is theta, what is the area? Area would be pi r square, area of the whole sector, pi r square into theta upon 2 pi, right? That is the area of this particular sector with angle of theta, right? So this will be equals to r square theta upon 2 pi. Okay, now can you tell me what is my theta equals to? So theta is also a function of time. So if, let's say, if we know this, right, so our distance x is equals to speed, velocity into time, right? This is in the linear motion. In curvilinear motion, our x gets converted into theta. Theta will be equals to, v will be converted into angular speed, and t will be t only. So theta will be equals to omega t. So basically it depends. So theta will depend on omega into t. This is the most basic formula, right? So I can convert my theta here as r square by 2 pi into omega t, that is this, sorry, this pi also will not be there, right? R square by 2 into omega t, that is the theta. Now one more thing is given, that okay, if the loop resistance is 10 ohm, because they are asking me the peak to peak value of current. So for calculating the peak to peak value of current, first of all let me compute the peak to peak value of the voltage, and if I divide by resistance, that will give me the peak to peak value of the current. So peak to peak value of the voltage, right? So what is phi of t? Phi of t is this. This is my phi of t, r square omega t by 2. So what is E? E would be minus of d phi by dt. So this will be r square by 2 omega. Okay. Now what is happening is, this is my induced EMF. So this is the value of the induced EMF. Or this is the always the value of the induced EMF. Okay, peak to peak value. What is happening? Hold on. Minus d phi by dt. Okay, r square by 2. So yeah. So what is happening is, if you see here, what is happening, the flux is increasing when my theta is going, from 0 to pi. What is happening? The flux actually increases. If the flux increases, if you see here, from theta equals to 0 to pi, flux is increasing. It is going starting from 0 to phi m by 2 to phi m. So flux is increasing. So your induced EMF would be negative. It will be constant, but it will be negative. So when my theta is from 0 to pi, it is constant. Induced EMF is certainly constant, but it is negative. Okay, the value is this minus r square by 2 omega, but it is negative. But as soon as my theta is going from theta equals to pi to 2 pi, what is happening? Your flux is reducing. If your flux is reducing, right, that means your d phi by dt is negative. If your d phi by dt is negative, that means your induced EMF is positive. So the sign of the induced EMF will change. Although the magnitude is constant, the sign of the induced EMF will change, and this cycle will repeat. So the induced EMF is just like a square function. So what is the peak to peak value, right? So this value is r minus r square by 2 minus r square by 2, and this value is plus r square by 2, right? So the peak to peak value, obviously omega is there. Peak to peak value would be r square into omega. This is the peak to peak value. Now I will divide by the resistance, that is 10 ohm, and this will be the peak to peak of the current, right? Peak to peak. So it is the absolute value, magnitude of the peak to peak value of the current, that is r square into omega divided by 2. Now your r is 1, your omega is 10. So this would be simply 10 by 10, that comes out to be 1 ampere. So it is 1 ampere peak to peak. If everything is correct here, r square theta pi r square upon 2 pi, yes, yeah, it is 1 10. Sorry, okay, sorry, just one small mistake here. So this was the area, right? Sorry, this was the area. Okay, this was just the area. So what is your flux? Flux is equals to b into a, right? I forgot to write this. Flux is equals to b into a. So this was just the area that was computed. I also have to multiply by the flux density, that is b, that is equals to 2. In our case it is 2 tesla. Sorry, really sorry about that. This is 2 tesla. So this will be multiplied by 2, right? So everywhere there will be multiplication of 2. So this will be r square omega t. So ultimately this 2 will go away. This will be r square omega r square omega. So actually this will be 2r square by 5, right? So this will be by 5, this will be 2 amperes. So 2 amperes peak to peak will be your answer for the question. In the given circuit, Vz, the general voltage is 12 volts, beta is 50, and Vbe is 0.7 volts. Based on this, identify the correct statements, right? Zener current and all those things. So if nothing is mentioned, right, the minimum amount of Zener current for the Zener to be in breakdown is 0 amperes. Okay. So first let us see whether our BJT is in active region or it is in cutoff region. There is no possibility of saturation because they have not given me the information regarding saturation, right? It can be, but most probably it is not in saturation. So if I assume your Zener diode to be in the reverse biased, right, it is basically clamped to 5 volts. So your Zener diode is clamped to 12 volts, right? So this potential, this is what N transistor, N transistor, right? So your P is at 12 volts, and if I assume this to be off, right, so this is at 0 volt because no current is flowing. So PN junction is forward bias. Basically the base emitter junction is forward bias, certainly it is forward bias. And if I see this point potential is 15 volts, right, so certainly your uh, collector base junction is reverse bias. So intuitively I can say certainly the BJT will be in active region. So BJT is certainly in active region, that is established. Okay, now let us assume that, let us right now write the equations, right? So this is 12 volts, and VBE, if it is in active region, this will be 0.7 as given in the question. So what will be the voltage VO? VO would be 11.3 volts. Remember, I will still not put this as my answer. I need to still verify whether my Zener diode is in the reverse bias or not. Okay, so yeah, we will verify that certainly. This is 11.3. What is the current? So the current here, I can easily compute the current IE, emitter current. This will be equals to the voltage 11.3 upon the resistance, that is 1 kilo ohm. So it will be 11.3 milliamperes. So if I know IE, I certainly know what is my IB. So your IB, beta 1 plus beta into IB will be equals to IE. So it will be IB will be equals to IE by 1 plus beta. Beta is 50. So 11.3 upon 51. 11.3 upon 51, that is equals to 0.221 milliamperes. This is my IB current. Now if this potential is 12 volts, right, so what is the current that is coming in here? So it will be 3 divided by 0.22 milliamperes. I have converted 220 ohms to milliamperes. So 3 divided by 0.22, that is equals to 13 milliamperes. So this is equals to 13 milliamperes. So here current is coming in 30 milliamperes, out of which 0.221 milliamperes is going here. So the remaining current is certainly going here. So your IZ current, right, is certainly flowing in the reverse bias direction. So certainly your Zener diode will be in the breakdown region. Certainly your Zener diode will be in the breakdown region. Your IZ is greater than IZ minimum. Nothing is mentioned. IZ minimum would be 0. So certainly your Zener diode will be in the breakdown region. So yeah, certainly all these values are absolutely correct. Okay, so output voltage will be 11.3, absolutely correct. What will be your Zener current? So your Zener current would be 13 milliamperes. Sorry, this is 13.6, right? Sorry, 13.6, 13.634 minus 0.22, that will be approximately 13.41 milliamperes. Okay, so IZ will be equals to this 13.664 minus 0.22. Okay, so 13 point something 41 milliamperes approximately. So option 1 and 2 are correct. This is wrong, this is also wrong. Okay, so this will be the answer of your question. Two identical NMOS transistors M1 and M2 are connected as shown below. The circuit is used as an amplifier with the input connected between gate and source. Okay, so input is connected between this. So basically, if I assume this to be ground, source to be ground, the input is connected here. It is used as a amplifier. Now, what they're telling me, that V bias is the bias voltage, VD are adjusted so that both the transistors are in saturation region. The trans conductance GM is del ID upon del VGS, right? What is ID? ID is the drain current basically, right? That is same in both the transistors as they are in saturation. And RO is del VDS upon del ID. RO would be basically, this is my output node, right? So it will be small signal output node. So RO would be the output, like output resistance as seen from the drain terminal of MOSFET M2, and RO1 and RO2 are the output resistance of transistor M1 and M2, basically if lambda is not equal to 0, and GM1 and GM2 are the trans conductances. So they are asking me what is the equivalent GM of the whole circuit and what is the output resistance of the whole circuit. Before you say, sir, will this come in our exam electrical, just check the 2025 paper. A easier version of this question did came. Okay, I have just taken a higher level. Okay, I have just taken a bit upper level question so that you will be prepared. So yes, MOSFETs do come in your examination, and it did came on 2025. Okay, so that's why it is important. So yeah, how, so let's do few bit of intuition here. What would be my GM? So I see GM, right? So what is the GM of transistor M1, it will be del VDS, that is this potential, upon your del ID, right? So basically ID is same in both the transistors, but they are asking me what is the overall GM. Sorry, this del ID upon del VGS. Sorry, del ID upon del VGS. So one thing I observe, what is the thing that I observe, that GM is basically the output current, differentiation of the output current upon the input voltage. So the output current I out is nothing but the drain current of transistor M1. So this is ID1 upon VGS1. So this is nothing but drain current, output current, right? Basically the GM of your whole circuit will be del I out upon del V in, right? That is the GM of the whole circuit, because VGS is nothing but the input voltage and I out is nothing but the drain output current, right? So your del I out, so what is your I out? I out and ID1 are the same, and your VGS and V in are the same. So actually this is equals to del I out upon del V in. So this is actually equals to my overall GM of the circuit. So your overall GM of the circuit is actually equals to GM1. So overall GM of the circuit would be actually equals to GM1. Okay. So there is a shortcut way to solve this. I'm just solving it in a quicker manner. In our YouTube only, I think these questions have been solved. You can see the RPYQ series. There I think all the PYQ questions have been solved, and this was also I think was solved. This is a question that is most similar to the PYQ, right? So you can check that. Now certainly it will be the same, and I will just solve this in a quicker manner. Okay, there is a full question solved. You can go and check out. Certainly you can go and check that in our RPYQ series playlist. I will solve this in a quicker manner. So if I am computing the output resistance R out from here, so what happens essentially, this particular R out, right, is magnified by what? By the factor of GM to RO2. And what is the R out here? RO1. So this will be GM2 into RO2 upon RO1, because this particular, what is the impedance seen from this particular point? It is RO1, right? So this actually is boosted. So don't worry, your answer would be this. Okay, don't worry, your answer would be this, meaning don't worry if you are not able to understand, because you are not supposed to understand this, because I have not explained you the concept. Okay, yes, you can draw the small signal model, you can solve all this, but there are multiple tricks involved. So whenever we are seeing the output impedance from this side, from the drain side, right, and if there is some resistance on the source side of the transistor MOSFET, then this source resistance will be boosted by the intrinsic gain of the MOSFET, that is GMRO, that is GM1 GM2 into RO2 into whatever is the resistance connected in the source side, that is R1. So your answer will be this only. Okay, it will be boosted. Now the point of taking this question is, it's not like you will have to understand the whole concept. Yes, you can draw the small signal model. I'm telling you, go ahead, draw the small signal model. Approximately your RO will be this. Go ahead, but the point is you should be able to solve this in a quicker manner. Okay, so first I identified what is my GM. As soon as I got to know what is my GM, then I moved on to RO. I see only these two options are present. All I will do is eliminate. Even though if I don't understand that whether there will be some gain boosting, what will be the formula of gain boosting, but I certainly just remember this, that if there is a source resistance connected, that will be certainly boosted if I am seeing the impedance or the resistance from the drain terminal. So it will be boosted. So certainly it will not be RO2. Okay, it will be boosted. So RO1 into some gain, that is GM2 into RO2. So that's why option D will be answer. Now again I'm saying this, if you want to see the complete solution, RPYQ videos are there. So all the PYQs, I think from 2007 till 2024 or 23, I don't remember, all those PYQs for all branches has been solved. Please go into that video and watch that. Okay, this video is only for to tell you what are the tricks, and obviously if you want to know more about them, of course follow those videos. So the answer of this question would be option D. For the circuit shown below, which of the following statements correctly describes the current through the 2 Henry inductor? So I, like, this is the circuit of a full wave rectifier, uncontrolled full wave rectifier, right? And the inductor current is discontinuous, inductor current is continuous. The shape of the waveform will of the inductor current will depend on the inductance value. The condition for continuity of the inductor current will depend on inductance value. So one thing that I can see is the frequency, right? or the time period is 1. And what is the time constant of this particular circuit? The time constant of this circuit is actually L by R. And what is R? R is 0. So actually the time constant is infinity. So it simply essentially means it will never settle, right? That is what it means. Now to check the continuity of the current, if I assume the current is continuous, if you say the current across the inductor is continuous, right? If it is continuous, we know if the current is continuous across the inductor, then the voltage, average voltage across the inductor would be 0. Otherwise this system will not be stable, right? Because basically what will happen, if the current is continuous, then if the current is continuous, the inductor current would be something like this, right? And it will have some average current, that is certain, but it will charge for certain region and then it will discharge if it is continuous, right? Something like this will happen, or like this also it can happen. I exactly don't know the plot, but this also is a possibility, right? Okay, so whatever, like it will be periodic. If it is continuous, it will be periodic because your input is periodic voltage, it will be periodic. If it is periodic, your VL average will be 0, right? This is taught to you in the full course, right? In power electronics, all these things have been taught in the crash course as well, RPYQ as well, I have taught you. So if it is continuous, the average voltage across the inductor would be 0. Now what will be your VO average? Your VO, what is your VO? VO is actually is equals to VL plus the voltage E, that is 10. So what will be VO average? VO average will be equals to VL average plus average of 10, that is 10 only, right? And VL average will be 0 over a cycle, it will be 0 if, let's take the case 1 where the current is continuous. So your VO average comes out to be 10, which is constant. And what is your if I assume here, this is a example of an uncontrolled rectifier, right, where alpha is 0. So what is the output average voltage if I don't consider the load, if I consider a continuous load? What is the output average voltage? Output average voltage, VO average, is coming out to be, I hope you remember, it was 2 Vm upon pi into cos alpha, right? Where alpha is 0, so it will be 2 Vm upon pi. Now 2 into Vm, Vm is basically 5 pi upon 2, so sorry, upon pi, this is 10 volt. So this is exactly coming out to be equals to my VO average. So my actual output average voltage of the output of the rectifier is exactly same as the output voltage of the this particular load. So basically that means the current is just continuous, it is continuous. So the inductor current will be continuous because this was the case 1 where I assumed the inductor current to be continuous. And if I assume my inductor current to be continuous, and for that case I am seeing whatever I am calculating VO average from the continuous case of a rectifier and from the load itself, I can see that they are matching. So certainly inductor current will be continuous. Now the shape of the waveform of the inductor current will depend on the inductance value. The shape of the waveform will not depend on the inductance value. Okay, what will be the shape of the waveform? So the shape of the waveform, let's say when the diodes are on, it is simply Vm. So what is the voltage across the inductor? It is Vm sin omega t minus 10. That is the voltage across the inductor. And your current, right? Current is simply 1 by L of integration of VL d omega t or dt, right? From it, if it is periodic, right? So the shape, like of course the exact values, instantaneous values will depend on L, that is certainly true, but the shape will depend on VL, and VL depends on the E and Vm. Shape depends on this particular thing, that is on the input and the eval. So shape does not depend on it, so this is wrong. The condition for continuity of the inductor current will depend on the inductance value. Now is this true? This again is not true. Again the condition for continuity will depend on E and Vm. These things have been taught in the full course. It will depend on E and Vm, it will not depend on L. Okay, E does not. So essentially, right, if this integration comes out to be 0, then certainly your inductor current will be continuous. If this does not come out to be zero, if there is more positive area, if there is more less negative area, like if there is more negative area, right, then your inductor current will not be continuous. Okay, basically it will not have enough energy to keep this diode on, right? So what happens here is these two are on, and again these two are on, right? So yeah, so yeah, this you will understand. So here, right, uh, your continuity of the inductor current, because your inductor current depends on this integration, and this integration, right, if it is zero, then your current will be continuous. If it is not zero, your current will be discontinuous. We cannot comment. Uh, we'll have to do more uh, thinking in the circuit, right? We have to like do the analysis of the circuit, right? So in this case, only option 2 is correct. Only option 2 is correct. This statement, although this question was very short, but if you know a very basic thing, inductor current will be continuous if your VL average is 0, then you will be able to solve this in a much quicker manner. So option B will be the correct answer for this question. Consider an ideal buck step down DC to DC converter with RL load and a freewheeling diode in parallel. So if I have an ideal step down chopper, right, uh, with a RL load and with a freewheeling diode in parallel. Now this is my input, right, Vs. Now what they're telling me, that if the input supply remains constant and if the load is reduced, so if the load is reduced, basically they're telling me that the RL value will increase, right? Load basically reduced basically means your IL value will, so your output current will reduce, which essentially means that I'm increasing the RL value, I'm increasing the resistance value. Then uh, the output voltage increases when the converter operates in discontinuous conduction mode. When the converter operates in discontinuous conduction mode, the output voltage will increase. So they're talking about the average output voltage, or yeah, or the instantaneous also they can say, the output voltage will increase. Okay. So what happens? So what happens in the discontinuous mode when, let's say, this was 1 ohm, right? And so what will happen in the so they are talking about discontinuous mode. If it is discontinuous mode, then as soon as I will connect the uh, buck converter, what will happen? Current will flow, right? That will energize the inductor, and the current will increase like this. It current will increase like this. Okay, and then as soon as I will open the switch, inductor will now de-energize like this, right? And this cycle will be repeated basically. Okay, and of course we'll get some average value of the current, right? That will be my IO average. I don't want to comment on that, but this is my discontinuous operation, right? This is what my discontinuous operation is. Now they're telling me that the output voltage will increase if the if this. So what happens? What is the output voltage equation here? So what is this current equation? IL would be equals to what? E raised to power, hold on a second, this will try to reach to Vs by R. Let's say, let's for a second, let's assume R to be 1 ohm, right? So Vs by 1 into e raised to power minus t upon tau. Tau will change. Tau is the time constant of the circuit. Okay, tau also will change actually. Tau also will change. This will be, let's take L to be 1 Henry, right? So this will be 1. Okay, this is the current across the inductor, and this is the load current only, right? Now sorry, this will be 1 minus this, right? The value would be 1 minus of this. So your IL current would be Vs into 1 minus e raised to power minus t. Okay, so that is what your inductor current is equals to. Now what about your, okay, this was during the time period for which the switch was on, that is still alpha t, and during this 1 minus alpha into t, that the switch will be off, and that will be the, your current will follow the discharging equation, that is Vs e raised to power minus t. That's all, right? Okay, how do I comment about the voltage? Now if the load current is reducing, basically if your RL is increasing, if your RL increases, if your RL increases, what is the current? Now your current would be Vs by 2. Let's say I have increased the RL from 1 to 2, still it is in the discontinuous mode, so this will be 1 e raised to power minus t upon, now what will be a time constant? Time constant will be L by R, so this will be actually 0.5, that is actually 2 2t, and your, this is in the charging duration, and in the discharging your IL would be Vs by 2 e raised to power minus 2t, so it will charge and discharge a bit slower. Okay, but still it is operating in the discontinuous mode. Now what is happening is the derivative. The derivative, if I know the derivative, will I be able to comment on the voltage? But they're asking the output voltage will increase. Does the output voltage increases? So what is LdIL by dt in this case? It will be okay, if it is operating in the discontinuous mode, right? So when the, okay, let us do some basic analysis. When the switch is on, what is output voltage? When the switch is closed, the output voltage VO is nothing but Vs. Okay, now when the switch is off, when the switch is off, the diode will be turned on, diode will be turned on, right? And as the diode is turned on, it will be on. So your VO is simply 0 volts, right? Because the diode is turned on. Now if it is operating in the discontinuous mode, that technically means that the duration for which your switch is on, that is, let's say, alpha into t, that is a duty cycle, and they have not mentioned anything regarding the duty cycle, so we are assuming the duty cycle is constant in this case, and when it is off it will be 0 volts, right? But this will be till beta, this will be 0 volts till beta, actually no, till, not even till beta, right? Actually, okay, once the inductor totally discharges through the diode, so this path is also open, this path is also open, because inductor has completely discharged. So what is the voltage across the inductor? It is 0. What is the current across the, so what is the voltage across the zero inductor? It will be 0. Why? Because the rate of change of the current across the inductor is 0. So when inductor has discharged, the voltage here is 0, the current also is 0, right? So the current voltage across the resistor is also 0. So actually during the discharge cycle and during when the inductor has totally discharged, the voltage, output voltage is 0 only till the point t. Again, once the switch will be closed, again the inductor will energize, and again the same cycle will be repeated, right? 1 plus alpha. So actually the average output voltage does not even depend on the average output voltage does not even depend on the uh, does not depend on the load current. That's pretty interesting, right? Because if I have a freewheeling diode in parallel, okay, so when, it does not matter whether it is like in continuous conduction mode or in discontinuous conduction mode, ultimately, okay, when it is, when it is closed, when it is closed, it will energize. So the voltage, output voltage would be basically this Vs, right? That is the output voltage. It is closed. When it is open, the freewheeling diode is on, the inductor is discharging, so the freewheeling diode is on, so the voltage is 0 only, right? The voltage is 0. Now again, as soon as the inductor will be totally discharged, then what will happen? Then the voltage across the inductor is 0 because the rate of change of the current is 0. The voltage across the resistor is also 0 because there is no current. Hence, this voltage is 0. It does not matter whether it is continuous or discontinuous. So technically, your average output voltage does not even depend. Your average output voltage does not depend on the load. Okay, if it is operating, it does not matter if it is operating in discontinuous mode or it is operating in continuous conduction mode. So this statement is certainly wrong. Okay, now let's read the next statement. If the output voltage of the buck converter is to be maintained constant, if the output voltage of the buck converter is to be maintained constant while the load current decreases, okay, so output voltage they want to maintain constant while the load current decreases, the duty ratio must be reduced. Consider the load is operating in continuous conduction mode, right? Now if the load is operating in continuous conduction mode and they want to maintain a constant, is to be maintained constant, output voltage is to be maintained constant while the load current decreases. Okay. The duty ratio must be reduced. Again, right, we have already discussed that if I reduce the load current, it does not affect the output voltage. So again, uh, so okay, they want to maintain the output voltage to be constant. So do I want to reduce my duty cycle? No, right? You will not want to reduce your duty cycle, because if you reduce your duty cycle, your output voltage will reduce. If you reduce your duty cycle, your output voltage will reduce, right? What is the average output voltage? Average output voltage is basically this, right? What is it? It is simply Vs into alpha. That is what your average output voltage is, and it will reduce. So suddenly this statement is wrong. We will not change our duty cycle. If I change my duty cycle, our output voltage will reduce. Okay. So yeah, both statements are false. Option D is correct. For what frequencies the circuit resonates, right? So basically they're asking me the resonant frequency. You know, for resonant frequency, essentially your whole circuit should behave as purely resistive. So how can I make it purely resistive? So like, of course you can solve it using the longer method. That's not a problem. If I observe something, here, that this L and this C are in series, so somehow if I make this short circuited, this whole branch is neglected, right? So if this whole branch is short circuited, essentially your circuit is purely resistive. So what needs to happen to short circuit this branch? Omega into L, that is 1, minus 1 by omega C must be equal to 0. So L is 1 and C is 4. So this will be 4 omega equal to 0. So your omega square equals to 1 by 4, that is omega would be equals to 1 by 2. So omega equals to 1 by 2, that is 0.5 would be your correct answer for this question. Now few students may have this doubt that what if omega equals to 0, because at omega equals to 0 this upper branch will be short circuited. You are technically correct, but of course omega equals to 0 is not a condition for resonance, because omega equals to 0 basically means DC, and at DC we don't see any resonance. We see resonance only when your frequency is not equal to 0, right? So this is certainly not your answer. Your answer is only omega equals to 0.5 radians per second, that is option C. For the circuit shown below, determine the value of R in ohm for which the power delivered to the resistor is maximum. So do you remember, when I have a pure resistive load and I want the maximum power delivered to the load, what needs to happen? So if it's a complex circuit, if I convert my basically my whole circuit, right, into its VTH equivalent and into its RTH and obviously into its XTH equivalent, right? So this, if I have a pure R load, essentially what needs to happen? Your R must be under root of RTH whole square plus XTH whole square, right? This was the formula. If let's say you had here R plus JXL, okay, and this is also plus J, right? Then you'll have to consider the magnitudes. Then what should happen? Do you remember what needs to happen? Then simply your R, right, like your R, your load will be equals to conjugate of the Thevenin impedance. So Z load will be conjugate of the Thevenin impedance. These are the things that I have told you how to remember as well. You can watch the RPOIQ series. There I have told you how to exactly remember all these things. Okay, so there you can revise it. So for our case, it's very simple. Essentially, because there is only R, so we will not consider these certain cases. We will only consider this much. So our answer would be very simple. So we have to compute RTH and XTH. right? Simply we have to compute ZTH. So I see, to compute the equivalent Thevenin impedance, so we will eliminate the sources, independent sources. So if I make the current source to be 0, so I will open circuit the current source will be open circuited, right? So essentially this branch does not even matter. So only whatever matters is this branch, right? So this voltage source will be short circuited. So it will be basically 4 Henry and 3 ohms. Okay. Now this is in Henry, right? How do I know the reactance? So you can see the frequency, right? Both of them are working in frequency of 1. So certainly the reactance would be J 4 into 1, J omega L, right? So J 4 into 1 is J4. So your overall resistance would be under root of 3 square plus 4 square, that is simply under root of 5 ohms. So 5 ohms, uh, yeah, 5 ohms would be your answer for this question.
Yeah, so let's see this one. This is easy question only. You need to find out the value of I. Okay. So what is I? I is minus infinity to infinity x of omega e to the power minus j omega t d omega. Can you see the? Can you remember this formula now? But here there was plus j omega t, right? X of omega e to the power j omega t d omega 1 by 2 pi. Well and good. Okay. So what do you need to do? 2 pi x of t equals to minus 1 you need to put. That's it. Right? 2 pi x of t, in place of t you need to put minus 1. And what is your x of omega? X of omega is nothing but sinc square 2 omega by sinc square 2 omega by pi. So from here can you find out x of t? Surely you can. And then just put t equals to minus 1 and your job would be done. So do you remember this formula? A triangle t minus center upon width of one side, that would be a tau sampling square omega tau by 2. When sampling should be converted into sinc, then what will happen? If sampling is converted into sinc, then what will happen? Sampling means sine omega and sinc means sine pi omega, right? So it would be divided by pi. So this would be sinc square omega tau by 2 pi. So what is the value of tau by 2 pi? That is 2 by pi. So value of tau is coming out to be 4. So a triangle t minus center, that would be 4a sinc square, in place of tau we need to put 4. So that would be 2 omega by pi. So this is the scenario we are getting. Sinc square 2 omega by pi, our criteria a and a is getting cancelled out. So our answer is coming out to be 1 by 4 tri t by 4. Right? How it can be broken? It can be broken into 1 minus mod of t by 4. In place of t you need to put minus 1. So what you are getting? 1 by 4 into 3 by 4, and then you need to multiply with 2 pi. This will be your final answer. So let's do the calculation. 3 by 16 into 2 into pi. So 1.178. Answer is coming out to be 1.178. Okay, so simply you just need to know this particular formula. I hope you know it. If you have studied signal system, then at least you know this particular thing. Triangular function a tri t by tau, a tau sampling square omega tau by 2. We remember in terms of sampling we can convert it into sinc. So this was sinc given, we converted it into sinc. Then this is the scenario we were getting. We just compared it now. What we compared, that we need to get it tau by 2 pi should be equals to 2 by pi. So from there tau value we are getting 4. So again we put the value and we saw this expression we are getting. Our matter of concern is sinc square 2 by 2 omega by pi. So a and a was getting cancelled out. So answer, this is something that we are getting. So our x of t is, this is our x of t. So x of t was 1 by 4 tri t by 4. In place of t I need to put minus 1. This could be opened as 1 minus mod of t by 4. In place of t I just put minus 1. So this will become 3 by 4. 1 by 4 into 3 by 4 multiply with 2 pi. We are getting the answer of 1.178. So I am solving all the problems roughly because this is the solution video, not the concept video. No, the solution video it is, right? So we can solve it roughly as well. Let's go to the next.
Each parameter of a two-port network containing only resistive elements is shown. The capacitor voltage Vc at t equal to 2 would be equals to what? Okay, so basically initially the capacitor voltage was 5 volt, and at t equal to 0 I'm closing this switch. It is all a resistive network. Okay, then at t equal to 2, what will be the value of the capacitor voltage? So what I have to do, I have to convert this whole thing, right, network, into a single resistive element. So the h parameters are given, right? So I can use the h parameter and this value to find out the value of V1 over I1. If I'm able to find out V1 over I1, that will be the R equivalent. So I can replace my whole circuit with R equivalent. So from that I can use the capacitor discharging equation to find out the capacitor voltage at t equals to 2 seconds. Okay, so let me first write down the h parameters. Do you remember what was my h parameters? So I used to have V1 equals to h11 into I1, that was constant. Then I used to have V2 because h12 was the voltage gain. So this will be h12 V2. This will be, I have chosen I1 and V2, so only I2 is left. This will be again h21 I1 plus h22 the V2. Okay, so I can replace, like each parameters are given, so I can replace it. So this will be V1 into I1 plus h12 into V2. H12 is 2, so 2 into V2. I2 equals to h21 into I1. H21 is minus 2 into I1 plus h22 into V2, that is 2 V2. Okay, one more thing is there, that V2 by I2, right? V2 by I2 is basically, because this is negative, remember, I like V2 is equals to minus 2 I2 into 2. Okay, because I2 is in the opposite direction, right? So V2 is equals to minus 2 I2 into 2. So I2 would be equals to minus 2 I1 and V2 is minus 2 I2. So this will be minus 2 I2. So from here I can get the value of I2. I2 would be minus 2 by 5 of I1. Okay, so I can replace my, oh, can I replace? Okay, I can, so what is my V2 then? So V2 is minus 2 I2, right? So this will be 4 by 5 I1. V2 is 4 by 5 I1. So I can replace it over here. This will be V1 I1 plus 2 V2, that is 8 by 5 I1. So this would be V1 by I1 equals to 13 by 5. Okay, so 13 by 5 is my R equivalent. We got the value of R equivalent. Now what we have to do, we have to simply use the equation, right? What is the voltage equation? Vc, it will be Vc of 0, that is 5 into e raised to power minus t upon tau. Tau is simply R equivalent into C. What is C? C is basically 2 farad. C is 2 farad. So your time constant tau would be 26 by 5. Okay, so this will be 5 e raised to power minus 2 upon 26 by 5. Okay, so if I, this will be 10 upon 26 exponential into 5, approximately it will be 3.4. Okay, so this voltage will be 3.4 volts. So your capacitor voltage at t equals to 2 would be 3.4 volts. This will be your answer for the question.
Yeah, this is very straightforward. Amplitude of the fundamental frequency component and average value of A, and A be the average value of the signal. So very straightforward question, very straightforward. So cos square t plus cos square 2t plus 2 cos t cos 2t. So what this would become? Cos square t, 1 plus cos 2t by 2, 1 plus cos 4t by 2, 2 cos a cos b. So cos a plus b plus cos a minus b. cos A plus B. Why I am putting 2 here? So 2 cos A cos B is cos A plus B plus cos A minus B. So what you are getting? 1 by 2, 1 by 2 will become 1. Cos T plus 1 by 2 cos 2T plus cos 3T plus 1 by 2 cos 4T. 1 by 2 cos 4T, 1 by 2, 1 by 2 become 1, 1 by 2 cos 2T, 1 by 1 cos 3T. So what you can see here, this is the average value. These will have 0 average value, 0 average value, 0 average value and 0 average value. So average value here is 1. So what is the value of A? That is 1. And what is the amplitude of fundamental frequency component? That is also 1. So H plus A, Himanshu Agarwal. Okay, H plus A, Himanshu Agarwal is 1 plus 1, 2. Right, so answer is 2. Okay, well and good. So here I will change the limit from 2 to 2 I will put. Okay, so answer is 2. Yeah, let's go to the next one.
A cylindrical rotor synchronous motor is operating at full load with a load angle of 30 degrees. So I have a motor, right? I have this terminal voltage that is coming, and of course it is a cylindrical rotor, so it will have some reactance JXS, and it is operating with a load angle of 30 degrees, right? So basically, if let's say Vt was at angle 0, so this will be, assumption is this will be at minus 30. Okay, just we're taking some values, just some example. It is connected to an infinite bus. Which of the following statements is slash are correct? If the shaft load is suddenly increased to 1.5 times the full load value, okay, if it is increased to 1.5 times the full load value during the first swing, the speed of the motor will increase monotonically. Okay, so what does it mean? Basically, if I suddenly increase, if the shaft load is suddenly increased, okay, so basically what is happening here, right? What is our accelerating power? It is what comes first. First I gave the electrical input, right? Then and that is converted into mechanical output, right? So PM is the mechanical output, P is electrical input, so it will be input minus output. Input will always be greater. That's then only my motor will rotate, right? Not always, sorry, not always. Initially it will be greater, and at steady state both of them will be equal. Basically your accelerating power would be 0. Now what they are telling me, that they are increasing the shaft load. So if the shaft load is increased, your accelerating power will reduce, because at steady state your PE will be equal to PM. So actually your accelerating power will be negative, right? If it is negative, your shaft will deaccelerate. It will not, first of all, increase, and the second point being, it will not deaccelerate monotonically. What will happen is that if this is the graph, right? If this is the graph, then so initially, okay, initially the load angle is 30 degrees. If the load angle is 30 degrees, then if I use the simple formula, so initially this is the graph of the electrical power developed. So at 30 degrees, I will be lying somewhere here, half of the peak load, right? Half of the peak load. Just give me 1 second. So this particular line will be at steady state. That is, this will be what? If this is PM maximum or P max, this will be P max by 2, right? P max by 2, I'm just writing in rough. That will be equals to my electrical input. Now electrical input is constant, right? Your mechanical load is changing. So if your mechanical load is changing, what will happen? Basically this difference will increase, right? Because this is the electrical power, right? And the demand, if I keep on increasing my demand, right, PM will, okay, sorry, this is the PM, right? Okay, yeah, this is the PM, where PM is equals to P. Yeah, this is the PM. Okay, so P is equals to this, that is constant. P is not changing. Okay, this is the P line, and this is the load curve demand. If the delta increases, what will happen? Obviously the PM will increase. Okay, so what they are telling me is now, so yeah, okay, whereas I was in the first option, right? Here I was telling you that what will happen if suddenly your PM is 1.5 times the full load value. What is the full load value? What is the full load value? So they are telling me that it is operating in full load. So currently your PE is equals to your PM, right? The output power, because it is at steady state, that is equals to P max by 2. Why P max by 2? because if you remember, your PE is equals to VTEF by XS into sine of delta, right? That can be written as Pmax into sine of delta. So all of it depends on the delta only, right? So currently the delta is 30. So your PE and PM will be Pmax by 2. Now they're telling me this is my full load. This is my PM full load, right? Now what they're telling me? They're telling me that double the if I double the input, okay, sorry, if I double the motor load, so currently it is Pmax by 2. If I make it Pmax, so not double, sorry, if I make it 1.5 times the full load, so 1.5 times is 3 by 2 of Pmax by 2. So currently I'm changing it to 0.75 of Pmax, right? So I'm changing my PM somewhere here. What is my P? P is here. So what will happen? There will be some deceleration because your accelerating power is negative. So this will be the new steady state. Certainly this will be the new steady state, right? That will be delta 1, let's say. But what will happen? The rotor will swing around the steady state. So initially what will happen? The speed will reduce and then again the speed will increase, and this will this will keep on happening. It will oscillate around its steady state. After the oscillations are died down, this will be at this new value, that is delta 1. But it will not monotonically, first of all, it will not monotonically increase. It will decrease actually. Initially it will decrease and then again it will increase. All this has been taught to you in the full course, right? So it will decrease, increase, decrease, increase. So it will oscillate around its stable position. So it will, like, the behavior will definitely not be not monotonic. Okay, it will be it will increase and decrease, right? It will not be monotonic. So option A is anyways wrong. Option B, if the shaft load is suddenly increased to 1.5, the full load value, the motor may lose synchronism. The motor loses synchronism when your load angle becomes more than 90 degrees. This has been taught to you. In this case, what is our load angle? It is certainly not greater than 90 degrees, because if your load is equals to Pmax, then only we will lose our synchronism, because it will never be able to reach back to its state. This has been taught to you. In this case, our load, right, is equals to 0.75. That at steady state this will be equals to P will be equals to PM, this will be equals to P max sine delta, right? And from here, if you compute the value of delta, right, so this is basically 0.75 sine inverse, that is delta is coming out to be 48.59 degrees, that is approximately 6 degrees. Certainly we have more range, our motor will certainly be in synchronism. This statement is also wrong. It will not lose synchronism. If delta is greater than 90, it will lose synchronism. If the shaft load is suddenly increased to 1.5 times the full load value, the motor will oscillate about a new steady state load angle of approximately 48.6 degrees. Absolutely correct. That is what I have been explaining till now. The maximum load that can be suddenly applied to the shaft without loss of synchronism is 2 times the full load. This again is correct. What is full load? Pmax by 2. If I make it 2 times the full load, your current load, right, PM becomes Pmax, and in this certain case, my delta is 90 degrees. In this certain case, my delta is 90 degrees. If I give any load beyond this, of course motor will lose synchronism. This is the edge case, just stable. Okay, this is just stable. So it will be on the verge of losing synchronism at this particular case, right? So yeah, maximum load would be 2 times the full load, that is P max actually, right? So option C and D will be the correct answer of this question.
Very straightforward. H of n is given, y of 0, y of 1 value is given, you need to find out the value of x of 1. And x of n is a causal system. That means there will be x of 0 involved, there will be x of 1 involved, x of 2 involved, and all these points will be involved. And I know that y of n is nothing but x of n convolved with h of n. Can you find out the value of h of 0? H of 0 would be 1. Can you find out the value of h of 1? So that would be 1 by 4. Can you find out the value of h of 2? That would be 1 by 16. So x of 0, x of 1, x of 2. 1, 1 by 4, 1 by 16. So this will be x of 0, 1 by 4 x of 0, 1 by 16 x of 0. x of 1, 1 by 4 x of 1, 1 by 16 x of 1. I guess these two would be enough. So x of 0 would be equals to y of 0. X of 0 would be equals to y of 0. That means it would be it would be 1 by 2. And x of 1 plus 1 by 4 x of 0 would be equals to y of 1. Y of 1 value is given as 1. So this is 1 minus 1 by 8. Answer would be 1 minus 1 by 8. That means 7 by 8. So if you do 7 by 8, what you are getting? 7 by 8, 0.875. So answer would be 0.875, rounded off to 3 decimal places. Very straightforward, very easy. I don't think solution is required for this one. Okay, simply write down these values, x of 0, 1 by 4 x of 0, 1 by 16 x of 0, x of 1, 1 by 4 x of 1, 1 by 16 x of 1. This will be y of 0, this will be x of 1 plus 1 by 4 x of 0, that would be equals to y of 1. Okay, so put the value, you will get the answer.
A single phase induction motor consumes 12 megawatt of power. So it consumes 12 megawatt of power at lagging power factor of 0.6. To improve the overall power factor of the system, so I want to improve the power factor of the system to 0.8 lagging, right? The a capacitor is connected in parallel with the motor. So basically capacitor load is connected in parallel with the motor. I have this motor load. Assuming that the motor's real and reactive power remains same, so whatever the motor is demanding, these are same, right? Determine the reactive power delivered by the supplied by the capacitor. So this is a very basic simple like question that I have explained multiple times from class notes. So the extra reactive power demand that the capacitor needs to deliver, if the like if I want to improve the power factor, will be P PL into tan phi 1 minus tan phi 2, right? So PL is equals to 12 megawatt. Okay, what will be phi 1? So this is 0.6, right? 0.6 is 36.86, I guess. 0.6 is cos inverse of 0.6 is, so not 36, 53.13, and 0.8 would be 36.86. So 36.86. Okay, so it's very like this kind of questions we have done multiple times in class notes and class as well. So this will be 12, they have asked in MVAR, so this will be 12 megawatt into tan of, so tan of phi 1, tan of phi 1 would be, so basically you can directly compute what is your sin phi 1. Sin phi 1 would be 0.8, right? What is your cos phi, sin phi 2, it will be 0.6. You can use the Pythagoras. So this will be actually tan phi 1 would be uh, sin phi 1 upon cos phi 1. So this is actually 4 by 3 minus this will be sin phi 2 upon cos phi 2, that is 3 by 4, right? So this value would be 12. I'm just doing a shortcut, you can use calculator, no worries. So 16 minus this will be 12, right? Yeah, so this will be 12 will be cancelled actually. 4 by 3 minus 3 by 4, so yeah, 12 will be cancelled. So this will be actually 7. So 7 would be your answer for the question, 7 MVA. Okay, simple formula based question. I hope I don't need to explain. If you are not able to understand, you have to go and watch the RPO videos. There these kind of questions have been solved. Two Boolean functions f1 and f2 are defined as this. If a new function f3 is equals to f1 dot f2, how many essential prime implicants does f3 have? So basically it is ANDing. So they are asking me how many essential prime implicants does f3 will have, right? So do remember what is f1 dot f2? Do remember it? So basically whatever is the common part that I will consider, right? Whatever min terms are common between f1 and f2, that will be the min terms of f3. I hope you remember this property. If we are ORing it, then we will do union. If I am ORing, then we will do union of the min terms, and if I am ANDing, right, then I will do intersection of the min terms. So what are the min terms of f2? I know the min terms of f1 because it is already represented in the min term fashion, but what are the min terms of f2? So min terms of f2 would be just the opposite, right? So it will be summation of m 0 to 4, 1 2 3 4 5 6 7 8, 9, 10, 11, 12, and of course it's a like 4 variables, so 13, 14 and 15. So what are common? So I see a lot of things common. 0 is common, right? So the common, right, min terms of f3 would be 0. Then 1 is not common, 2 is not common, 4, 5, 6, 6 is common, 6, 7, 8, 6, 7, 8 is common, 6, 7, 8 is common certainly. And then I see 13 is not there, right, and 14 is not there, 15 is there, right, 15 is common. So these are my min terms basically. I hope you got the point. Now, yeah. So they are asking me how many essential prime implicants does F3 have? So for this, unfortunately, we will have to uh, draw the key map actually for this. So 1, 2, 3, 4, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and 15. So 1 will be here, 6 there will be 1, 7 there will be 1, 8 there will be 1, 15 there will be 1. So so this can be made as a group, right? I should have used a different color. So there are 5 minterms, right? So this can be made as a group and this can be made as a group. So uh yes, so basically all of these are uh how many essential prime implicants do I have? So I see that I can make 3 groups, right? I can make 3 groups and all 3 are my essential prime implicants here, correct? Why they are my essential prime implicants? Because a single group I can, like, there is at least one element, one literal in a single group that is not connected with any other group. In this example, let's say this is alone and this is only connected to this group, right, not connected with anyone, and these two are connected on only this group, they are not connected with anything else. So total I have total 3 prime implicants and those 3 are my essential prime implicants. So total I have 3 essential prime implicants. This is the answer of my question.
Yeah, so this problem, I know a lot of people would have struggled here. I will try to give you the maximum of the concept, okay? Because the concept of ROC is not taught that much in depth. I know a lot of people study concept of ROC in a very surface level, whether it is for jet transform or it is for Laplace transform. If you need to see the in-depth concept of ROC, then you can go to this particular video. Okay, a very good video it is, 6 hours of video. There I have given the ROC concept for jet transform as well, Laplace transform as well. When we talk about Laplace transform, we talk about these poles, but we forget about s equals to minus infinity and s equals to plus infinity. When we talk about z transform, we talk about z equals to 0 and z equals to infinity, right? But in the Laplace transform, we forget about these two guys, and these two guys are very important. This year or next year, whenever, if they want to frame a good question from ROC, they will talk about these two guys. In this question, the discussion is around these two people only, s equals to minus infinity and s equals to plus infinity. So in-depth concept, if you want to learn, already you know most of the things, you can spend 1 or 2 hours, you will be able to understand the in-depth concept of ROC from this particular video. Already you know most of the things, so let's get started now. Okay, so this is your h of s. Sir, where is the poles? Sir, poles I can see at -1, -2, -3 and -4, but I always say check at 3 points for sure, minus infinity, plus infinity, and check at 0 as well, but 0 is surely not the pole, so let's not talk about 0. So we should always at least check at these 2 points as well. Sir, I could see the pole at -1, -2, -3, -4, but what about minus infinity and plus infinity? Are we having poles at minus infinity and plus infinity or not? So that we need to check, right? So let's write down the h of s again, and then we will do the analysis. So h of s is e to the power s minus e to the power minus s divided by s plus 1, 1, 2, 3, 4. So sir, if I make the S plane, what I can see, sir, I can see the poles at -1, -2, -3, -4. Now, if someone is solving the problem right from here, then what he would do? He would say that, sir, this could be my ROC, so it could be anti-causal. Sorry, if this is your ROC, then sir, this would be causal, and if this is the ROC, then it would be anti-causal. And sir, if this is the ROC, this is the ROC, this is the ROC, that means it would be your non-causal. But you forgot to discuss about plus infinity and minus infinity. Can you find out the value of h of s at plus infinity? At plus infinity, what will happen? E to the power infinity, right? What will happen to this? 0. Infinity, 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 infinity by infinity. What I can do? I can apply L'Hopital rule, right? How will I L'Hopital rule? Look, s is going to infinity. That means s is very large. So this 1 can be ignored, right? 2 can also be ignored, 3 can be ignored, 4 can be ignored. S is going to infinity. I'm not putting the value of s. I'm just saying that if s is very large, then 1, 2, 3, 4 all can be ignored. So can I make, when your s is tending to infinity, then your h of s could look somewhat like this. If s is tending to infinity, this will go to 0. So I'm ignoring this guy. I'm only putting e to the power s. This is going to infinity. So let's have some patience here. But this will be left. E to the power infinity will be left for sure. 1 will be gone, 2 will be gone, 3 will be gone, 4 will be gone. Because s is very large. If s is very large, this will be 0. I don't need to write it down. If s is very large, then s plus 1 can be replaced nearly equals to s only. So all these guys will become s. This will also become s, 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 s. This will become s to the power 4. If I put infinity here, this will become e to the power infinity, which is infinity only, and this will also become infinity. So it is becoming infinity by infinity. Why I did so? Because now the expression is becoming much more simpler. Now I can apply L'Hopital rule. What does this rule says? That you keep on differentiating until you are not getting infinite by infinite form. So if I differentiate one time, what I will get? 4s cube, infinite by infinite form. Again I differentiate, what I am getting? 12s square. Right? Again I differentiate, what I am getting? 24s. Again infinite by infinite. Again I differentiate, what I get? 24. So after differentiating a lot of time, after differentiating 4 times, this is the scenario I am getting. Now here I need to put the limit of infinity. So if I put s tending to infinity now, if I put s tending to infinity, what I am getting? Infinity. That means in this particular expression, if you are putting s equals to infinity, you are getting your transfer function to be infinity. What is the definition of pole? What is the definition of pole? At the pole, your transfer function would go to infinity, right? Why you said -1 is the pole? Because if you put -1 in place of s, what will happen? This will go to infinity. If you put -2, it will go to infinity. If you put -3, it will go to infinity. If you put -4, it will go to infinity. So when I am putting s equals to infinity, then your h of s is going to infinity. What does that mean? If I put s equals to infinity here, infinite by infinite form was there, then I differentiated, I got to know that answer is actually coming out to be infinity. So when I am putting s equals to infinity, my transfer function is actually going to infinity only. What does that mean? That means s equals to infinity is one of the pole for sure. S equals to infinity is one of the pole for sure. So you said that, sir, -1, -2, -3, -4 are the pole, but x equals to infinity is also one of the pole. Is that understandable to you? Okay, so you forgot about this particular guy. Similarly, s equals to minus infinity will also be one of the pole. S equals to minus infinity will also be one of the pole. How is that so? You put minus infinity here, e to the power infinity, it would become, again infinity, it would become, again you do the same thing, apply L'Hopital rule. This guy will be becoming 24, downward it will be becoming 24, upward e to the power minus s will be left, at e to the power minus infinity this will be 0, so this will be gone. So upward e to the power minus infinity will be left, and negative sign will also be there, and downward 24 you will get. And now you put e to the power minus infinity here. In place of s, you put minus infinity. What you are getting? E to the power infinity. That means what you are getting? Infinity only. That means when you put s equals to minus infinity, then also it is becoming infinity only. So if your transfer function is becoming infinity at any point, that point would be known as pole. So when I put -1, -2, -3, -4, I am getting my transfer function to be infinity. That means these guys are the pole. This is also one of the pole, and this is also one of the pole. So we are having 6 poles here. These are known as finite pole, they are infinite pole. But infinite pole plays a very important role in terms of ROC. -1, -2, -3, -4. These are the poles. Along with that, we are having a pole at infinity as well, and we are having another pole at minus infinity as well. at minus infinity as well. Now, what all ROC I can have? Sir, this ROC you can have, this ROC you can have, this ROC you can have, sir, this ROC you can have, sir, this ROC you can have, and sir, this region of convergence you can have. In all the region of convergence, 1, 2, 3, 4, 5, all are bounded, no? All the region of convergence are bounded by poles. This is the pole at infinity, this is the pole at minus infinity. All the region of convergence, all the ROCs are bounded by the poles. This is -1, -2, -3, -4. All these are bounded by the poles. That means here also you will get non-causal. Here also you will get non-causal system. Here also non-causal. Here also non-causal. Here also non-causal. Here also non-causal. So you can never get anti-causal or causal. You thought this would be causal. You thought, sir, this could be causal, but actually it came out to be non-causal only because of the pole at infinity, because of the pole at minus infinity. You thought, sir, this could be anti-causal, but it also came out to be non-causal. So all the systems, whatever the system that you are going to get from here, all will be non-causal. All will be non-causal. That means the system can never be anti-causal or causal. The system can be causal? No. If the system is stable, it has to be non-causal. So where the system will be stable, this will be stable. This will be a stable system. Why is that so? Because it is including the j omega axis, right? So if it is including the j omega axis, that means this will be the stable system. If this is the stable system, that means it is surely non-causal. So if the system is stable, it has to be non-causal. The system will be surely stable? No. Why no? Because, sir, if this is the ROC, unstable. This is your unstable. Unstable. This is also unstable. This is also unstable. And this is also unstable because they are not including the j omega axis. So from this particular expression, we can get 5 kind of systems. What we can get? 5 kind of systems. All will be non-causal and only one of them will be stable. So that's the conclusion you can make from here. From this particular expression, we can get 5 kind of system. All will be non-causal and one of them will be stable. So from here, this will also be gone. So answer will be B and D. I tried to give the maximum concept, but yeah, if you need more in depth, you can surely watch this particular video. The kind of depth you will get in this particular video, you have seen nowhere, neither in books nor in lectures. Okay, so like this is one of my favorite creation of signal system at least. Let's move to the next one.
In the circuit shown, the clock input has frequency f0 and a duty cycle of 25%. Right, so it has a duty cycle of 25%. This clock. So they're asking me for the signal observed at Q, output of the flip flop, which of the following statements is correct. Actually, they should have mentioned assume the initial value of Q to be 0. That I will mention in the question. Assume the initial value of Q to be 0. So it is a 2-bit binary counter. So what happens in a 2-bit binary counter? So in the first, so this is like a edge triggered. So in the first T clock, right, the 2-bit binary counter will be simply 0 0, and we are taking the LSB, right? If you see, we are taking the LSB. Okay, so here also again we are assuming that the count is starting from 0 0, but even if you don't assume, right, if you assume that it is starting from 1 1, your result will be same because this waveform will be periodic. So although it does not matter, but it's safe to assume with the initial state 0 0. So after the first T clock comes, the output changes to 0 1. Before that it is 0 0. So if it is 0, right, Jk is shorted, that is 0, and when Jk is shorted and it is set to 0, it is nothing but memory, right? And memory, we are telling you initial value was 0, so it will remain at 0, it will not change. Correct. So in the first clock, right, so first clock pulse, before the first clock pulse, outputs were 0 0, so nothing happens. Correct. So my output Q, so this is my clock, right, and the duty cycle of the clock is 25%. So the time for which the clock will remain high will be much lower than it remains low, right? So let me show it properly. This will be the duty cycle of the clock. So during the first positive edge, because it is a positive edge triggered, because there is no circle drawn, the Q, right, before the first clock edge, the Q would be 0. Now just after the first clock edge, what will happen? Just at the clock edge, the LSB will change to 1. As soon as it changes to 1, what will happen? this will toggle, right? So before it was 0, it will toggle. So your Q also will toggle here, right? Because J, K both are 1, and we know if J, K both are 1, output will toggle, right? Nothing happens here. And then again we wait for the next clock H. So this particular transaction is 1 T clock, 1 clock period. In the next clock H, what will happen? Your counter will now go from 0 1 to 1 0, right? So your LSB will be 0 now. This is the LSB, this is the MSB, correct? So if LSB is 0, nothing will happen, right? JK both are 0, it will be memory, so it will hold its value. Now again next clock will come, correct? As soon as the next clock comes, your LSB again becomes 1. As soon as it becomes 1, then again this will toggle, right? Your Q will toggle, and again the next clock will come. If the next clock comes, what will happen? I will again restart because it is a 2-bit binary counter. So 1 1, again it will go to 0 0, which is again a memory state. So essentially what is happening, right? At every clock pulse, once we will toggle, once we will store the data. So essentially our period is actually 2 T clock. If you see at this edge, right, again we will toggle. So essentially if you see, this will be, this whole thing, right, will be 2 T clock. Hold on a second. This is 1 T clock. Let me mark it like this. This will be the best way to mark 1 T clock. Yeah, actually no, this will, okay, this will not be 2 T clock, right? So this is happening at after 1 T clock we hold the state, then in the next T clock we toggle, and again in the next T clock what happens, we toggle again. In the next T clock I will hold the state, right? And again in the next T clock finally I will toggle again, right? So basically I'm toggling, then I'm holding in the next period, then I'm toggling, and then I'm holding in the next period, right? So overall this is a 4 T clock, 4 T clock. That is the period of my Q, right? What is the duty cycle? Duty cycle is 50%. So for 50% of the time you see it is 0, for 50% of the time it is 1, right? So duty cycle is 50% and the period is 4 T clock, that is 1 by 4 T clock, right? And 1 by T clock, 1 by T clock is given as F naught, right? F naught is given, that is the clock input. So it is essentially F naught by 4. So your output frequency would be F naught by 4 and your duty cycle would be 50%. So option A will be your answer for this question. For the ideal operational amplifier, calculate the output voltage VO. So we will have to calculate the output voltage VO for the ideal operational amplifier. So first of all, you can solve it easily if you know the formula, right? So what is the formula? So if you remember, this is nothing but a R2R ladder DAC, correct? This is nothing but a R2R ladder DAC. So if it is R2R ladder DAC, I hope you remember how to compute it, right? So basically you have the bits. So this is your MSB. It is a 4-bit R2R ladder because this 4 will be my bits basically, right? So I will solve it with basics as well. Have some patience. I will solve it with basics as well. So B3, B2, B1 and B0, correct? So I see that if B3 is grounded, that means B3 is 0, right? B3 is simply 0. So B3 is 0, B2 is 1, okay? B1 is 0, B3, B2, B1, B0. B1 is 0 and B1 is 1. Sorry, B0 is 1, right? So your, what is the output of the op amp? Basically VO. VO would be the gain of this amplifier. How to compute the gain? So first of all, you compute the RTH from here, right? For a R2R ladder, don't worry, I will solve with basics as well. Have some patience. I will tell you the method too. But first, I am telling you the fast approach. For a R2R ladder, right? This resistance, if you see, this is 2R, that is R. Again, this R and R will be in series, that is 2R. Again, this will become R. Again, this will become 2R. Again, this will become 2R, right? Hold on, RR, R2R, R again here, 2R, 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 R. This will be 2R again, 2R, 2R, R. So ultimately, the voltage here, right, will be basically here. There will be some VTH, and this RTH would be simply this R plus 2R, that is 3R. and then I have the feedback register and then the output VO. This is grounded. So I hope you know what is VO basically. VO would be basically here, it would be minus R2 upon R1 into VTH. So R2 is 3R upon 3R into VTH, that is minus VTH. So your VO is minus VTH. What is VTH? So I will tell you the basic as well, but first I am telling you how to solve it in a fast manner. So VTH will be Vref divided by 2 raised to power n, right? It is a 4-bit DAC, R2 DAC, so it will be 2 raised to power 4 into Vref is how much? Vref is this reference voltage, right? That is 1.6 volts. So this will be 1.6. So let me write the formula, and don't worry, I will solve with basics as well. Don't be scared. This will be B naught into 2 raised to power 0 plus B1 into 2 raised to power 1 plus B2 into 2 raised to power 2, that is 4 basically, plus B3 into 2 raised to power 3. Correct? So yeah, just give me 1 second. Yep. Now, so your B3 is 0, B1 is also 0. So essentially this becomes Vref is 1.6 upon 2 raised to power 4, that is 16. This will be 1 plus V2 is 1, so that is 4, right? So basically 5 into 1.6 upon 16, that is 0.1. So that is basically 0.5. So your VTH is 0.5. So your V naught would be minus 0.5, and this will be your answer. Okay, I do agree. Do you have to remember this formula? Up to you, but we can derive it. Okay, we can derive the value. So I hope you understand how to get the RTH. That is very simple, right? 2R parallel, you can do it. You can calculate the RTH. That's very simple. Short it and you can do it. What about the VTH? So for the VTH, this Himanshu sir has already taught. I will just teach you once again. So 2R is here. 2R is here actually. So let us first consider for this 1.6 volts, right? Then I will consider for this 1.6 volts. So I'm using superposition and I'm computing the Thevenin voltage at this node due to this 1.6 volts. Then I will consider this source. So let me first consider this source, that is 1.6 here. This is 2R, and then we have R, 2R. This is grounded. Everything is grounded now. This will be R. This will be 2R. This is also grounded, and I think with the final one, R and 2R. 2R, and I'm computing the voltage VTH at this node. Seems very difficult, right? It seems very difficult. What you can do is, from this node, I can actually again compute the Thevenin voltage from this node. Okay. So if I compute the Thevenin voltage from this node, what will be the Thevenin voltage from this particular node? And RTH, the RTH would be 2R parallel with 2R, that is nothing but R. And what is the VTH? VTH will be the open circuit voltage here. So if this point was not there, right? So it will be 1.6 divided by 2, because simply the voltage will be divided by between 2R and 2R. So this voltage will be 0.8 volt. Okay, and already there is R, again 2R. Again you will repeat this experiment, right? So again you will compute the Thevenin voltage here. Again you will see, again it will be divided. So at this point the voltage will become 0.4. Same, and your resistance will be R only. Thevenin resistance at this node will be R only, right? 2R parallel with 2R. Again at this node the voltage will be 0.2, and at this node finally the voltage you will get is 0.1. Get my point? So actually your VTH will be 0.1 at this point. Now what about for this particular source? You will have to divide once. It will be 0.8. how many times, sorry, so once this voltage will come here, right? This voltage will come here, VTH, that will be 0.8 here. You can do the simplification, I'm not doing it, time constraint. And then again this will be divided, again you can compute the VTH, it will come 0.4 here, right? So technically due to this 1.6 you are getting 0.4 VTH, and due to this 1.6 you are getting 0.1. So here what is the addition? 0.5, and that is what we had computed here as well, right? So yeah, longer method but basics. So it's up to you what you want to do, both ways works for you, but yeah, this will be longer, but if you find out the way how to do it, right, in a faster manner, you can solve it here as well in a faster manner. So voltage is simply getting divided by 2 and 2. I'm talking about the VTH, not the exact node voltage. I'm talking about the VTH. Make sure you remember I'm talking about the VTH. So for this question, the answer would be minus 0.5.
Yeah, so let's solve this one. xt is given. You need to find out the power of x. You need to find out the energy of xt. So basically, this is something we need to find out. X square t dot dt. So can I break the xt in this manner? It can be written in even component and its odd component, right? Square dot dt. So what it could be written as, if I just open it up, a square plus b square plus 2ab, right? Now I will integrate separately. Now just let me know what this would be, even or odd. Even multiply with odd. Even multiply with odd. If you put minus t here, this will be as it is. If you put minus t here, minus sign would come out. So this would be a odd function, no? Now just simply think of it, no? Even function is a cosinusoid and odd function is a sinusoid. If you multiply both of them, what you will get? Cos t multiply with sin t. What you can do? Multiply and divide by 2. So sin 2t by 2. What is sin 2t? Odd function only. So even multiply with odd, you will get odd only. Very simple thing, right? Basic mathematics. Odd multiply with odd. What you will get? Odd. Sorry, what you will get? Even. Odd multiply with odd, you will get even. Sin t multiply with sin t. What you will get? Sin square t. In place of t, if you put minus t, what you will get? Sin square minus t. Sin square minus t would be minus sin of t whole square. What you are getting? Sin square t only. So in place of t, if you put minus t, you are getting the same function. What does that mean? It is even. And even multiply with even, surely you will get even only. So this is also even. So this is odd. Now integration of odd from minus infinity to infinity. Let's just say this is a odd graph, right? This is a odd graph. You integrate it. Positive area multiply with this is positive area, negative area, positive area, negative area. What will be the total area? 0. So this will throw 0. And what is the case of even? So this is a even graph. This is a even graph. So what is the area? Whatever the area you get in positive side, the same area you will get in negative side. So now how it can be broken? It can be broken into, this is how it can be broken. So it can be simply 2 into from 0 to infinity even square t dot dt plus 2 into from 0 to infinity over square t dot dt. Because this will be gone, this will be 0. Even square t dot dt from minus infinity to infinity. So it will be twice of it. So here 2 would come, here also 2 would come. Why is that so? Because whatever the thing that you are getting from minus infinity to 0, the same thing you are getting from 0 to infinity as well. Now this value is given as 3 and this value is given as 2. So 2 into 2 plus 2 into 3, what you are getting? 10. Straightforward. Again, very straightforward, I would say. This type of question has to be solved. In the examination, these kind of questions has to be solved. Okay. Even multiply with odd, that would be 0. And then even into even, that would become even. Odd into odd, that would also become even. Then area of even this would be 2, this would be 3. 2 plus 3 multiply by 2, answer would be 10. I think a lot of people would have solved it without using the pen as well. Without using the pen. They would know this would go to 0, they would be doubled. So simply answer would be 3 plus 2 multiply by 2, answer would be 10. Let's go to the next one.
In a power system load flow study, the Newton-Raphson method in polar coordinates, the Jacobian matrix is of order 100. The system contains one slack bus, 20 PV bus, with all remaining buses being PQ buses, right? So determine the total number of buses. Determine the total number of buses of the system. Okay. So the Jacobian order of the Jacobian matrix is 100. Do you remember what does my Jacobian matrix tells me? So the Jacobian matrix basically tells me the total number of what? Number of voltage, magnitude of voltage, unknown voltages, and plus unknown power angle delta, right? That is what my order of Jacobian tells me. These are my number of state variables, right? So total overall, if the order is 100, then number of unknown voltages and number of power angle delta is 100. Okay, this is what I know. Now the system has 20 PV buses and one slack bus. So in a slack bus, I know, if let's say if the total number of buses is n, if I have one, like one is slack bus, then I have n minus 1 total number of buses, right? Okay, let me keep it n only, and I have, these are my total number of buses. I have one slack bus in which both voltage and the power is known, and I have 20 PV buses. So in 20 PV buses, what is known? Voltage is known, angle is not known, right? So I have 20 of this in which the power and the voltage is known, and remaining, how many buses are remaining? The remaining are the load buses, right? So that is basically n minus 21, in which the power and the active power is known, right? So in which kind of buses the voltage and the magnitude is not known, magnitude of the voltage and the power angle delta is not known. So in this, right, I have 20 buses whose power angle is not known. In this, I have 2 into n minus 21 whose both, why 2? Because I don't know the voltage magnitudes, so that will be n minus 21 buses. Also, I don't know the angle magnitudes. These are load buses, right? So overall, 20 plus 2 into n minus 21, this will be the order of the Jacobian that is given to me as 100, right? That is given to me as 100. So order of the Jacobian is 100, correct? So if order of the Jacobian is 100, so your answer would be, this will be 2 plus 2n minus 42 equals to 100. So your n would be equals to what? This will be minus 22, minus 22, 2n would be equals to 78, right? So your n would be equals to 64. So your total number of buses would be equals to 64. I hope I'm not doing any mistakes over here. This is n minus 1, 42, yeah, 2n minus 22, 22. Okay, sorry, this will be 122, right? Sorry. So this will go add, yeah, sorry, this will go there, it will be added. So this will be actually 61. So your total number of buses of the system will be 61, and 61 will be your answer of the question. In a 5 bus power system, a 3-phase fault at bus 2 results in fault current of this much, right? So a 3-phase fault is this much at bus 2. Okay, we have a 5 bus system. So do you understand how do I compute the 3-phase fault? With pre-fault fault voltage to be equals to pre-fault bus voltage to be equals to 1 pu. So basically, if I convert my whole equivalent circuit about the bus 2, I will get a xth1. If I want to compute the fault current for a 3-phase fault, I will get a vth1, right? That will be 1 angle 0. That is 1 pu that is given to me in the question. So basically what they're telling me that there is a 3-phase fault, right, to ground. So what is the fault current? So I have just drawn the equivalent circuit when there is a 3-phase fault. That is equals to this 1 upon j into xth. This is j, right? J into xth1, and that is given to you. This value is j minus j 3.33. So this value is minus j 3.33. So from here you can actually compute what is your xth1. Xth1 would be 3 by 10, that is 0.3 pu. So you got your xth1. Now they're telling me that a single line to ground fault at bus, okay, I think this should be bus 2. This is not 3, this should be 2. Bus 2 produces a fault current of minus j 3 pu. So in the same bus, what is happening? A single line to ground fault is happening. Do you understand in single line to ground fault what happens? So in single line to ground fault, all the sequence networks are in series. So basically you have your 0 sequence network, jx naught. Then you have your positive sequence jx1. Okay, basically jxt naught, Thevenin equivalent negative sequence, and of course your Thevenin equivalent positive sequence jxth1, and of course you will have the voltage source connected, that is your vth1. That is equals to 1 angle 0, that is given to you, and you have the single line to ground fault. So this current is what? This is not your fault current, this is your zero sequence current ia naught, right? So your fault current is 3 times ia naught. I hope you remember, right? Your fault current will be 3 times ia naught. So your fault current is equals to 3 into ia naught. What is ia naught? Ia naught would be 1 upon j into xth1, that is 0.3. Now if you read the question further, they have told you that the positive and the negative sequence impedances of the system are equal. So basically whatever is your xth1, the same thing will be copied to xth2. So this will be plus 0.3 plus this thing I don't know, xth naught, that is what I have to calculate, and this value, right, fault current is given as minus j 3 pu. So this is 3 pu minus j 3. So yeah, this would be 0.6 plus xth naught, that is equals to 1, right? So xth naught equals to 0.4 pu. Okay, xth naught is equals to 0.4 pu. That is what your xth naught is equals to, right? So yeah, now what they're telling me, under these conditions determine the magnitude of the fault current when a double line to ground fault occurs at the same bus. So if a double line to ground fault is occurring, do you remember what used to happen? So if a double line to ground fault is occurring, basically your all the networks, right, will be in parallel. So this will be 1 angle 0, 1 pu. This will be jxth1, that is j 0.3, and your negative sequence network also will be in parallel, and your zero sequence network also will be in parallel, that is j 0.4, right? Now you will compute your ia naught. If you know your ia naught, right, if you compute your ia naught, your again fault current will be 3 into ia naught. You will have to compute the magnitude of the fault current in this condition, right? So what will be your ia naught? For that I will reduce my circuit, right? So I will reduce it to vth and xth. So vth is what? If I open, what is the open circuit voltage? So the open circuit voltage will be this 1 volt will be equally divided between 0.3 and zero point 0.3. So this will be j 0.5, right? So your vth actually is 0.5 pu. Remember, this is the VTH, not the actual voltage. This is just the open circuit voltage. What is your XTH equivalent here? It will be 0.3 parallel with 0.3, that is J 0.15, and of course I have the load connected, that is J 0.4. So your current IA naught current would be 0.5 upon 0.15 plus 0.4, that is equals to, let me compute this, 0.5 upon 0.55, that is equals to 0.9. J is there, so minus j 0.91. Okay, this is the amount of current, right, ia naught, but the fault current will be multiplied by 3. So your fault current would be magnitude of 3 into ia naught, magnitude of the fault current, that would be equals to 2.727 pu. Okay, so they have asked us to round off to 2 decimal places, so this will be 2.73 pu. This will be the answer of your question.
Yeah, so what about this one? What is the Fourier transform of what is the discrete time Fourier transform of signum m? So you are supposed to remember this particular data directly. Answer is minus j cot omega by 2. But if you don't remember it directly, then you can derive it. So how signum n could be written? Signum n definition is also given. So how you can write down signum n? So definition could be written in this manner. You can see the graph 1, 1, 1, and then minus 1, minus 1, minus 1. This is minus 1, this is minus 2, this is 1, 2, 3, and at 0 it is 0. So can you write down the definition? Surely I can write down the definition, sir. It should be written in this manner. Say yes or no. Is this correct? Yes, sir. And then in the negative side, sir, it should be written somewhat like this. Is this also correct? Absolutely correct. So this is how you can write down the definition. Understandable? Okay. So once you have written the definition, can you find out its Fourier transform? Yes, sir. What will be the Fourier transform of delta n? That would be 1. Delta n minus 1, it would be having e to the power minus j omega plus e to the power minus 2j omega plus e to the power minus 3j omega and so on. Now minus. What about this one? Delta n plus 1. So it would be e to the power j omega plus e to the power 2j omega plus e to the power 3j omega and so on. So a upon 1 minus r minus a upon 1 minus r. Understandable? Right? Simple formula I have applied, nothing else. A upon 1 minus r, which is e to the power minus j, e to the power minus j omega, and here e to the power plus j omega. Understandable? Very easy. Now what I can do is that I can solve this one. But what I can do, I would take e to the power minus e to the power. Let's solve this one only. So 1 by e to the power j omega I will write down. What I will get? 1 upon 1 upon e to the power j omega upon 1 minus 1 upon e to the power j omega. So 1 upon e to the power j omega minus 1. This is what you will be getting. Okay, but I need to write down in the same manner. So I am putting this particular thing. You can solve it 1 upon e to the power j omega 1 minus 1 upon e to the power j omega. So e to the power j omega, e to the power j omega will cancel out. This will go here, e to the power j omega minus 1. Negative sign you can take outside. Okay, minus e to the power j omega 1 minus e to the power j omega. Now what do you see here? So minus sign I can take common, e to the power j omega 1 minus e to the power j omega. Now what you can do in this kind of situation, what you need to think, sir, e to the power j theta plus e to the power minus j theta, this is something I will try to make. So what I can do, e to the power j omega by 2 I can take common. So what I will get here, e to the power minus j omega by 2 plus e to the power j omega by 2. Did you understand this point? Minus sign is already outside. Minus sign is already outside. This is e to the power j omega by 2. E to the power minus j omega by 2. Multiply both of them, it will become 1 plus e to the power j omega by 2. Similar thing you will do downward. E to the power minus j omega by 2 minus e to the power j omega by 2. Understandable? Fine. Okay. This and this is getting cancelled out. Let's take this minus sign inside. What I am doing, I am taking this minus sign inside. So what will happen? This will become plus and this will become minus. I have just taken the minus sign inside. Why is that so? Because now I will do divide by 2, divide by 2. Why I am doing divided by 2? This will become cosinusoid. What this will become? Sinusoid. If I need to make it sinusoid, I need to multiply with 2j. That means here I will have to multiply with j. Now this j goes upward, it will become minus j. So now this is becoming cos omega by 2. This is becoming sin omega by 2. Cos omega by 2, sin omega by 2, what that will become? Cot omega by 2. There you go. So you are supposed to remember it directly. Minus j cot omega by 2. What is the Fourier transform of signum n? Minus j cot omega by 2. You should remember it directly. In the examination, it can be asked. Signum n will have minus j cot omega by 2 as its Fourier transform. Okay, let's move to the next one.
The circuit turn-off time of an SCR is defined as the time interval during which the SCR is reverse biased by the commutation circuit. This is a very basic definition of circuit turn-off time. You can follow the RPYQ course. In the full course, everything, everywhere we have actually like explained what does circuit turn-off time means. So option C will be the correct answer for this question. A step-up boost DC to DC converter is operating at the boundary between continuous and discontinuous conduction modes. It is operating between the boundary of continuous and discontinuous conduction mode. So it is in the boundary condition, right? It is just continuous. So if it's a boost converter, do you remember the circuit diagram of a boost converter? So I have this Vs source here, and then I have this switch here, right, which boost the inductor voltage, and then ultimately uh, we have the load. Okay. uh yes, now what are the thing? At certain duty ratio, the average output current, right, IO average, is equals to 1/4 of the average inductor current, that is IL average. Now the output average voltage is maintained at 40, assuming an ideal converter and that a capacitor is connected in parallel with the load to keep the output voltage remain nearly constant, right? The output voltage is nearly constant at 40 volts, and yeah, the converter is ideal. This is my Vs. Now determine the value of the input supply voltage in volts. They are asking me what is the value of the input supply voltage in volts. So okay, if it is just continuous, do I know the duty ratio? No, I don't know the duty ratio, but they're telling me it is just continuous, right? It is just continuous. So can I compute any information regarding the duty ratio? So if it is just continuous, right? If it is just continuous, then I know what is the waveform of the inductor voltage. The average value of the inductor voltage will be 0, right? Because it is just continuous. All these things has been taught to you. So when the switch is closed, the voltage across the inductor is nothing but the supply voltage, Vs. When the switch is open, the voltage across the inductor would be your Vs minus 40. 40 voltage will be certainly higher, so it will go negative. So this value would be Vs minus 40, and this value would be 40, and this will be alpha into T. This will be capital T, right? From this equation, you can actually say what is your Vs. That is fine. That is one thing. And what is your average value of the inductor current? Your average value of the inductor current is nothing but the supply current. Average value of the supply current, because your supply and the inductor are always connected in series, and your IO average is given. So technically, because the converter is ideal, so what is the input power? It is Vs average, that is Vs only, into Is average, right? That is equals to 1/4 of IL. That is equals to your VO average into IO average, right? What is your Vs average? Vs average is Vs, right? Is average is what? It is IL average, right? Because this current and inductor current are same, they are in series. VO average is 40, that is given to me in the question. Output voltage is maintained at 40 volts, and your IO average is basically 1/4 of IL average, that is given in the question. So from this, we don't even need to do anything. We don't even need to do anything, right? So basically your Vs, right, would be equals to 10 volts. This will be your answer for the question.
Yeah, so I hope this question you should not be looking at the solution. Either you can remember by the concept or you can remember by the trick as well. What I have said, continuous will always result in aperiodic. Discrete will always result in periodic, and vice versa. Periodic will always result in discrete, and continuous will always result in, and aperiodic will always result in continuous. Only one thing you need to remember, and rest all will be remembered on your own. If you just remember cap, continuous will result in aperiodic. Now where discrete will go? Continuous and discrete both are opposite to each other, so discrete will result in periodic. Now vice versa, aperiodic will result in continuous and periodic will result in discrete. Basically both goes like forward and backward, both scenarios are there. So just remember cap. Continuous will result in aperiodic, aperiodic will result in continuous, discrete will result in periodic, so periodic will result in discrete. So what is the first thing? Discrete plus periodic. So discrete will result in periodic and periodic will result in discrete. So discrete plus periodic will be periodic plus discrete, which is correct. Next one is continuous plus periodic. Continuous plus periodic. So continuous will result in aperiodic and periodic will result in discrete. Continuous will result in aperiodic, periodic will result in discrete. Periodic will result in discrete. So aperiodic plus discrete. Wait a second. Continuous, okay, it was continuous plus aperiodic actually, but there will be option of continuous plus periodic as well. So continuous plus periodic will result in discrete plus aperiodic. Okay, now continuous plus aperiodic. So continuous will result in aperiodic and aperiodic will result in continuous. So continuous plus aperiodic will be continuous plus aperiodic only. And what about D? Discrete plus aperiodic. So discrete will result in periodic and aperiodic will result in continuous. So periodic plus continuous. So A, B, C, D all are correct. So just remember cap. That's it. Continuous will result in aperiodic. Now both are opposite of each other. So continuous. So discrete will result in periodic. Aperiodic will result in continuous and periodic will result in discrete. That's it. Very simple question, very straightforward. अरे यार वीडियो पॉज ही नहीं हो गया. Yeah, so you need to find out the energy stored in the capacitor C. You need to find out the energy stored in this capacitor. What will be that energy stored? Sir, half CV square, right? Half this capacitor CV square. So answer would be V square. So you just need to find out the potential across this capacitor. This is your question, and then do the square. So what I will do, sir, I can see that 2 1 2 1 2 1 it is being repeated. That means if I say this is my C equivalent, then this would also be my C equivalent only, right? So my circuit can be replaced somewhat like this: 2 1, and this is your C equivalent. This is C equivalent, this is 2 farad, this is 1 farad, right? And C. So C equivalent is coming out to be 2 farad in parallel with 1 plus C. So 2 into 1 plus C divided by 3 plus C. So from here I can directly sense that value of C will come out to be 1. How I can sense it? If I put C equals to 1 here, 1 plus 1 2, 2 and 2 in parallel would become 1 only. So 1 and 1, that is matching. So value of C is coming out to be 1 farad. So from here I can replace the circuit. This C is actually 1 farad. Okay. So now what is the scenario I am having? 2 farad and 2 farad. This is the scenario that I am having. And applied voltage here is 11 volt. So this 11 volt will be divided equally. This voltage will become 5.5 volt. So that means this much of portion is getting 5.5 volt. So here what potential you are getting? 5.5 volt. So 5.5 volt, this is your capacitor C, which is 2 farad. Now then again there is 1 farad, and after this here what is the total capacitance? This is also C only. So this particular setup can also be replaced with 1 farad, and here the voltage was 5.5 volt. Basically I started from here. I got to know that across these two nodes I am getting 5.5 volt. Now this is 2 farad, and here also equivalent is also 2 farad. So 5.5 volt, 1 plus 1, this will become 2. 2 and 2 again equally divided. So here what will be the potential I will be getting? And I need the potential across this 2 farad. So what that potential will be? 5.5 divided by 2. 5.5 divided by 2. I just need to do the whole square. That's it. So 5.5 divided by 2, do the whole square. 7.562. Answer would be 7.56. That's it. 7.56 joule. This is the energy that we are storing. Half CV square, value of C was given. I need to find out the potential. For finding out the potential, I find out the equivalent. That came out to be 1, 1, 1, 2. Potential half divided. Again potential half divided. Again in that manner it will be half, 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 half divided. So this became 5.5. This also will be 5.5. Half CV square applied. I got the final answer 7.56 joule. Let's go to the next one.
Independent measurements of current are obtained from three sensors. The measured values are reported as mu plus minus sigma, where mu denotes the mean value and sigma denotes basically the standard deviation. The measurements are as follows. Assuming the measurement errors are independent, determine the uncertainty I1, I2, I1 plus 2, I2 plus 3, I3. So do you remember what was the formula of uncertainty? Let's denote this quantity as I, that is equals to I1 plus I2, I2 plus 3, I3. So your sigma I, that is basically the uncertainty, degree of uncertainty, that is equals to whole under root of del I1, so del I with respect to I1 into sigma I1, this whole squared, and so on. Like this will go on, right? This will be del I upon del I2 with respect to sigma I2 whole squared, and so on, right? Like this. I hope you remember the uncertainty formula. So we will certainly use this. So what is del I upon I1? That is equals to 1. If I differentiate this function with respect to I1, it will be 1. What is sigma I1? Sigma I1 I can directly see here, right? They were asked in amperes, the same unit as this unit, right? Standard deviation. Sigma I1 is simply 0.02 whole 0.02 whole square. Plus, similarly, if I differentiate this function with respect to I2, this will be 2 into 0.2 whole square, right? Plus, this will be 0.15 3 into 0.15 whole square. So this, if I solve, just give me 1 second. This, if I solve, this will be 0.02 whole square plus 0.4 whole square plus 0.45 whole square whole under root. That comes out to be 0.602, and they have told me to round off to 2 decimal places, so it will be 0.6. That's all. This will be your answer of the question. The power consumed by a balanced 3-phase load is measured using 2 wattmeter method. The average power drawn per phase is 30 kilowatt. Okay, so this is the average power drawn per phase, and the load is balanced. Now if the load is balanced and the average power drawn per phase, what is the 3-phase power measured? It will be 3 times 30 kilowatt, because it is we have been given the per phase power, right? So this will be 90 kilowatt. So 90 kilowatt would be the 3-phase power measured, and this will be the power measured by the wattmeters W1 and W2. So what is the active power measured in 2 wattmeter method? That is W1 plus W2. This is the formula for active power measured. I hope you remember what was my W1 and W2 equals to. So my W1 and W2 were equals to this: VL into IL. One was equals to 30 minus 5, other one was equals to 30 plus 5. Okay, I hope you remember these things. So one of them, it depends on the connection, but these values will be same ultimately, 30 plus 5 and 30 minus 5. Okay, so these were my W1 and W2. Now they are telling me that the load operates at a lagging power factor of root 3 by 2. Basically cos phi is root 3 by 2, it is lagging. Let the readings of the wattmeter be W1 and W2. Let max of W1 W2, basically it is the max function, right? So determine the value of maximum of absolute value of W1 and absolute value of W2 in watts. Okay, so how to solve this? So for that I will obviously need to calculate what is W2 and W1. So it is lagging, right? If it is lagging, what can be my phi? So my phi would be basically cos phi is root 3 by 2, so phi would be 30 degrees, right? Phi would be, yeah, it is lagging, so phi would be 30 degrees. Yes. So phi is 30. So if I replace here 30, right, one of the wattmeters will read what? It will be VL into IL. Okay, so what is the ratio of the wattmeter readings, right? Ratio of W1 upon W2, it will be cos of 30 minus 5 divided by cos of 30 plus 5, right? So this will be equals to, if I put 5 equals to 30, this will be cos 0, that is 1 upon cos of 60. Cos of 60, right? Cos of 60 is half. So W1 by W2 is this. So basically your W1 is 2 times of W2. So I can replace this value here. W1 is 2 times of W2. So if I replace this value here, this would be 2W2 plus W2 is equals to 90. So your W2 comes out to be 30 kilowatt, right? What about your W1? So your W1 would be 60 kilowatt, right? Because W1 plus W2 has to be 60. So now what are they asking? They're asking me, okay, this should be in kilowatts. I'll change this. This unit will be in kilowatts. Okay, this will be in kilowatts. Sorry. So yeah. Now basically the maximum of this is simply maximum of 60 comma 30, that is basically 60, right? So 60 kilowatt would be your answer for the question.
Yeah, so let's see the solution of this one. So here, what is the scenario? What is this make before break switch? That means it will make the connection before breaking the other one. Okay, like if you are moving from A to B, then like basically the scenario is this inductor will be driving some current, right? Inductor will be driving some current. This is driving some current, right? Now you are saying that, sir, I am breaking this connection. This is connection A, this is connection B. You are breaking this connection and you are connecting here. So there will be a time where the connection is broken. Like it will be gone from A as well, it will be not connected to B as well. Like when you have broken the connection from A and you are going towards B, so there will be one time where this current source will be open. What is the meaning of open current source? What is the meaning of open current source? There is no meaning of open current source. That means what is the meaning here? Make before break. What does that mean? That first it will make and then it will break. Is that understandable to you? So this is like, this will not be helpful in solving the problem. But conceptually, if I need to frame the problem correctly, then I need to use make before break switch. Understandable? What is the meaning of make before break? That first it will make the connection and then it will break it. So current source should have some connection, but this is not necessary with voltage source. If this is the condition, you are happy with that, there is no problem. Voltage source could be open, but current source open, what does that mean? You are saying that here 5 ampere current is there, and since it is open circuited, you are saying that 0 ampere current should be there. So 0 ampere 5 ampere doesn't make any sense, right? So that's why make before break switch. Yeah, so now what is the scenario? At t equals to 0, this is connected to A. It will be connected for 1 second. Then what will happen? Inductor is exposed to a constant voltage. What will be the current? It will be developing 5t by L, right? Constant voltage means current would be Vt by L. That would be 5t ampere for 1 second. So current would be built up t from 0 to 1. So current that would be built up is 5 ampere. Now the current that has been built up here is 5 ampere. Now the switch has moved to point B. Now this is the scenario. 1 Henry, then there is a resistance 1 ohm, and then there is 2 Henry. Okay, the current here is 5 ampere. So what you did here? You applied Laplace transform. If you apply Laplace transform, that means you did not study from this platform. You should study from this platform as well. Or if you have studied from gold educators, then you might be applying Laplace transform as well. But you can solve it in time domain as well, because it is a first order circuit. If it is a first order circuit, it can be solved with the time domain analysis as well. What is the scenario? This inductor will say that I will drive 5 ampere current. What this inductor will say? He will say that I will drive 0 ampere current. He will say that I will drive 5 ampere current. Both are in series. Both are in series. One is saying 5 ampere, one is saying 0 ampere. Both guys are in series. What does that mean? That means they will have to shake the hands, or they have to conserve the energy. So what will happen? They will immediately change their current. Okay, you will say that, sir, in the inductor immediate change in the current cannot take place, but it will take place because there is infinite voltage, or there is impulsive voltage. How impulsive voltage, all these points I will not explain now. In the comprehensive course I have explained. So there will be immediate change in the current. 5 0, so immediate change. This 5 will come to what? L1 I naught 5 into 1, L2 I naught 2 into 0 divided by 2 plus 1 divided by 3. So this 5 will come down to 5 by 3 ampere, and this will also from 0 to it will go to 5 by 3 ampere. So this 5 by 3 ampere will be flowing in the circuit like this, 5 by 3 ampere. So this is the current that has been set up at 1 second. Just as the switch is, all this has happened in 0 time. Just as the switch has moved to point B, all these things has happened. So what is the value of IT you are getting? What is the value of current at 1 second you are getting? That is coming out to be minus 5 by 3 ampere. And at the steady state, what will happen? What will be the value of current? What is the value of this current at steady state? At the steady state, both of the inductor will say that, sir, we will be shorted. At steady state, both of the inductor will say that, sir, we will be shorted. If both are shorted, this is 1 ohm resistance. Both inductors are shorted. So how much voltage is there across this resistance? So 0 volt. That means how much current it is driving? 0 ampere. So how much current will be flowing through the inductors? 0 ampere. So at steady state, this current would be 0. So you are going from minus 5 by 3 to 0. From minus 5 by 3 to 0 you are going. But you started at 1 second. What is the value of tau? Both are in series, so both will be added. So L by R, tau value is 3. You started at 1 second. So minus 5 by 3, this is the equation of your IT. Minus 5 by 3 e to the power minus, started at 1 second. Started at 1 second. You need to find out the inductor current at 3 seconds. So 3 minus 1, that would be 2 divided by 3. So this would be your answer at t equals to 3 seconds. So minus 5 by 3 e to the power minus 2 by 3. Minus 0.855 ampere. This is the answer we are getting. So this is the answer we are getting. Okay, minus 0.855 ampere. Understandable? All good? How did you check the direction? Sir, this was 5 ampere, then it became 5 by 3 ampere. Now the current will be flowing in this direction only, no? Previously, when 5 ampere was there, it was flowing like this. Then it became 5 by 3 ampere. So it will flow in the same manner. Understandable? So basically this 5 ampere has developed some current in this particular inductor. So it will flow in this direction. The current direction will not change immediately. From 5 to 5 by 3 we are going in this direction only. So this is how I can define the direction of current. Okay, well and good. Yeah, let's see the next.
The unit step response of a second order closed loop system exhibits a peak overshoot of 40% and a rise time of 1.92 seconds, right? Based on this information, which of the following is the most appropriate approximation of the transfer function, right? So simply they have given, like this is simply a formula based question, right? So they have given you the peak overshoot. Do you remember what was your peak overshoot percentage equals to? So your simple formula, peak overshoot percentage, was simply equals to e raised to power minus pi cos theta into 100, right? That is equals to your percentage peak overshoot, that is given as 40%. What is your rise time formula? Your rise time formula was equals to pi minus theta upon omega. What will come here? Omega d will come. Okay, how do I remember? So there are two things, right? One is the rise time, another one is the delay time. Okay, so your delay time would be, if there is d, right, omega t will not come. Certainly omega t will not come. Okay, so certainly in the bottom I will have omega n. If there is delay d time, omega t will not come, omega n will come. Now with omega n, we remember the pole zero diagram, right, of a second order system. So this, right, real part is zeta omega n and the imaginary part is omega t. So the real part is zeta omega n, right? So with omega n, zeta will come. I do remember, like there will be some in the numerator, there will be 1 plus 0.7 into zeta. Whether this will come with this formula or this formula, how do I remember? If I have omega n in the bottom, then zeta will come. Okay, that's all. This you will be able to remember, but whether it will come with in the TD formula or in the TR formula, how will you remember? You will remember it like this. So if I have D, I will write omega n, right? If I have D, I will write omega n. I will not write omega D. If I have omega n, zeta will come. So certainly this formula has been fixed. So once you remember this formula, automatically you know the other formula, right? It's very easy to remember the formulas, but which time will come with which formula, you don't know. So that's how you will remember these things. So this is my TR, this is my TD. Okay, so yeah, that's all basically. I hope you get the point. Now so the rise time is given, so these values are given, right? So first let me first compute. So here, remember here theta is in radians, right? So let me first calculate theta and then I will come back to the other part. So yeah, if I solve this equation, the first equation, this will be basically 0.4 ln and then inverse and then tan inverse. Okay, just hold on. 0.4 ln then divided by pi, then inverse, then tan inverse. So this is 73.74 in theta is equals to 73.74 degrees, or in radians it would be pi divided by 180. So 1.28 radians. Okay, 1.28 radians. So now uh yeah, now what shall be the values here? What shall be the values? How do I solve the okay, so I got the theta, right? So here the rise time is given, that is 1.932. So from here I can get the value of omega d. Omega d would be pi minus theta, that is 1.28 radian upon 1.932. So this plus pi upon 1.932. So omega d is approximately 0.96. Now if you remember this pole zero diagram, right, this theta is the angle of inclination. So your omega n sine theta is actually omega d, the damping frequency. So from here I can easily calculate the omega n value, omega d upon sine of theta, right? So this upon sine of theta, so 73.74 of sine. Make sure you're properly in radians and degrees. So omega n comes out to be 1. So your the characteristics equation, right, of your transfer function ce would be s square plus 2 into zeta into omega n. So zeta, okay, zeta is cos of this, right? Zeta is cos of 73.74, that is essentially equals to cos theta, that is essentially equals to 0.28. How all these are derived, I've explained this in my full course. So 2 zeta into omega n is 1 into s plus omega n square, that is 1 square. So it is s square plus 0.56 s plus 1. So s square plus 0.561 s plus 1, that is present in option D. So option D is correct for this question. The block diagram of a control system is shown in the figure below and g of s is given. Determine the maximum value of the gain k such that all the closed loop poles of the system lie on the left of the vertical, sorry, this will be plus, there is a typo, left of vertical s equals to plus 2, okay, this will be plus, this will not be minus, just a bit of typo here, yeah. Now what do they mean by left of s equals to 2, real part s equal to 2? So s equal to 2 is this line, this is my s equal to 2 line, correct? So now if they want to see how many poles lie on the left hand side of this, with route I only will be able to comment about s equal to 0, right? So what if I change my s equal to 0? So what if I change my map my transfer function, right? What if I map my transfer function to z plane, where z equal to 0 is nothing but s equals to 2 plane. So this s equal to 2 plane can be mapped to z equal to 0, because if I apply my routes RH criterion on z plane, I will be able to comment how many poles lie on the left hand side of z equal to 0, right? I will be able to calculate the condition. So and z equal to 0 will be nothing but s equal to 2 in the mapped plane. So s equal to 2, right? So I can take my 2 on the other side, s minus 2 equal to 0, and I know this, right, is nothing but z equal to 0. So s minus 2 would be equal to z. So I can replace uh, this here, right? I can replace what? I can replace s with z plus 2. Okay, I can replace my s with z plus 2 in this equation, so that I can map it in what equation? In the characteristics equation, because this is a unity feedback system, this is just the OLTF. So the characteristics equation would be 1 plus g of s equal to 0. So that would be equals to s into s plus 1 into s plus 2 plus k equal to 0. So let me replace my s with z plus 2. Let me map it. So this will be z plus 2 into z plus 3 into z plus 4 plus k equal to 0. Okay, this will not be that easy and simple to compute, but we will try our level best. So this will be actually z square plus 5z plus 6 into z plus 4 plus k equal to 0, z cube 4z square 5z square plus 20z, and yeah, this will be 6z plus 24 plus k equal to 0. So let me rearrange the terms again. Because it's a third order system, I will use my shortcut. Okay, you can totally compute the route table, but I will use my shortcut. So this will be, so I will have to essentially compute for the condition where all the poles are on the left hand side of z equal to 0. So let me rearrange them properly. 9z square plus 26z plus 24 plus k. So I know for the system to be stable, basically for this z plane, for all the poles to lie on the left hand side or the system to be stable, the internal product must be greater than the external product. So basically 9 into 26 must be greater than 1 into 24 plus k. Okay, you can use the route table as well, you will get the same condition, right? So here essentially what is your 9 into 26? So 9 into 26 minus 24, that is coming out to be 210. So your k would be 210. This would be your answer for the question. The terminals of a three-phase 6-pole cylindrical rotor alternator are connected to a balanced load whose per phase equivalent circuit is shown. It is given, so this is the per phase equivalent circuit of the load that is connected with the rotor, with the alternator. It is given that under this operating condition, the armature reaction is purely cross magnetizing. Under this operating condition, the armature reaction is purely cross magnetizing. Determine the rotational speed of the alternator rotor in revolutions per minute. Okay, so what is the speed of the alternator? That is what they are asking me. How do I compute the speed of the rotor? So for computing the speed of the rotor, right, obviously for alternator it rotates in a synchronous speed which is equals to 120 f by p. So I know p, that is 6, so it will be 20 into f. So technically I need to calculate the frequency, but nowhere I can see like nowhere frequency is mentioned. How will I compute the frequency? So one thing they have told me, this is the load that is connected, right, and they have told me that the armature reaction is purely cross magnetizing. Do remember, when is the armature reaction purely cross magnetizing? When, so if you have only synchronous reactance, and when your load is unity power factor. So the power factor of the load cos phi is 1. So if the power factor of the load is 1, right, that means this particular circuit is operating in resonance. So this is technically again condition for resonance, right, because whenever it is unity, that means your circuit is purely resistive. So I can see Henry here, I can see the capacitor has a reactance of minus J4. So technically I have to somehow make this purely real. If this particular impedance is purely real, then this whole circuit is operating in unity power factor. So what is the reactance by this 1 Henry? It will be plus j omega. That's all, right, and the reactance already is given, that is minus j4. So if I calculate the equivalent impedance of this particular block, what will be it? It will be let me write this as only x, okay, jx, that's all, or j omega is also fine. J omega is also fine. So this will be j omega into 4 minus j4 upon 4 plus j omega minus 4. Okay, and this is the equivalent impedance, and of course let me just reduce this in a proper format. This will be j omega into 4 minus j4 into 4 minus j omega minus 4 divided by 4 square plus omega minus 4 square. I don't care about the denominator. All I care is the imaginary part here must be 0, right? If the imaginary part is non-zero, ultimately your power factor will not be equals to unity. So let me first again reduce the terms. Let me reduce the numerator now. I don't care about the denominator. Okay. So this would be, if I just consider the imaginary terms, this will be 4. Okay, let me first multiply these two values, right? Let me first multiply, oh, let me multiply these two values, right? If I multiply these two values, this will be basically 4. So 4 can come outside, right? Or let me multiply. So okay, let me take the j inside, right? That's it. I will take the 4 common, I will take the j inside. So this will be j4 plus 4. Okay, now if I see the imaginary terms, so that is 16j, right? and here also I have another imaginary term, that is minus j4 into omega minus 4. If you notice, I don't care about this 4 omega because ultimately this will be equated with 0 because the imaginary part is 0. So all these, right, denominator and this common part will be vanished. So from here I get the condition that omega minus 4 is equals to 4. So omega is equals to 8. So I get the value of omega, that is 8. If I know the value of omega, I certainly know the value of frequency, right? Certainly I know the value of frequency. F is 8 by 2 pi, that is 4 pi. Sorry, not 4 pi, sorry, 4 by pi. 2 pi f. So it will be 4 by pi. This is the value of f, right? Remember, they have asked in revolutions per minute. That's why this formula will be used. If they would have asked in uh, radian per second, then simply your omega would have been your answer. That's all. Your omega would have been your answer. Okay. Is it so? No. This is your synchronous speed. This is not the rotor speed, right? If you want to compute the rotor speed in radian per second, you'll have to do what? So I know your theta s or theta electrical is equals to p by 2 of theta mechanical. So your omega will be equals to p by 2 of omega m. So omega m would be 2 by p of omega. So this will be the actual speed if they would have asked in radian per second, right? So be very careful. They can ask in radian per second as well. So in our case it will be 20 into f, that is 20, that is 80 by pi, right? So if I calculate 80 by pi, let me just quickly calculate 80 by pi. 80 divided by pi, that is equals to 25.56. So 25.56 would be your answer for the question. 25.56, right? Sorry, 25.46, and you have to round off to one decimal places. So 25.5 revolutions per minute would be the answer for the question. The no load magnetization characteristics and the external terminal voltage characteristics of a DC shunt generator are shown in the figure. Okay, so this is the no load external characteristics, so no load magnetization curve, and this is the load characteristics. When the load is connected, we can see certainly there is a demagnetizing effect. So as you can see from the statement itself, when the generator is operated at its rated load, armature reaction produces a demagnetizing effect identical to that of the indicated in the characteristics. Given that the armature resistance of the generator is 0.5 ohms, so Ra is 0.5 ohms, determine the power delivered to the load in kilowatt under rated operating conditions. So if it is operating in the rated condition, as you can see, they should have mentioned this is the rated condition actually. Yeah, it should be mentioned. I will mention in the statement that this particular voltage is the, this particular 205 volts is the rated condition. Okay, so yeah, so what is the power delivered in this condition? Basically, when the terminal voltage Vt is 205, right? What is the power delivered to the load under the rated condition? So yeah, they're asking me what is the power delivered to the load under the rated condition, right? So when my, so in the rated, this is my rated condition, right? This was my rated condition, that is 205 volt and 5 ampere as the field current. Okay, it is a shunt, it is a shunt generator. Now the thing is, as soon as I connect the load, right, it has some demagnetizing effect. Although you are operating your motor at 205 voltage, but it has some demagnetizing effect, right? Due to which, of course, your field current will reduce, because what is happening? Your overall field flux is reducing, right? That is basically reducing your field current. And there are certain things as well. I will explain. So let's first draw no load. So in no load, I have this Ra, and I have the motor, sorry, generator, and I have the shunt resistance RSH. This is Ra, and this is my terminal voltage. So under no load condition, this current is zero, right? So whatever current armature is delivering, it is same as the field current, right? So at no load condition, I see that 5 volt is the field current. This is equals to 5 volt, And what is the drop across the RA? It will be very small. So 5, what is the armature resistance, that is 0.5, it is 2.5 volts. So the drop across the RA is 2.5 volts. And I see that the terminal voltage is 205 volts, right? So this is my VT, that is 205 volts. So I can certainly calculate what is my RSH, right? RSH would be this voltage upon the field current, that is 205 upon 5, that is 101 amperes, right? That is my field, that is my that is my shunt resistance. Okay, so this particular information is only used to calculate the shunt resistance. Now few more things I want to calculate. Now what is happening, as soon as I connect a load, as soon as I connect a load, what is happening? As soon as I connect a load, there is a drop. This drop is what actually? This drop is not nothing but the IARA drop, right? The terminal voltage is suddenly reducing. What can reduce my terminal voltage? It is only this, right? IARA drop. So as soon as I'm connecting the load, there is some drop, IARA drop, that is happening, that is expected. So there is some IARA drop. So I can see the IARA drop to be exactly 20 volts. So 20 volts is the IARA drop, right? So IA into RA is equals to 20, right? And RA is 0.5. So when the motor is operating at full load, right, the IARA drop is 20 volts. So IA full load would be what? It would be RA is 0.5, so it would be 40 amperes. IA full load would be 40 amperes, right? Okay, so it is 40 amperes, right? Now how to solve this? So we got our IA full load, right? If I know my IA full load, what is the field current? So the terminal voltage is given to me, right? So what happens then? Of course, after connecting the load, there is bit of demagnetization effect, due to which the field current also reduces. What is this field current? I don't know, but I can certainly compute, right? How can I compute? Uh, by computing the terminal voltage, because the terminal voltage after taking into effect the demagnetizing effect is 180 volts. So 180 is the terminal voltage, the voltage across the shunt resistance upon the shunt resistance, that is 101. This will be the current after considering the demagnetizing effect, right? After considering the demagnetizing effect. Okay, sorry, this is not 101. What am I doing? This is 41. I'm sorry. This will be 41. This will not be 101, right? Yeah, sorry. There was a bit of brain fade. So 180 upon 41, that would be IF would be equals to 4.39 amperes. Okay, so previously your field current, if you remember, it was 5 ampere. It reduced to 4.39 amperes due to demagnetizing effect. Okay, this is your actual field current. Now if I know the field current, if I know the field current, if I know the armature current, can I compute the uh, can I compute the line current? Because I have to compute the power delivered to the load, and the power delivered to the load would be VT into IL. It's DC, right? So your IL would be simply what? VT is VT, that is 180 volt. VT is 180 volt, right? Into IL. IL would be 5. Sorry, IA is how much? IA is 40 amperes, right? Full load armature current is 40 amperes minus the field current, that is 40 minus this, 40 minus 4.39. Okay, 40 minus 4.39. So if I multiply by this plus 40 into 180, that would be 6.4 kilowatts approximately. 6.4 kilowatts. So your answer would be 6.4 6.41 kilowatts approximately, right? 6.41 kilowatts. This is your answer for the question. Find the particular integral of this particular differential equation. So it's very simple to find out the particular integral. So I will convert this. This will be d square minus 2d plus 1 into y equals to e raised to power x cos of 3x, right? So I need to find out the particular integral. So the pi, right? Y pi would be, this will be 1 d square minus 2d plus 1 e raised to power x cos of 3x. Okay, so what we do is whenever I have exponential e raised to power x into some other function v of x, then I replace my d with d plus a. So I can take out the e raised to power x and this will be replaced, the denominator will be replaced with d plus a, that is d plus 1, because here a is 1. Okay, so d plus 1 whole square minus 2d plus 1 plus 1 into cos of 3x. Okay, so this would be equals to e raised to power x, this would be d square plus 2d plus 1, okay, plus 1 minus 2d minus 2 plus 1, that is minus 1. So automatically what will happen, this will be basically cos 3x and e raised to power x upon d square cos 3x. So what happens is we replace, if I have a sinusoid, we replace our d square with minus. If I have a sinusoid or cosinusoid of cos ax, we'll replace this with minus of a square. We'll replace d square with minus of a square. So this will be e raised to power x upon minus of 3 square cos of 3x. So basically your pi would be minus of e raised to power x cos of 3x upon 9. Okay, so this will be your pi, which is present in the, okay, there actually, yeah, particular integral is this, right, option B, but the general solution, I have to find out the general solution, right? Also I have to so solve for the general solution. So yeah, so this is my pi. What is my cf, complementary function? So complementary function will basically be the roots of this equation, that is d square minus 2d plus 1, which is nothing but d minus 1 whole square. So basically my roots are 1 comma 1. So this will be e raised to power x into cos of, sorry, roots are real, right? So this will be c1 plus c2x into e raised to power x. Right? Whenever roots are real and equal, what happens is we write this c1 c2 into x, and here, right, whatever is the value of the root, that will come in the coefficient of x with the exponential. So your general solution would be e raised to power x c1 plus c2x. So yeah, option C is also correct, and obviously particular integral will be this. So option B and C are correct answer for this question. Let f of R as R is defined by this, which of the following statements is slash R true, right? It is like f belongs to all real values, x also belongs to all real values. The graph of f of x is symmetric about y axis. So if a graph has to be symmetric about the y axis, what needs to happen? The function must be even, right? If you see any function, uh, let's say your cos, right, cos x. So your cos x, all the functions, right, that you see that are symmetric about the y-axis, all of them are even. So if I replace x with minus x, right? So what is f of minus x? It is equals to minus x raised to the power of 4 minus x raised to the power of 2. That is same only, because I see it is even, right? All the powers are even, and whenever the powers are even, certainly your function will be symmetric about the y-axis. So first option is certainly correct. The minimum value attained by the function is 0.5. For this, we will have to differentiate our function. If I differentiate my function dy upon dx, that would be 4x cube minus 2x, and this we will have to equate equals to 0. That will give me two solutions here. So I can take x common, this will be 2x square minus 1. So x common, Okay, I can take 2x common, 2 will go anyways go away. This will be 2x square minus 1, that is equal to 0. So x can be, okay, I have got three solutions. X can be either plus minus 1 by under root 2 or x will be equals to 0. So let me differentiate this function again, that is 12 x square minus 2. Now at x equal to 0, this value is negative, right? So your double derivative is negative at x equal to 0, that means you will get a maxima. Okay, x equal to 0, the double derivative is negative, that means you will get a maxima. So maxima, and at x equal to plus minus under root 2, your function is simply, your double derivative is positive, that means this will, you will get a minima here. Okay, so they are asking me the minimum value. So the minimum value attained by the function is 0.5. So let me replace my x right here, plus minus, because it won't matter because the function is even. So it won't matter whether I put plus or minus 1 by under root 2. So this will be whole square, that is 1 by 2, whole square, that is 1 by 4, minus 1 by 2, that is minus 0.5. Okay, so it is minus of 0.5, and they are telling me the minimum value attained is plus of 0.5. So certainly this is wrong, but let me draw the function once. Can you draw the function with me? So yeah, if I draw the function, this will be basically, if you see that the highest power coefficient is positive, so at x equal to plus infinity and x equal to minus infinity, the function would be somewhat like this. This will be the behavior of the function, certainly, like just like a quadratic, but it is a quartic, that's all. Okay, yes, will it be exactly like this? No, actually what will happen, the function will behave something like this. Now because if you see, it is a quartic function, so there will be certainly 4 roots, right? There will be 4 roots. Okay, there will be 4, sorry, hold on a second, there will be 4 roots, right? So it will start from here, it will start from here, it has touched here once, and yes, this will be the behavior of the function, right? Because it is a quartic function, that means there will be 4 points, 4 roots obviously, where it will cross the x-axis. Now I can obviously see these are the 2 points of minima, right? You can see these are the 2 points of minima, that is minus 0.5. So the function f of x has 2 distinct points of minima. Yes, these are the 2 points that we have already calculated over here. So this option is certainly true. The minimum value is actually minus 0.5, which is wrong. So which is yeah, minus 0.5, but here they have told 0.5, so which is wrong again. The function f of x is an odd function. It is certainly not an odd function, it is an even function. If it is symmetric, it will be an even function. Now if they would have asked maxima, so here you are seeing that x equal to 0, we're getting a maxima. What is this? This is not, this is a local maxima. Local maxima. Here, actually at x equal to 0, this graph is not proper. X equal to 0, this will be 0. Okay. Yeah, x equal to, okay, x equal to 0, the yeah, x equal to 0, the value is 0. Okay. So you are getting a local maxima here. So basically it has 2 roots at x equal to 0. If you take x square common here, right, what will be x square minus 1, right? So basically you have 2 roots at x equal to plus minus 1, right? And the other 2 roots are at x equal to 0 comma 0. So you are getting a maxima, but this is maxima is not a global maxima, it is a local. Whatever you do in the differentiation, right, all these are computed locally, so it is a local maxima. Your actual maxima is here at plus minus infinity, which is infinity, right? So just be careful of this. In this case, option 1 and 3 will be correct for this question. The incremental cost characteristics of two generating units expressed in rupees per megawatt hour are given as a function like this, right? These are the incremental cost for a given load demand. The units are initially operating such that this is the initial incremental cost. If the generator is rescheduled to minimize the total operating cost, determine the resulting value of P1. Okay, so initially they were operating in this particular incremental cost. So for this incremental cost, can I calculate what is the actual power that they are delivering to the load? So when my dc1 upon p1 is 76, 76 is equals to 0.2 p1 plus 50. So your p1 would be equals to 26 into 5. 26 into 5 would be 130 megawatt, right? 26 into 5 would be 130 megawatt. So this was the initial power that P plant 1 was delivering, which is given within our range. And if I calculate the same thing for P2, right? So it was 68.8, that is equals to 0.24 into P2 plus 40. So this would be 28.8 into 0.24 into P2. I'm guessing this is like some even multiple. So this into 28.8 into 100, yeah, your P2 will come out to be 120 megawatt. So previously the load, right, that they were delivering to, catering to, it was actually P1 plus P2, right? So which is 250 megawatt. Now I want to like minimize the cost. So I want economic operation, the most economic operation, right? So for that, what needs to happen, the incremental cost must be equal. So basically dc1 upon dp1 must be equal to dc2 upon dp2. So these values must be equal to each other. So p1 plus p2 is 250, this is the one equation, and 0.2 p1 plus 50 must be equals to 0.24 p2 plus 40. Okay, so this will be equals to 0.24 p2 minus 0.2 p1 equals to 10, right? So now if I solve it, right, how to solve it, this will be basically equals to uh, if I multiply by 5 on both sides, this will be actually 1.2 p2 minus p1 is equals to 50. Now if I add this equation and this equation, so if I add these two equations, this would be 2.2 p2, that is equals to 300. So your p2 comes out to be 300 divided by 2.2, that is 136.36 megawatt, which is again within the given range. So I am safe there. Okay, and they have asked the p1 value, right? So p1 value would be what? P1 value, because p2 plus p1 is 250, so if I subtract this from 250, I'll get 113.63 megawatt. Okay, so yeah, p1 is 113.63 megawatt. They have asked us to round off to two decimal places, this will be actually 64. So this will be your answer for the question. Negative sequence protection is mainly employed to protect which of the following components in the power system? So negative sequence basically means we want to protect the unbalanced nature, right? And why do we check whether my equipment is balanced or not in case of generators, alternators, right? Because alternators must be balanced. So the negative sequence components protection is mainly employed in alternators. It is not employed in transformer, bus bar, or transmission line, because we want to check the unbalanced nature. We want to protect from unbalancing, because in alternator there is high chance the alternator may be unbalanced. So we want to check it on the alternator side. So for this particular question, we want to option C will be correct answer, because mainly we employ negative sequence protection in the alternators. A single phase full bridge voltage source inverter operates with unipolar pulse width modulation technique using one pulse per cycle. So basically they're talking about this technique. Uh, the inverter is supplied from a DC voltage source of VDC, where VDC denotes the DC bus input voltage of the inverter. Determine the pulse width in degrees such that the RMS value of the fundamental component is 0.6 volts of the VDC. Right, what VDC is the DC input voltage. So again, inverter, simple formula based problem. So if there is like, if you apply this modulation technique, then the output voltage is somewhat like this. And if I compute the Fourier series, right, this is the expression of the Fourier series of your output voltage if I have a pulse width of what, 2D. If I have a pulse width of 2D, then this is the expression of Fourier series, and they are telling me that the RMS value of the fundamental component must be 0.6 VDC. So what is the RMS value of the fundamental component? That is n equals to 1. This will be 4 VDC by pi into n equals to 1, that is sine pi by 2, that is nothing but 1. into sine d, right? Now remember, 2d is your pulse width, d is not your pulse width. Okay, they have asked our pulse width in what, in degrees, so 2d is the answer that I will provide. So this upon root 2, because this is the peak value, I will divide this by root 2, this will be the RMS value, this will be equals to 0.6 VDC, right? So from this I can easily calculate what is my sine d. So 0.6 into root 2, hold on, 0.6 into root 2 into pi upon 4 sine inverse. So d is actually equals to 41 degrees, 41.79 degrees. So your 2d would be basically equals to 82. So multiply this by 2, 83.58 degrees. So this is your answer, 83.6 degrees, right? They have asked us to round off to 1 decimal places. So 83.6 degrees would be your answer for the question. A separately excited DC motor is supplied through a single phase semi-converter. So this is a semi-converter. The motor has the following ratings. The armature resistance is 1 ohm. Inductance is not given. So I will assume the current to be continuous. I will assume LA to be very high, right? Assume that the motor operates in continuous conduction mode. Determine the electromagnetic torque developed by the motor. What will be the electromagnetic torque developed by the motor, right? So if it is operating at rated speed, so what is the rated speed? That is this. So what is the torque developed by the motor if it is operating at the rated speed? So torque developed by the motor, Tm into omega m, would be equals to the Eb back EMF into the armature current, Eb into Im, right? Now it is operating in continuous conduction mode. Okay, with the help of that I will be able to calculate my IA average, because if it is operating in continuous conduction mode, so my IA average would be simply equals to my VO average minus E divided by RA, right? And what is my back EMF? So they are telling me that it is a separately excited DC motor. It is a separately excited DC motor. If it is a separately excited DC motor, if this is the speed, right, 960 RPM, so the flux will be constant. So your EB will be proportional to speed upon flux, right? And flux is constant. So essentially your EB is proportional to speed. So if it is operating in rated speed, so your back EMF also will be same. So what is the back EMF in the case 1 when it is at rated condition? EB, this will be, this is a motor, right? So it will be VT minus IA RA, 15 into RA is 1. So your back EMF is 145 volts. So this will be same as the rated back EMF, right? So because they are telling me this back EMF will be same as 145, because the speed does not change, back EMF also will not change. So what is my omega m? Omega m would be basically, speed is given in RPM, this will be 2 pi n by 60. It is operating in the rated speed, so it will be 2 pi into 960 upon 60. So this will be 1 into 6, right? So 32 pi, right? So 32 pi is the uh, speed in radian per second. Right? So we have all the data. I need IO average. For IO average, I need to calculate VO average. So it is operating in continuous conduction mode and it is semi-converter. I will not explain how do I derive to the formula. This I have explained in the RPYQ series as well. So it's very simple. For a semi-converter, the voltage waveform, if you remember that from 0 to alpha, what will happen? These two diodes will conduct. From 0 to alpha, these two diodes will conduct. So the output voltage will be 0. Again from alpha to pi, it will follow the input, and again from pi to pi plus alpha, again the voltage will be 0, again this will be followed. So the average value of this waveform, this I have derived, I will directly write it. This will be equals to Vm upon pi into 1 plus cos alpha, right? This you can verify with the formula what? with the formula when my alpha is 0. So if my alpha is 0, right, if my alpha is 0, this will be 1 plus 1, that is 2. This will be 2 Vm by pi, which is exactly the average value of a full wave rectified waveform. So your alpha is what? Alpha is actually pi by 3, that is 60. So cos 60 is half. So your answer would be 3 by 2 Vm. So this is my Vrms. Vm would be this divided by pi into 1 plus cos alpha, that is 3 by 2. So 3 by 2 this, right? So yeah, let me compute this value. This will be actually equals to 3 by 2 into 230 into root 2 upon pi. So this will be equals to 155.3 volts, right? So yeah, VO average is this. I can easily calculate what is my I average. That will be equals to VO average minus E. E would be this value. Now E is the EB, right? E is the EB. EB is 145. EB is simply 145. So 145 divided by the RA. RA is 1 ohm, right? So your IA average current comes out to be 10 amperes, 10.3 amperes. So I can easily calculate what will be my torque developed. That will be equals to EB is 145 into IA, that is 10.3, upon the speed is 32 pi, right? So let me calculate these values. 145 upon 32 upon pi. So it approximately comes out to be 14.86 Newton meter. So 14.86 Newton meter would be your answer for the question. For a real parameter alpha, consider the system of linear equations. Right? Alpha into x plus y equals to minus 1, x plus alpha y equals to 1. Right? Alpha is a real parameter. Depending on the value of alpha, the system may have no solution, a unique solution, or infinitely many solution. Which of the following statements is correct? Okay, depending on the value of alpha. There exists exactly one value of alpha for which the system has no solutions. So do remember what were the conditions? This is a non-homogeneous equation. If it is a non-homogeneous equation, right, then what were the two conditions? Like there were three cases, right? If my rank of A is equals to rank of A colon B, and it is equals to the total number of variables. How many variables I have? 2. Then certainly I will have unique solutions. If my rank of A is equals to rank of B, A colon B, but it is certainly less than n number of unknowns, then we have infinite solutions, right? Infinite solutions. And if rank of A is not equals to rank of B, A colon B basically, then we have no solutions. Which condition are they talking about? So they are telling me there exists exactly one value of alpha. There exists exactly one value of alpha for which the system has no solutions. Is that so? So for exactly one value of alpha. So what is A colon B? If I form the matrix, let me use a different, yeah. So A colon B would be simply alpha 1 1 alpha, and this is minus 1 1. Minus 1 1. Okay. Now here what shall I do? I want exactly no solution, right? If I want no solution, let me try to make 0. So if I add the rho 1 and rho 2, this will be alpha 1 1 plus alpha 1 plus alpha, this will be 0 0. So I can take this 1 plus alpha common. Okay, this is essentially making, okay, I want to make them not equal to each other, right? So I want this rank to be higher than this rank. Okay, how do I choose? Let's not think about this. I will do this later. Let's think in terms of here. So what is the rank of A colon B here, right? So basically I can see I have, if my alpha is any value, right? Alpha, if alpha is 1, then this and this row are different, then certainly rank is 2. If alpha is 0, then also rank is 2. So essentially what is happening, what is the determinant of this particular matrix? Only 2 cross 2 matrix, that is alpha square minus 1, right? When it can be 0, it can be 0 at alpha equals to plus minus 1, right? Okay, yeah. So I see for whatever values of alpha, right? So for alpha equals to minus 1 here, if I put alpha equals to minus 1, what is the rank of A colon B? That is equals to 2, right? Rank of A colon B is 2. But when alpha is this particular values, by rank of A, what is the rank of A? Can you tell me what is the rank of A? It is actually equals to 1. Why? Because if I form the matrix A, it is this, right? Let's say when alpha equals to 1, it is 1 1 1 1. So I have only one independent row. Or if you choose minus 1, right, then also you see I have only one independent row. So certainly when your alpha is equals to plus minus 1, your rank of A is 1 and your rank of A colon B is certainly equals to 2. So they are not equal, certainly you will have no solutions. But what are they telling me? There exists exactly one value of alpha. Is that true? No, it is a real parameter and there exist two values of alpha, right? Two values. So there exists two, not one. So this statement is certainly incorrect. There exist infinitely many values of alpha for which the system has no solution. Again incorrect, because there exist two values of alpha for which there are no solutions. For any other values of alpha, right, your rank of A will be 2, because the rows will be independent. Rank of A will be 2, which will be equal to rank of A colon B. Hence that is not true. There exists exactly one value of alpha for which the system has unique solution. Again incorrect. There exist infinitely many solutions of alpha, right? Because in many values of alpha, because for unique unit rank of A equals to rank of A colon B. So if your alpha is not equals to these two values, then this will always be true, right? This will always be true. So there exist uh, infinitely many solutions. There exists exactly one value of alpha for which the system has infinitely many solutions. There exists exactly one value of alpha for which the system has infinitely many solutions. So if it is required to have infinitely many solutions, right, that basically means, okay, it needs infinitely many solutions. So that basically means alpha 1 1 plus alpha, this will be 1 plus alpha, this will be minus 1 0, right? So basically no, that is not possible, right? So alpha, so if alpha is equals to minus 1, okay, hold on. So at alpha equals to minus 1, I observe a certain thing. Oh, alpha equals to minus 1, this is getting to minus 1 1 minus 1, and this is going to 0 0 0. Oh, okay, we have to be very careful here, right? So alpha equals to minus 1, the rank of A colon B is actually 1, because I only have one independent row. I was wrong here. This statement was wrong, right? I was telling at alpha equals to plus minus 1, the rank of A colon B was 2. I was wrong because I did not check it properly, okay? So whenever you're doing ranks, make sure you check it properly. So make sure you try to make this whole 0. Then only you can say surely, right? Okay, I was wrong. So actually I was wrong. So at alpha equals to minus 1, right, A colon B is rank is 1 and your rank of A is also 1. So actually you have infinitely many solution at alpha equals to minus 1. So there exists exactly one value of alpha for which you have infinitely many solutions is correct. But there exists one value of alpha for which the system has no solution, this statement is also correct, because alpha equals to 1, alpha equals to 1, certainly the rank, what is the rank? If I put alpha equals to 1 here, right, what is the rank? It will be 1 1 1 1 minus 1 1. So rank I can directly see it is 2 because these two rows are independent. But if I put minus 1, I was wrong actually, previously I just checked. If I put minus 1 here, this will be 1 minus 1 minus 1 1. So essentially, right, if I multiply a negative with the second row, I will get the first row, right? So that's all. So actually this statement is also correct. There exist infinitely many values for alpha for which no solution. No, this is again wrong. There exists one value of alpha. No, there exist infinitely many values of alpha. So option 1 and 4 are the correct answer for this particular question. Evaluate the surface integral where S is the surface in three-dimensional space defined by this. Okay, the vector field is given by this, and n vector denotes the outward unit normal to the surface S, right? Yeah, so basically they are asking me to compute this surface integral, right? Okay, given by this surface. So what is this surface? Do you understand what is this surface? So I see this is z square. Z square is greater than x square plus y square. X square plus y square. So this surface is nothing but z square is greater than or equals to r square. If I assume, like, let's say x square plus y square is some radius of a circle, it is r square. So if I draw the three dimension space x, y, z, right? So basically, if I assume x square plus y square is nothing but a circle, right? So my z square must, if let's say I am at here at z equal to 0, so your r must be 0 because z square must be greater than r square. So r must be 0. Let's say I am at z equal to 1. If I am at z equal to 1, so basically your x square plus y square basically must be less than 1 square, that is 1. So basically if I am at z equals to 1, so your radius of the circle should be less than 1, right? If I am at z equal to 2, your radius of the circle should be less than 2. So what is happening, as I am moving up or down, it does not matter, your radius of the circle is increasing. So with deviation in z, the radius of the circle is increasing, right? So essentially I can say your z actually will always be greater than or equals to the radius of the circle. Is that so? So basically your z and the radius of the circle follows a linear relationship. Do you remember which certain shape has that linear relationship? So I have here, then again as the radius increases, z also increases. As the radius increases, z also increases. So this I have taught in my full course. This is the shape of a cone. Okay, this is the shape of a cone simply. Okay, shape of cone, right? Okay, this is the shape of a cone, right? So that's the thing here. So actually they are asking me to compute the this surface integral over the cone, because your cone, basically the radius of the cone is varying from 0 to 3, right? So what we can do, we can actually compute, so we can use the divergence theorem, right? If I have to compute uh, surface integral, I can use the divergence theorem because it is a closed surface. It is a closed surface, right? I have to compute the integral from here. So it is a closed surface. So I can use divergence theorem. That will be the volume integral of del dot f dv. So volume integral in the xyz coordinate, this will be del dot f. So if I differentiate with respect to x, this will be 4 only, divergence, plus differentiate this with respect to y, that is 0, differentiate with respect to z, that is 0. So this is actually 4 triple integration of dv is simply 4 of into v, where v is the volume of the sphere, sorry, volume of the cone. What is the volume of the cone? It is pi r square h by 3. So 4 into pi r. Okay, so what is your maximum value of the radius? That is 3, right? R is 3. 3 square into h. what is the height of the cone? Maximum height is 3, right? Yes, 3 upon 3. So this will be actually 9 into 4, that is 36 pi. What have they asked? They have directly asked me to calculate the answer in integer. Okay, 36 pi, this will be 36 into pi, that is 130. This will be your answer for the question. The Bode plot of the open loop transfer function is shown in the figure below. Determine the phase margin of the system. So nothing has been mentioned, right, regarding the system. So I will assume a unity negative feedback system. Unity negative feedback system. Okay, that is what I will assume. Now we will have to determine the phase margin of the system in degrees, right? So first of all, to determine the phase margin, what do I need? I need the phase of my OLTF at gain crossover frequency, and I will add that phase with 180. That will give me the phase margin of the whole system. Cool. So here I see that like at what frequency there will be, like the gain crossover frequency means the magnitude of the OLTF is 1, and in dB scale it is 0 dBs. So I see this is the omega GC, but I don't know anything regarding the transfer function. If I want to calculate this, I have to calculate what is my transfer function, what does my transfer function look like. So I see, first of all, as you have to calculate, and you can see omega GC can be computed from the this graph itself. We don't need to calculate the DC, like we don't need to calculate this value. Okay, I will explain what do I mean. So let us first briefly see what is happening. So I see initially I have two zeros because the plot starts from minus 40 dB per decade. So at s equal to 0, I will have, no sorry, not 2 0, 2 poles. At s equal to 0, I will have 2 poles. So this will be k by s square, and then I see the slope increase to minus 20 from minus 40. So this will be s by, there is a 0, right? That's why the slope increase omega z plus 1, and then again I see again the slope changes from minus 20 to minus 40. So this will be s by, again I will encounter a pole. So this is my OLTF. Now how do I know information regarding these points? So this particular informations will help me, certainly it will help me, right? So this is what, this is the slope of the graph, right? So, and remember your omega always is in log scale. So simply writing the equation of a straight line, what is the slope of this particular region from this to omega z? What is the slope? The slope is minus 40 dB per decade. So minus 40 dB per decade, right? So what is the change in y? Final minus initial, 18 minus 46. 18 minus 46. What is the change in x? Change in x is, remember 46 dB is at 0.1. They have given this point specifically, and I need to calculate omega z, right? So it will be, remember your x axis is in log scale, so it will be log base 10 final minus initial. Final position is omega z, initial position was 0.1. So with this I will be able to solve for omega z. Let us solve for omega z. So 18 minus 46 upon 40, 10 into 0.1. So your omega z approximately comes out to be 0.5 radian per second. Now similarly I will use the same method to calculate omega p. I will use the same method to calculate omega p. So again, what is the slope in this region? Minus 20. Minus 20. Final minus initial. Final value 6 dB, initial value 18 dB. 6 minus 18 upon log of final minus initial. Now initial value is now my omega z. Initial value is my omega z, that is 0.5. So this will be equals to 12 by 20 10 raised to power this into 0.5. So your omega p comes out to be 2 radian per second. Omega p is 2 radian per second. We need one more information. So we got our transfer function, right? We certainly got our transfer function, but I need the value. Either I need to calculate k, or I can directly see the graph itself what is the omega gc point, right? So we can calculate that. So again I will apply again the same formula. In this region, what is the slope? Minus 40. What is the final value? Final value is 0 dBs. Initial value is 6 dBs. So 0 minus 6 log 10 omega final omega gc upon initial, it is 2, right? This time the pole is the initial value. So this will be 6 upon 40 10 raised to power this into 2. It is basically 2 root 2. Your omega gc is 2.82 or it is 2 root 2. So we got our omega gc, right? Now we can actually calculate. And you will say, sir, do I need the k? We don't need the k. For phase margin, we don't need the k. Why? Because we know omega gc. And when I calculate the angle, right, what happens? Simply this k is not used, right? The angle of k is 0, right? So yeah. So what is g of j omega? It will be k upon j omega whole square, that is minus omega square. It is s by omega z, that is j omega by omega z. Omega z is 0.5 plus 1 upon j omega by 2. J omega by 2, right? J omega by 2. Yeah. So we got our j omega. Now what is the angle? So what is the angle contributed by k plus k? K is a positive parameter. Nothing is mentioned. K is a positive parameter, and you will calculate k as well. It will come out to be positive because k is positive, right? You can see it is lying above 0 dB axis. K will be positive. Like we know k certainly is positive. Now k will contribute 0 degree angle, right? Now minus omega square will contribute how much angle? Minus 180, because I have a so this negative sign can go at the top, right? So this negative sign will contribute a minus 180 degrees of angle, plus tan inverse, the 0 will contribute omega upon omega z, that is simply tan inverse 2 omega minus tan inverse omega by 2. This is the angle contribute. Now what will be the phase margin? Phase margin would be 180 plus of angle, right? So this whole thing at what? At omega equals to omega gc. So my omega would be equals to omega gc, that is basically 2 root 2. 2 root, I'm just writing this in rough. So if you calculate this thing, approximately your angle will come out to be 25.26 degrees phase margin. Okay, so this will be your answer. 25.26 degrees certainly will be your answer. Now if you guys might have doubt, so sir, we don't need the value of k, is this proper or not? It is proper. So after writing down your this equation, right, you compute the gain of your OLTF at omega equals to 2 root 2, right? And from here you can solve what is the value of k. I will tell you what is the value of k. K value will approximately come out to be 2. How? So you write 20 log k is equals to 46 divided by what? So remember, we are calculating the gain at 0.1. So if I calculate the gain at 0.1, what will happen? These values will be ignored. These values can be ignored. This has been taught in the full course. So approximately the gain at 0.1 would be k upon omega square. That will be coming out to be equals to approximately 200 and omega is 0.1. So k will come out to be approximately 2. Okay, like that you can solve. Obviously you can verify whether this is actually the gain crossover frequency or not by computing the gain at the gain crossover frequency. So I think the discussion regarding this question is over. This was a good question. Answer would be 25.26.
Yeah, so in this problem, what we need to find out? We need to find out the average power absorbed by the resistor. So what is the average power absorbed by the resistor or dissipated in the resistor? What is that? I average square into R. No, a lot of people do this error. It is not average, it is RMS square. Okay, this is the correct formula. So average power dissipated across the resistor is I RMS square into R. So Q graph is given, Q versus T. I can find out the current graph, and then I need to find out its RMS value, not the average value. Okay, so RMS value I need to find out. So can I draw the current graph? Yes, sir. What will be the current graph? Sir, I is simply dq by dt. I is simply dq by dt. So simply differentiate, you will get slope is 1, here also slope is -1, in between slope is 0. So if I draw the graph, +1, slope is 0, then slope is -1. Then again the same graph will keep on repeating. So this is the graph which will keep on repeating. Value is 1, value is -1. Okay, this is 0 second, 1 second, 2 second, 3 second. This is your IT graph versus T, which will keep on repeating. So how will you find out the average? Sorry, how will you find out the RMS? Average is 0. Average is 0. So someone would say that, sir, power dissipated would be 0. No, RMS I need to put. So in signal system we studied 1 square into 1, 1 square into 1 divided by its time period. Okay, so this is the power. If I need to take the RMS, do the under root. So this is your IRMS value we are getting, which is under root 2 by 3. In signal system we learned it. So what will be the average power dissipated? 2 by 3 square into resistance 3. So answer is coming out to be 2 watt. That's it. Okay, so average power dissipated is 2 watt. Okay then, yeah.
A negative unity feedback control system has the open loop transfer function. The root locus of the closed loop poles is plotted in the S plane. Let A denote the point on the real axis. So root locus is plotted and A denote the point on the real axis uh, where the asymptotes of the root locus intersect. So I hope you know what are asymptotes of root locus, and B be the point where the B with the point on the real axis where the root locus breaks away. So basically they're asking me what is the breakaway point and what is the centroid, because wherever the asymptotes meet, it is called as the centroid, right, of the root locus. So determine the value of the A minus B. So roughly if I plot the root locus, if you remember, we have three poles, S equal to 0. Let me first not plot A, we'll get an idea about A later on. S equal to 0, S equal to -1, S equal to -2. Okay, now if I plot the root locus, so we don't have any zeros, right? What are the angles of asymptote? So angles of asymptote would be equals to 180 minus 180 divided by p minus z. So that is 3 into like integers, right, or odd multiples basically. So it will be this will be -60 minus 180 and minus 300, right? So -60 would be, hold on a second, sorry, so not minus, plus 68 plus, like we can use plus minus, does not matter, ultimately you get the same values. Yeah, it will be plus, right? Sorry, so plus 60 would be somewhere here, right? So somewhere here I will have asymptote, and my plus 300 would be, this is 180 and another 120, it would be somewhere here, basically minus 60 plus 300 is nothing but minus 60. So I have two asymptotes here, and minus 180 also I will have asymptote. So obviously we know in the real axis, if it's a normal root locus, right, not complementary, then we know at like root locus will exist if on the right hand side I have odd number of poles plus zeros. So of course root locus will certainly exist in this whole region, and in this region as well root locus will exist because I have odd numbers of poles and zeros. So basically I see this pole will terminate with this virtual zero with this asymptote, and these two poles will break away and basically terminate here. I exactly, yeah, I think it will be somewhere here actually. This point will be somewhere. I will exactly tell you why this point will be somewhere here, exactly here. Just you can draw the root locus, you'll see. Okay, so this, right, wherever the asymptotes meet is called as a centroid, and this centroid actually, that is equals to a in our case, right, the point that is equals to the sum of the poles. Sum of the poles, what is the sum of the poles? S equal to 0 plus minus 1 plus minus 2 minus sum of the zeros. I don't have zeros, so I'll put there 0 only. Don't know zeros I have. Divided by number of poles minus number of zeros. So number of poles I have 3, number of zeros I have 0. So essentially it is actually equals to minus 1. Okay, how to remember this formula? Very simple, right? Sum of p minus sum of z upon p minus z. I don't think you have to remember like how to remember. I have explained this in the RPYK course as well. Please visit, please watch those videos. There I have explained this properly. So this is minus 1, right? Now, so my centroid or a value is minus 1. What is the breakaway point? For calculating the breakaway point, basically what needs to happen is your k is equals to what? So we have this formula, right? So the characteristics equation, that is 1 plus g of s, that is s into s plus 1 into s plus 2. This is my characteristic equation, that is equals to 0. So from here I get the value of k. K value would be minus of s into s plus 1 into s plus 2. And we know whenever there is a breakaway or break-in point, the value of k is either minima or maxima in the near neighborhood. It is a local minima maxima. This concept also has been taught in the RPOIQ course. So we will certainly calculate the different derivative of this. So let me first rearrange this. Minus sign would be outside. S into s square plus 2s. Right, now I will differentiate this plus 6s plus 2, and now I will equate this equal to 0, that is the point of maxima or minima. So yeah, this will be minus b plus minus b square minus 4ac. So 8 into 3, that is 24 upon 2. So this will be minus 6 plus minus 12, right, under root 12. So under root 12 will be 4 into 3, so 2 under root 3 upon 2. So this will be basically minus 3 plus minus uh, root 3. Now, of course, we will not choose the negative solution. Why? Because that point, I'm getting 2 points. One is 3 minus root 3, another one is minus 3 plus root 3. So if you see, minus 3 minus root 3 will be lying somewhere here. Do I have a breakaway point? No, I don't have any breakaway points. So anyways, you will have to draw the root locus. If you don't draw the root locus, you will not be able to eliminate this solution. So this is not correct. This is certainly correct. What is minus 3 plus root 3? So approximately minus 3 plus root 3 would be minus 1.26. Okay, hold on. That also does not make sense. Somewhere I'm making mistake. Just give me a second. Right. Just trying to check what is happening. Somewhere I'm making a huge calculation error. Okay. S plus 1 s plus 2. So s square plus 3s plus 2 s cube plus s3 square plus 2s. Now I will differentiate. This will be 3 square. This will be 6s plus 2. B square minus, oh sorry, 2a, right, 2a. Every time the coefficient here is 1, so be very careful regarding these mistakes. It is 2a, right? So just be careful, you can make this mistake in your exam hall. 2 into a, so this will be 2 into 3. Okay, don't make this mistake. Don't make this mistake. Okay, sorry. Yeah, now I think it is fine. So this is 6 actually. This 6, so this will be minus 1 plus 1 by root 3. Okay, so minus 1 plus 1 by root 3 is one solution, and minus 1 minus 1 by root 3 is another solution. Now again, the same reasons, I'll obviously ignore this minus 1 minus 1 by root 3 because root locus does not even exist here, right? There cannot be any breakaway point here. So breakaway point will be only this one. So what is this value? Root 3 inverse minus 1, that is minus 4.22. This is my B point. And what have they asked? They have asked me the value of A minus B. A minus B. A is minus 1, right? So A is minus 1. So A minus B would be equals to minus 1 minus of minus 4.22. Hold on now. This is minus 1, this is plus, yeah, minus 0.577. Okay, so minus 0.577. This is your answer for the question. For the circuit shown below, determine the value of the equivalent resistance seen between the terminals A and seen between the terminals of the voltage source, right? Okay, just let me just give me 1 second. Yeah, all these are fine. Yeah, we have to compute the equivalent resistance seen from the voltage source. So we cannot use referring here. Of course, you can use referring, but I see there are multiple things. So ultimately, we have to compute the equivalent resistance seen by the voltage source. So let's assume that the source delivers a current of Is, right? So ultimately, we'll have to calculate the ratio of Vs RMS, V in RMS upon Is RMS, right? That is my target. So it's very difficult to start from here. Let us start from here, right? So if I know that these two coils are in series, so they will take a current of I. They will take a current of I. So what is the voltage drop here? The voltage drop here would be 5 into I. So let me assume a few things. So if this is V in, right, I see these two coils are in parallel. So this also will be, let's assume this is V and this is V, right? So what is the voltage here? So it is a 2:1 transformer. The voltage here would be V by 2. The voltage here would be V by 3. Correct? And we have to calculate V upon Is, right? So what is your V? So okay, this, what will be your current, basically your I across the load? It will be this whole voltage, because this is dot polarity, that's why plus will come with dot, plus will come with dot. Okay, so this whole voltage is how much? This whole voltage is 5V divided by 6, and your resistance is 5 ohms. So your current would be V divided by 6. That is the current. Now if the current through this coil is V by 6, can you tell me what is the current through the primary of this coil? It will be divided by 2. So this will be V by 12, right? And what will be the current here? It will be V by 18, correct? So this current is V by 18, this current is V by, hold on, the current will be coming out from here, right? Yes, V by 18. So what is the current Is? Is, now V is V in, okay, don't be worried about that. So your current Is would be V by 18 plus V by 12. So simply this will be V in is V only, Is is V by 18, V by 12, that is V 1 by 18 plus 1 by 12. So this would be 1 upon 12 plus 18, that is 30. Okay, let me take common 1 by 6. This will be 1 by 3 plus 1 by 2. So this would be 5 upon 6, right? So 36 by 5. Okay, so what is 36 by 5? It will be around 7.2 ohms. So the equivalent resistance seen between the terminals of the supply will be 7.2 ohms. This will be the answer of the question. A three-phase induction motor with star connected stator winding is supplied from a balanced three-phase source as shown in the figure. So we are supplying from a balanced three-phase source while the motor is running under no load condition. One of the supply lines is open circuited. So let's say one of the supply lines simply gets open circuited. So let's say this C is open circuited, right? Then what will happen to the motor? What will be the operation after that? The resultant air gap flux continues to rotate, but its speed is no longer constant. So there are multiple statements. The motor comes to rest. So if I open this particular phase, right, what happens? So whatever is the current here, same current flows through here. So technically, right, technically if I see there is no neutral connection. If there was neutral connection, the answer would have been different. But as there is no neutral connection, technically this becomes a single phase induction motor. And we know in a single phase induction motor, it develops a pulsating torque. Pulsating torque. In a single phase induction motor, although the torque is lower, right, because there is a forward field, forward wave, and backward wave, right? But what happens is the what do you call? There is no starting torque, right? In a single phase induction motor, there is no starting torque. But here, as the motor was already rotating, because they're telling me that while the motor is running at no load, so there is some starting torque already. So motor will still rotate in the same direction, but the torque will be lower. Okay, so the air gap flux becomes pulsating. Why it will become pulsating? Because you have a forward field and a backward field. This is a concept of single phase induction motor, and the motor operates as a single phase induction motor. Absolutely correct. So option C will be your correct answer for this question. Consider Cauchy's theorem for complex integration. Let P be a simple closed contour lying entirely within a simply connected domain Q. Okay. So it is lying in the domain Q, simply connected domain Q, for the complex integral fz dz. Which of the following statements is / are true? Okay, do you remember what does Cauchy's theorem tells you? Cauchy's theorem simply tells me that if there are no poles that are lying inside my contour, then that means my integration, right, this closed line integration along the contour P would be 0. That is what my Cauchy's theorem tells me. Cauchy's residue theorem is different. You will have to compute the residue there. Okay. Cauchy's theorem cannot be directly applied to conclude that this is equals to 0 when your fz equals to 1 by z cube and P is the unit circle. So if P is a unit circle, that basically means inside the contour 1 by z cube, right, I have z equal to 0, which is a repeated kind of pole which is lying inside that. So Cauchy's theorem alone will not be able to directly conclude what is the integration that is equal to 0. We'll have to use Cauchy's residue theorem. So yeah, this statement is correct. They're telling me it cannot include. So it is correct. We cannot conclude that. Okay. If fz is analytic in Q, then fz integration of this, right? Okay, entirely within a simply connected domain Q. Closed line integration of fz dz equals to 0 for any simple contour P in Q. So if the contour P is lying in the domain Q, and if in the domain Q fz function is analytic, then certainly if it is analytic, there are no poles, like it is basically continuous, right? Intuitively you can understand. So yeah, this will be always 0. This will be always 0. That is certainly true. Okay, if it is analytic, it will be 0. So we don't have any problems. To conclude that this integration is equals to 0 for any simple closed contour P in Q, the function fz must be analytic in Q. Is it true? Is it always true? No. Why? Because yes, if your function is analytic in Q, right, then certainly this integration will be 0. That is stated in the option B. But if it is not analytic in Q, right, or in the contour P, which is lying in the domain Q, you will compute the residue, and your residue, right, for a particular pole can be equals to 0, and that can also cause this integration to be 0. So it's not like this will be 0. If this is 0, then certainly your function is analytic. No. Even if your function is not analytic, still this integration can be 0 if the residues come out to be 0, or the sum of the residues come out to be 0, right? Sum of the residues are coming out to be 0, then also this integration can be 0. So this statement is incorrect. Now this integration is not equal to 0 when your fz equals to 1 by z cube, since the function is not analytic at z equals to 0. Again, here, right, nowhere they are mentioning what is the curve they have chosen. So it may be that the curve that they have chosen, yes, it is not analytic in 1 by z cube. That is certainly true. At z equal to 0, it is not analytic. That is true. Okay. because there are poles, there are repeated poles. But I don't know what is my P, right? What is the contour P? So P may be this contour that does not include z equal to 0. So here I can use my Cauchy residue theorem because it does not lie in the pole. So if it does not lie in the pole, if there are no poles inside my uh, contour, then I will simply use Cauchy theorem, and Cauchy theorem states that it will be 0. So in this region it is analytic, right? So yeah, this is not equal to 0, but you will have to get the information regarding P. They have not provided you with the information of P. So this statement is incorrect. So here option 1 and 2 will be your correct answer for the question. If x and y are identical independent binary binomial random variables, if the experiment is repeated thrice, okay, so remember your x and y are binary meaning either they can take two values, so either it can be x equal to 0 or it can be x equal to 1. Now they are binomial random variables, right? I hope you know what is binomial, like they follow binomial distribution. Now if the experiment and they are independent, both x and y are independent, they are identical but they are independent. Now what they're telling me that the experiment is repeated thrice, so n in the binomial distribution is thrice, remember this, right? And the probability that x equal to 0 is given to be 2 by 3. So what is the probability that x equal to 1? It is a binary random variable, it will be 1 minus 2 by 3, that is 1 by 3. The probability that the matrix this that is never orthogonal, the probability that the matrix is never orthogonal, right? Now do remember what was the condition for orthogonality. Your condition for orthogonality was P into P transpose will be equals to I, right? So what is P into P transpose? X by root 2 y by root 2 minus 1 by root 2 1 by root 2. Now P transpose would be what? P transpose would be equals to x by root 2 minus 1 by root 2, sorry, I'm doing the transpose, y by root 2 divided by 1 by root 2. So that is my P transpose basically, right? So we got this. We will multiply these two together and that should give me the identity matrix. So if I multiply these two, this will be x square by 2 row into column, right, plus y square by 2, that should be equals to 1, that is one equation. X minus x by 2 plus y by 2, that should be equals to 0, right? This is the other equation, right? I'm multiplying the first row and the second column. Then again coming back to the second row, this will be again minus x by 2 and plus y by 2, that again will be equals to 0, that is the same equation as this equation, right? And this final one will be the same basically. Oh no, sorry, this will not be the same, this will be 1 only, right? We'll get 1. So we get two equations. What are the two equations? X square plus y square equals to 2 and x is equals to y. So if I replace, let's say, my y with x here, right? So basically your x would be equals to 2x square would be equals to 2. So your x can be plus minus 1. Now as my variable is random, right? So either it can be x equal to 0 or x equal to 1. It is a binary. Binary means it is either 0 or 1. So if it is 0 or 1, that basically means we cannot take negative values. We'll either take plus 1 and 0, right? So basically our x needs to be equals to 1, and of course this condition must also be satisfied, that is our y also must be equals to 1, right? So x is equals to 1, y is equals to 1. That is the condition for the matrix to be orthogonal. But what are they asking? They're asking me it is never orthogonal. So what is the probability that it is never orthogonal? So what is the probability of success? Probability of S. It will be 1 minus probability of failure, right? That it is orthogonal. Let's assume it is orthogonal, right? If I subtract 1 from that, then I will obviously get it is not orthogonal. So it will be, what is the probability that it is orthogonal? Both x and y must be equals to 1. So what is the probability that x is equals to 1? X equals to 1 is 1 by 3. So it will be basically 1 by 3 into 1 by 3, right? Because y also has to be 1, right? That's why they are independent. I can simply multiply the two probabilities. So it would be 8 by 9. Now remember, this is a probability for the matrix to be never orthogonal, but this is only in the scenario where my n is 1, right? But I am repeating this experiment thrice. So of course, now using the formula of binomial distribution, it is NC P, the success, right? Or NCR, P raised to the power of R, Q into n minus R. So I am repeating this thrice, and I never want orthogonal, right? I always want success. I don't want orthogonality any time. So I always want it to be orthogonal only. So out of the 3 times, I want all of it to be not orthogonal. I want all of the time for my matrix to be not orthogonal. So it will be 3 only. R will be 3. 8 by 9, probability of success raised to the power of 3, and obviously this will be 1 by 9 raised to the power of 0. So this will be 8 by 9 whole cube. Okay, and if I calculate 8 by 9 whole cube, this would be 0.7. This would be the answer of the question. A star connected synchronous motor with 8 poles operates at 50 Hz. The synchronous reactance is 10 ohm per phase and the no load line voltage is 2.5 kilovolts. So it is star connected with number of poles is 8, frequency is 50 Hz, and synchronous reactance XS is 10 ohms. The no load line voltage is 2.5 volts. So basically the terminal voltage is 2.5 volts, and at no load, this is my voltage of the synchronous motor as well. Okay, so this is the motor. Basically here I have XS and this is the motor. This is the terminal voltage VT, and this is the motor basically, that is E. I can write here EM. Okay, just give me 1 second. Yeah, I think it is fine. Yeah, what else are they asking? Now they're telling me that following a sudden increase in the shaft load, okay, so suddenly I'm giving some load in the shaft, the rotor slips back by 1.5 degrees mechanical. So basically the rotor slips back by 1.5 degrees mechanical. So the delta, right, changes. Initially it was at rest, so your EF VT was equals to EF, that means your delta was 0. Vt was equals to EF, your delta was 0. Suddenly due to some load, your delta was shifted by minus 1.5 degrees. Basically your EM will lag Vt. So if Vt is here, so EF will be somewhere here. It will lag the Vt by 1.5 degrees. Okay, this is in mechanical. This is not the, this is in the phasor diagram. So this is electrical, right? So I will have to convert this angle into electrical angle, right? This was in mechanical, 1.5 degrees mechanical, so actual angle. So this multiplied, so we know our theta E is equals to P by 2 of theta M mechanical, right? So poles is 8, so 8 by 2, that is 4, I have to multiply, so minus 6. So this will not be 1.5, this will be 6 degrees. Very careful, this will be 6 degrees. Okay, 6 degrees lag. Negative sign represents lag. Determine the synchronizing current in amperes required to bring back to its original steady state position. Right, this concept I have taught in my full course as well. In RPYQ as well I have taught this. So basically this will be asked, and this has been asked recently, 2025 only. Right, simply you will consider this magnitude EF, this is magnitude EF, right? Vt is also equals to EF here, and you have to compute. So what happens? There will be a synchronizing current that will bring this EF back to Vt, right? Bring this delta angle to 0, and this particular vector magnitude is equals to I synchronizing current into the excess drop, right? J into excess into I synchronizing current. This is the synchronous current that will flow when there is a lag, right? So this essentially I have taught this concept in my full course as well. So technically what happens is, it is just like a isosceles triangle. Both sides the magnitude is EF of the vector, and this angle is basically, let's say if this angle is delta, so what will happen? This magnitude of the side is I synchronizing into excess, right? So this will be half of that, I synchronizing into excess by 2, this particular distance. So I can apply, and this is 90, right? So I can apply the sine rule. So the opposite side length EF upon sine of 90 will be equals to the opposite side length, that is I synchronizing. All I'm interested is only on the magnitude right now, right? I'm not interested in the value, into xs divided by, what is the angle here? This is the bisector, so this will be sine of delta divided by 2. Okay, so yeah, also there is a division by 2 here, don't forget. So from here I can get the expression for synchronizing current. This would be equals to ef, magnitude of ef divided by xs into 2, and of course into sine of delta divided by 2, right? So most of the places you will see they will tell you to memorize the formula, but I am deriving it. I am deriving it live in the exam. Okay, so this will be equals to 2 into ef. Ef value is nothing but, okay, remember one thing, these are all, it is a star connected synchronous motor, right? So if this voltage is given, this is a line voltage. So what is your phase voltage? So phase voltage would be this divided by root 3. Okay, don't mess it up. So this is star connected, right? So this will be 2.5 kilovolt divided by root 3 into 1000 divided by xs. What is xs? The synchronous reactance, I think, is 10 ohm, right? Okay, hold on, this is into 1000, right? xs is 10 ohms, so this will be, oh yeah, into 100 only, that is correct only. Into sine delta by 2. Now delta is 6, delta is 6, so delta by 2 would be 3, right? Delta by 2 would be 3. So yeah, let me solve this particular equation. So 2 into 2.5 into 100 divided by root 3 into sine of 3, that comes out to be 15.10, 15.10, and this will be the magnitude of the synchronous current, right? This will be the magnitude of the synchronous current. So 15.10, 15.1 would be your answer for this question. Now there is another way to solve this question as well. If I draw the circuit diagram here, because you're adding a load, suddenly your voltage, right, of the motor will not suddenly change because the excitation has not changed. So this voltage magnitude, right, will be still same, that is 2.5 divided by root 3 kilovolt, but its angle will be minus 6 degrees as mentioned, right, because it will lag the terminal voltage which is constant, that is 2.5 divided by root 3, angle 0. So from this you can also calculate what is the amount of current, synchronizing current, that will flow. This is also another way to solve it. I will not solve it, but you can solve it certainly. So your 2.5 divided by root 3 in kilovolt, remember this angle 0 would be equals to your I synchronizing current, this will be also in phasor, into your jxs, this plus the voltage, right, plus this voltage drop, that is 2.5 root 3 minus 6 degrees. If you don't want to use formulas, you can use this particular thing to compute. So what you can do, essentially you can equate the real and imaginary parts on both sides. So if you take the cos on both sides, if you equate the real parts on both sides, so left hand side the real part is 2.5 divided by root 3 into 10 cube. Now what is the real part here? It is 0, right? What is the real part here? This will be 2.5. okay, it is not 0, right, because your current, right, will have a phase. This current will have a phase of theta synchronizing, right? So it's not like your current has 0 phase, it is not in phase with the terminal voltage, right? And this excess will provide a phase of plus 90. Okay, so if I take the cos on both sides, this will be I synchronizing into xs into cos of 90 plus theta sy, and of course plus 2.5 by root 3 into cos of 6. This is one way, cos of minus 6, to solve the question. And again, if I equate the imaginary part, this is the easier part, easier way to solve. So the left hand side does not have any imaginary part, right? So this will be 0, that will be equals to this same thing, cos will be converted into sine, that's all. So this will become sine, and this also will become sine. So remember, this is negative, right? Sine of minus 6 would be minus of sine 6. So from here also, if you want to solve, you can actually solve your question like this particular formula that comes, right? This is an approximated formula. Because your delta is very small, then only we can do this approximation. Otherwise, to exactly compute the value of I synchronizing, you can use this formula. So this, again, if you solve this, your answer will almost come out to be similar as this one. Okay, so this is your answer for the question.
Yeah, so you guys are done with the KillerX examination. You have seen the solutions as well, and I hope you have spent roughly around 3 to 4 hours or 4 to 5 hours in analyzing this question paper. This was my requirement, this was my suggestion as well, that you see each and every question and understand that what I can get from this particular question paper. Okay, and this is how you should be analyzing your question paper. Now roughly around it's at 7 p.m. Okay, at 7 p.m. we are going to come live on YouTube. On this channel only, on our PrepFusion channel, we are going to come live on YouTube, and we will be discussing about the question paper. Like what was the marks of topper, what was the difficulty level, and based on your marks, where do you stand? Whatever the queries that you are having, you can also ask that particular query as well. So at 7 p.m. we are going to come live. Okay. I hope you have enjoyed the session. I hope you have enjoyed the question paper as well, and you are confident enough for the next examination. When is our next examination? Our next examination will be on 25th of January. Okay, and then the next would be on 1st of Feb. This is Booster X and this is your Replica X. So let me tell you one thing, this was the toughest examination of all. Booster X will not be that tough. Replica X, I am not telling you the level. Replica X I will make, although this question paper was also made by me only and Anish sir as well. But for Replica X, we are not telling the level. Replica X means it will be gate replica. So no level will be disclosed. But this was KillerX. It was on the tougher side, I can tell. But Booster X will not be on that tougher side. Okay. This question paper was roughly, like you can say, gate 2023 electrical. Gate 2023 electrical. Or you can say gate 2024 EC. Or you can say gate 2025 IN. So here you would see that AIR1 was getting 63 or 66 marks. I guess 66 marks. Here AIR1 got 63 marks. AIR1 I am talking about. And here like AIR1 was like very good student. So let's not talk about AIR1, but I remember the marks of in gate 194. Whose marks I remember? Like I remember here like again in 60 plus marks you were getting under 100. This was the scenario. 60 marks under 100 was the scenario. So this was that kind of question paper. Now it might happen that in 2026, who knows, EC paper question come out to be on the same side, like 70 marks rank 1. This may also happen. So that's why KillerX. You need to analyze this question paper. You need to see what maximum you can get out of this particular question paper. And you can comment down as well your reviews, sir. What was the level of the question paper? Because we have personally set up all the problems. No, it took a lot of time. We are spending at least 7 to 8 days in just making this question paper and solution. 7 to 8 days only for this one question paper. Okay, so setting up the question paper, then analyzing it, then all these things, everything we are doing. So you can comment down that, sir, yes sir, the level was pretty good. And I don't think any coaching institute anywhere you are going to get this kind of question paper. They will hire some ranker, they will make the question, they will put it there. But efforts were involved here. I hope you are able to appreciate it. Okay then, so let's meet at 7 p.m. and we will discuss everything about this KillerX All India mock test. Okay, and let's meet in the second All India mock test, which will be taking place on 25th of January. Okay, yeah, thank you very much. Happy learning.